ಇದಾಗಿದೆ ಆಗಿದೆ.
Shubhodaya, good morning. A warm welcome to all of you to the second day of this international conference. May I request all the esteemed delegates and speakers to please walk into the auditorium and be seated here. We will begin the second day of the conference in a few minutes' time from now. Thank you.
ಒಂದಷ್ಟು ಇಲ್ಲಿ ಇಟ್ಬಿಡಿಪ್ಪ.
Hear me, sir? Saha, sir. Hello? Sir, can you hear me? Okay, okay. Yes, sir, yes, sir. Okay, okay, sir. We'll just check the things. Yes, sir, your video is now coming visible, sir. Just one or two slides you can just present, sir. So we'll see if the slides are coming, okay?
ಸರಿ, ಇನ್ನೊಂದೆರಡು ಇಲ್ಲಿ ಇರಲಿ. ಇಟ್ಕೊಂಡ್ರೆ
ನೀರು ಕೊಟ್ಟಿದೆ.
ಇಲ್ಲ ಇಟ್ಬಿಡಿ.
ಇದೆಯಾ? ಇಟ್ಟಿರ್ತಿದ್ವಿ. Shall we start ಅಂತ ಕೇಳು.
Yes, sir. Yes, sir, yes, sir. You can just go to slide, presentation mode, sir. Yeah, it's okay, sir. Now I think it's working fine. So in another 5 minutes we'll start, sir. So we'll just connect with it.
During lunch we will discuss. Okay. Not now. Right. Okay.
Yeah, you can be online, sir.
ಅಥವಾ ಇಲ್ಲೇ ಇರಬೇಕು, ಇಲ್ಲೇ ಇರ್ತೀನಿ. ಅಲ್ಲೇ ಮುಂದೆನೇ ಇರ್ತೀನಿ.
Girish, sir.
ಸರ್ ಅದಕ್ಕೆ ನಾನು ಹೇಳೋದು ಕೊಟ್ಟರೆ ಮೈಕು ನೀವೇ ತರಬೇಕು ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಕುಮಾರ್ಗೆ ಯಾರು ಸರ್ ಹೇಳೋದು ಎಲ್ಲರಿಗೂ ಛತ್ರ ಆಗೋಯ್ತು ಹೂ ಇಷ್ಟು ಅಲ್ಲ ಕುಮಾರ್ ತಗೊಳ್ಳಿ ಸರ್ ಕೇಳಿಲ್ವ ಮೆಂಬರ್ಸ್ ನಾವು ಹೇಳ್ತೀನಿ ನಮ್ಮ ಮೆಂಬರ್ಸ್ ಪ್ರಿಫರೆನ್ಸ್ ಇರಬೇಕು ಆಯಿತು ಆಮೇಲೆ ಪ್ಲಸ್ ನಮಗೀಗ
ಅಲ್ಲಿ ಫೋನ್ ಮಾಡ್ತೀನಿ ರಘು, ಕಾನ್ಫರೆನ್ಸಲ್ಲಿ ಇದ್ದೀನಿ. ಹಾಂ
ಆಯಿತು ಅಲ್ವಾ ಸರ್ ನಾವೆಲ್ಲ ಒಂದೇ ಸರ್ ಇರೋದು ಎಲ್ಲ ಹೋಗ್ತೀನಿ ನೀವು ಹೋಗ್ತಾ ಇಟ್ ಡಸಂಟ್ ಮ್ಯಾಟರ್ ಮೇಕ್ ದೆಮ್ ಟು ಸಿಟ್
ಯಾರು ಕೊಡೋಣ ಸರ್?
ನೀವು ಏನು ಮಾಡಿ ಸರ್ ಇವರು ಕುಮಾರ್ ಇರಲಿ ಕುಮಾರ್ ಇದ್ರೆ ಹಾರ್ಡ್ ವರ್ಕಿಂಗ್ ಮ್ಯಾನ್ ನಮಗೋಸ್ಕರ ಕೊಡ್ತಾರೆ ಸಚ್ಚಪ್ಪಲ್ಲ ಇದಕ್ಕೆ ಏನು ಮಾಡ್ತೀವಿ ಗೊತ್ತಾ ನಮ್ಮಲ್ಲಿ ಯಾರಿದ್ದಾರೆ ಸರ್ ನಾವೆಲ್ಲ ಕೂತಿರ್ತೀವಿ ನಾವು ನೀವು ಕೂತಿರ್ತೀವಿ ನಾಲ್ಕು ಕೊಡ್ತೀವಿ
ರಘು, ಕಾನ್ಫರೆನ್ಸಲ್ಲಿ ಇದ್ದೀನಪ್ಪ, ದಯವಿಟ್ಟು. ಹಲೋ, ಯಾರಿದ್ದಾರೆ ನೋಡಿ ಸರ್?
ಒಂದು ನಿಮಿಷ ನೀವು ನೋಟು
ಈ ಅನಂತರಾಜ್ಮನೆ ಇದೆ ಅವ್ನು ಜಾಸ್ತಿ
ಅಲ್ಲ ಇವರು ಇದರಲ್ಲಿ ಸರ್ ಇದರಲ್ಲಿ ಯಾರು ಇದ್ದಾರೆ ಸ್ಪೀಕರ್ಸ್
ಹಲೋ,
ಒಂದು ಕೆಲಸ ಮಾಡಿ ಲೇಡಿ
ಹಲೋ,
ಲಕ್ಷ್ಮೀ ಪರಮೇಶ್ವರ್ ಯು ಕ್ಯಾನ್ ಸ್ಟಾರ್ಟ್ ಕೊಡಿ ಸರ್ ಓಕೆ ಅಲ್ವಾ ಲಕ್ಷ್ಮಿ ಶಿ ಈಸ್ ಆಲ್ಸೋ ಇನ್ ಟು ದ ಸೇಮ್ ಕರೋಷನ್
ಆಯಿತು
ಅಲ್ವಾ ಆಯ್ತು ಇವ್ರುಗಳಿಗೆ ನೀವು ಹೇಳ್ದಂಗೆ
ಕುಮಾರ್ಗೆ ಹೇಳ್ಬಿಡ್ಬೇಕು ಆ ಮಾತನ್ನ.
ಏನಂತ
ಇವ್ರನ್ನ ಕರಿತಾ ಇದ್ದೀವಿ. ಏನು ಹೇಳೋದು ಬೇಡ, ಅವನದು ಮಾಡಿದ್ರೆ ಮುಗಿದೋಯ್ತು.
You should not interfere. He will become you should see. $3,000 ಎಲ್ಲ ಇದೆ.
ಓಕೆ 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 ಹೇಳ, ಯು ಕ್ಯಾನ್ ಸ್ಟಾಪ್.
ಮತ್ತೊಮ್ಮೆ ನಮಸ್ಕಾರ, ಶುಭೋದಯ, ಸ್ವಾಗತ ಸುಸ್ವಾಗತ. ಇದು ಎರಡನೇ ದಿನದ ಇಂಟರ್ನ್ಯಾಷನಲ್ ಕಾನ್ಫರೆನ್ಸ್ಗೆ ಎ ವೆರಿ ವಾರ್ಮ್ ವೆಲ್ಕಮ್. ಹ್ಯಾಪಿ ಮಾರ್ನಿಂಗ್ ಟು ಆಲ್ ದ ಎಸ್ಟೀಮ್ಡ್ ಡೆಲಿಗೇಟ್ಸ್ ಆ್ಯಂಡ್ ಸ್ಪೀಕರ್ಸ್ ಆ್ಯಂಡ್ ದಿ ಸ್ಪಾನ್ಸರ್ಸ್ ಆಸ್ ವೆಲ್. We will commence the second day of this international conference now. May I request the chair of this panel, Dr. Lakshmi Parmeshwaran, to kindly come over to the dais and occupy your chair onto the dais, ma'am. I also request the co-chair, Engineer Kumar, a leading consultant, to please come over and occupy a seat on the dais. Please come.
ಎಷ್ಟು ಟೈಮ್ 20 minutes, huh?
15 minutes each.
15 minutes each, 5 minutes. Okay. 2 minutes, okay. Canada.
Thanks to the chair and co-chair. Now we request our esteemed speakers and panelists to please come over as I read their names. Professor Surya Prakash ji of IIT Hyderabad. A warm welcome to you, sir. and Dr. Radhakrishna Pillai of IIT Madras.
Welcome, Professor. Thank you. Kindly be seated. Welcome, Professor.
In fact, Dr. Jayant K. Saha was supposed to be with us today. He is indisposed, but his dedication is such that he has agreed to come online and deliver his keynote speech. As we begin, may I quickly run through the introduction of the esteemed speakers. Dr. Jayant K. Saha is an expert with over 40 years in the steel applications industry, that too in the area of corrosion and fire protection. He is presently the Chief Technology Officer at Asiano Biotech and the visiting professor at premier institutes across India. He has authored many books or papers, and he leads the national expert panel of certain committees. He has earned national awards as well. His career in bridges, R&D, consulting, and academia are exemplary, with global engagements in testing, development, and policy making. He holds a PhD, an MTech from IIT Madras, and a BE from IEST. He has a rich experience with HAL, CSIR, CMERI, Philips, and Instack. That's Dr. Jayant K. Saha. Now we go on to the next esteemed speaker, Professor Surya Prakash of IIT Hyderabad. In fact, Professor Surya Prakash's name resonates with innovation and structural resilience in the Indian engineering fraternity. He is from the prestigious Indian Institute of Technology, Hyderabad, and is internationally recognized expert in precast and pre-stressed concrete, and as well in seismic performance and structural strengthening using advanced materials such as FRP composites. He leads the renowned Castcon lab at the IIT Hyderabad, where his work bridge cutting-edge technology research and the field applications for ultra-durable structures are notable. His contributions have not only enriched academic literature with over 100 research papers and international patents, but have also earned him accolades like the ICI Young Scientist Award a few years back. With a PhD from the Missouri Institute of Science and Technology, USA, Professor Surya Prakash brings global perspective to India's infrastructure development. He stands at the intersection of science, sustainability, and structural longevity, making him the perfect voice of today's theme. The next esteemed speaker, Professor Radhakrishna Pillai, is from IIT Madras. He is an authority on ensuring structures stand the test of time. He is from the Department of Civil Engineering there. He has a PhD from the Texas A&M University in 2009, and he joined IIT Madras in 2010 and became a full professor in 2022. He leads critical research in corrosion mechanisms, service life estimation, and cathodic protection for reinforced and pre-stressed concrete fields that are vital for ultra-durable infrastructure. He has authored over 60 peer-reviewed journal articles, holds patents in corrosion control technologies, and serves as a leading contributor to service life design tools and standards. Professor Pillai has earned accolades, including the Outstanding Young Concrete Engineer Award from ICI in 2016 and Excellence in Corrosion Science and Technology Award, NACE India in 2019, reflecting both his scholarship and social impact. In short, he is a practitioner scientist whose work ensures that concrete structures we build today endure the challenge of tomorrow. Ladies and gentlemen, please join me in welcoming the esteemed speakers and the chair and the co-chair, please. Let's applaud them. Thank you. Now, ma'am and sir, over to you for the panel discussion session, please. Thank you.
Good morning, everyone. The first session of today, session 5, that is on corrosion assessment in RC and PSC members by analytical and numerical modeling. and the keynote speaker is Dr. Jayan Saha. I request him to make his presentation. I think he's available online, so his presentation. So I request him to conclude his presentation in 15 minutes. Thank you.
Dr. Jayan Saha, can you hear us? Yes, we can hear you. Please go ahead, sir. Thank you.
started, you all know, you all are proud about our bridge, 1943, and then the latest one, the Kenai bridge. So that is again, it is again a wonder that such a high altitude, difficult area, the various severe climate conditions a bridge can make.
Another question coming up. Please kindly note.
So that is the way we are talking about. Now this is some of the bridges. I am not going into the rating of bridges. The issue is when you will find these bridges are made to survive for 120 years plus life, and at the same time you see there are high strength grades of steel that are also being used for the canal building 410, which is very seldom used in some of the other bridges in India. Now look at this slide, then again a very interesting part you can think of. When you look about any landmark structures, be it a building, be it a bridge, there are 4 pillars for making a building or a structure's landmark. What are these things? The safety requirements, durability requirements, cost effectiveness, and the aesthetic parts. In all these 4 areas, steel scores the highest. That's why we have a lot of leverage to make the structures durable, thus having a choice for the steel as a material for So people sometimes say that when we talk about the high strength grades of steel, so now the world, there is a association, they are in the process of getting 2000 MPa value of steel for the advanced high strength grades of steel. But those steels being explored for the automotive industry. When we talk about the bridge construction, it is limited up to 400 to 700 MPa value because of the good weightability and ease of fabrications and other associated parameters we cannot require for automotive grade systems because they are objectively different. That's why continuously those things have been developed, third generation of iron steel. So when we are talking about the base steel, so it is because of our requirement for the fabrication needs, our requirement for the durability, all those things making us slightly lower level up to 700 MPa value of steel. And then it will be about various types of steels what are being used. I'm just showing you the basic classifications, but in general, the mild steel what we are taking it comes under low carbon grades of steel up to 0.25 of carbon. And when we are adding some alloy elements in places less than 5% for the alloy steel, in 206 to IS there also you will find that a little bit of alloy elements are added just to enhance the property as it is required for our design performance enhancement. So that also we will discuss. Now when you, as a professional, when you go into a tender document, when you are preparing a tender document, how to select the right kind of steel, and at the same time, how to select the metallurgical codes like IS-262, IS-1, 587, and there are n number of manufacturers. They make various types of structurals, various types of plates, whom to buy, so that from where to buy, the sourcing is good, so that ultimately it serves the purpose. So we call it in our language, we call it success, property, performance relationship. That means what type of steel they are looking for, it ultimately the performance is indicated with respect to strength, toughness, the grip, resistance value, maybe impact value, maybe fabrication property, and so on. So all those processes is a very complicated system. Through metallurgical process, we evolve that steel.
Once we switch down, we can't switch it down. Only what we do is after removing that thing, we get it down. We'll get back the whole audio afterwards. This portion we I'll ask them to cut. And balance will keep it. That will do it afterwards.
So this is the rolling process. When you find the slab, billets, rooms are converted into various
No
forms
problem,
of
sir.
structural
Take
grades.
care. We'll go cut
And these
correct.
structural grades are used for the
We'll take
fabrication
out
of
the
these
whole
structures.
video.
And the right side, you will find there are so many,
Whatever
rolling
presented
processes.
data,
We
we cut
call
it
it normal road,
This was we
normalized road,
planned when you told me,
convoluted
then
control
I
road,
discussed with them.
convoluted control process,
Then we said, sir,
direct field
once it is
process,
switched
all
on,
those things
it keeps
are
going.
type of heat treatment.
What
And
we do
that
is,
is to
he told me what we do is, when
property
we
of the material.
get the whole thing, when
You
we
just take to its
cut it
stage.
and reload it off.
This is a very interesting slide. I just delivered
Let us see, sir,
this one just to
how to,
give a very good thought process in that.
कुछ करेंगे
Just
सर,
have a look in this
कुछ
slide.
तो करेंगे for your.
See that chemical composition in all the grades 250 to 550, all the grades you will find the chemical composition is more or less not very much. But at the end you find when the validation of the UPS value starting from 410 to 650 and at the same time proportionately the elongation value also drops. How it is possible? It is possible through the heat treatment process, and there you get this is the key. So when you are writing a tender document, the material finish condition is this. You have to ensure that type of condition is mentioned in the material test certificate. That means if it is a TNC, the thermomechanical control costing is done. So that's how I have put this in the last one. You can see that depending on the thickness range, this type of rolling followed by heat treatment is recommended, and that is the job of the veterinary engineer. So this is very important to understand that although the same composition you keep giving higher yield as well as maybe the carbon equivalent, maybe the lower elongation percentage. Now coming to just different types of structural steels, I am not going to that, you all know. 206 when you add some little other elements to give a weathering effect, we call it 11587 weathering steel. In the technical extent, we include corrosion resistance property. And then we have another IS standard, 15962. The structures include steel resistance, not very popular, but the number of steel companies they are efficient to manufacture this, we have in their code. And in some cases, people are using stainless steel because it is a duplex variety that gets a new. Now, this is a snapshot of the most important code that is used of X2. The wide as well as medium as well as high strength grades of steel is consists of 28 grades to select the right one for good. Now, see the right side, I have mentioned the steel quality increases as you go from A, B, R, B to and C with respect to the welding. And the Chati denotes values also start from room temperature, 0 is 0, degree centigrade, -20, and the place like when the temperature is still lower, then this is customized. So that type of product is also available in the country. And the availability is also increases from A to C. This is again a weatherization steel grades. So for the benefit of all of us, I just to do this. What is this weathering steel? In normal case, the mild steel has got a continuous rusting process because it is corroded. In case of the moisture, electric cell is formed and you get Fe2O3, Fe3O4, like this various type of iron oxide form. Those are rust and loosely sitting on the surface, so it is continuously eating up the material. But in case of weathering steel, it forms a rust, and rust is very adhesive type. It is a very good adhesion to the surface, and it is uniform in nature. There is no porosity in that, and it gets seasoned with the time. And for that you have dry and wet side. So there are certain limitations for the environmental conditions. You have particular formations, and there are a number of beaches in India that people are used.
He was also saying same thing.
So this is like analysis where the corrosion rate how it is compared to where steel versus normal steel. This is the seismic grade. This is again starting from 250 to 300
All
to
wanted,
450. And here you can find the red color.
tell the
YS
next
from the
time we'll
UPS
cut
value
yourself.
is coming in this. That means
At least
UPS
this
by
will cut
YS
now.
you can achieve up to 1.25. If you reverse it, this one
Which way has to
1.8.
follow स्वर्ण लेके जाएंगे.
So this is again some of the ideas go to another 3-4 minutes to have
Certainly, sir.
like finish
वो
this.
दो
So
लाख
these
है.
are the some of the major steel companies, Indian steel plants, the quality is not an issue for them. They have different grades for the bridge construction.
Commercial.
So, and other two codes we follow and IS-800 for design and fabrication. They also, these codes are very clearly mentioned what are the grades and which situation, what type of production protection is provided. It gives a very good guidance. You can find up to C5 or CX environment, you can provide the production protections. And this is again the factor based requirement as per IS-800 and IRC-24. And then again, the requirements for the fatty reactions and the other testing requirements also spread out. The last few slides on these subjects, we were talking about the good material, good design, and at the same time, how to protect the structure, the good fabrication process. So these are some of the challenges. The last challenge is to make the bridge more durable, we need to have a very good solid protection technology. Now, market has got different types of production technologies. You see that we have to find out the production is the site specific attribute. So, place like Chennai or place like Kolkata is not the same. So, we have to understand the severity of the environment, and depending on that, the left side you see the mapping of India's pollution hotspots. So, to design very smarter and build stronger structures. Unless otherwise you know what is the possibility zone of this. So we call it the extreme severe and the coastline, then the severe adjacent to that, moderate, mild and extreme. This is how the coating has to be designed depending on that. So this is that snapshots of the coating for the bridges or areas starting with the left, west, those are carcinogenic that have been banned. 1960, when we are talking about 2020, we are talking about various types of high performance coating, we are talking about hybrid coating, like we are talking about deep metallizing, we are talking about aluminum spray paints, we are talking about ceramic paints on the top of that, various types of smart coating like self-grease coating. Also, and at the same time, the new two processes are coming, when one is the puro polymer coating as well as the ceramic coating. These are the things are in very recent last started. So this is again I am not going into these are the classifications that you will find what is the production grade versus what type of coating and how much durability it will have, that is maintenance free structures it goes for the production or CX climate.
Sir, may I request you to conclude?
Yeah, maybe after 2-3 minutes you allow. So this is the when the pH level is very low, what is happening on that? The structure gets stressed, and then you have to find out the suitable coating system so that you can take up to pH level of so much of acidity or this type of effect. So this is the snapshot of that as per Summer Code 944. There are coating systems in last for 25 years. You can see the CX extreme climate, thermal spray, zinc aluminum coating. What is the hybrid coating? This is the last two slides. The advanced chemically bonded phosphate ceramics. Now we are talking about ceramic this coating, and the top of that, we can have this self-healing coating. That means in case of any leak and marks coming on the surface, it gets covered up like the way zinc provides protection in steel structures. So this is again a new thing. There are certain things minimize the corrosion effect. The designers have to look into this type of a lot of tools are available in the literature that what we do, what we should not do. But the design will increase the design efficiency. And then there are few highest and grades of materials are not used in India but elsewhere as to the list of that. USA, Europe, UK, Japan, China and Australia, what are the grades of the steel? We call it the ultra high strength grades of steel. What are the elements and what are the person protection they are required. So with this, I just made a concluding remark. Steel remains the material of choice for bridges, the strength, durability and adaptability. Bridge construction prioritizes the activity and long-term performance, extreme high-strength levels and the weather institute, high-strength low-alloy grade institute of sustainable low-maintenance solutions. Indian ports like and IS-800 IS-22 aligned with the global standards. So future trend adaptation to the ultra high scale, very efficient processes allowing hybrid protective and city use systems to extreme environment, smart refrigeration, driving safer, longer lasting and cost effective bridges. So it is the future trend of the steel bridges, the ultra high strength steels we are talking about. Till now I have been using 400 chains, so there are chains of beyond 500 steel. Use of weather resistant steel wherever it is possible. There are customization of weather resistant steel also possible in the major producers if your environment is very severe, and then application of high performance coating systems. Thank you so much. I have taken you this board for your question. Thank you so much again, government.
Thank you, Dr. Jayan Saha, for the very comprehensive and very informative presentation on selection of steel and also what is there in for future design, the ultra high strength steel. And you please stay online because we will be taking the questions at the end. So kindly be online. May I request the next speaker, Professor Surya Prakash, to make his presentation, and you have 20 minutes time.
Thank you.
You have very large time, sir. Yesterday only 10, 12.
Yeah. Anyway. Mike, am I audible? Yeah. Okay. Anyway, at the outset, I would like to thank the Indian group of IABSE for having given me this opportunity. And it always gives a great pleasure to be here amidst this august gathering of stalwarts in bridge design as well as the aspiring engineers. Today, do you have the slider? Yes. Okay. You can stage the PPT and keep changing it until that comes on. Okay. All right. So I'll briefly talk about the corrosion assessment and repair of pre-stress members through NDT techniques. And this is going to be, please go to the next slide. Yeah. Is it? Yeah. Okay. All right. So just a quick outline. I'll briefly talk about corrosion mechanisms and what are the different types of testing that typically we use in the field for measuring the corrosion. And we have initiated research on, particularly on post-tension concrete beams to see whether the existing NDT techniques can really help in quickly identifying the corrosion. And I'll present some of the work, ongoing research work on pre-stressed concrete members. Right. Okay, so we all know that pre-stressed concrete system is one of the most popular systems in bridges. If you look at the bridge stock, we have more than 60% of them would be of pre-stressed in nature, some way or other. And we also know that we lose about 5 to 7% of GDP every year due to corrosion, and this is about 110 billion US dollars. It's quite big. And the problem with pre-stressing steel is it's a high energy intensive material compared to that of rebar. So the corrosion products form, but by the time you detect only a little later compared to the normal steel. And the propagation also happens in a rapid fashion. So it's very important that we need to make sure that we monitor them through proper techniques. Otherwise, this kind of, we all know that electrochemical cell forms when you have a water, oxygen, even in the presence of chloride. Then, iron oxides form, and the volume of iron oxides is much larger. It is going to put a lot of pressure on the surrounding concrete. And we know that concrete is weak in tension. Tensile strength is always weak, so it is going to crack, right? So this is the problem, right? So now, again, just quick outline. I think this is again the electrochemical cell. Typically in anode, iron will start giving the electrons, and cathode, hydroxyl ions form, and then you complete the loop and so on. The whole idea is, somehow we have to elongate this corrosion initiation stage by somehow. Either you use corrosion resistant materials, like yesterday we talked about, stainless steel, some of the presenters gave. So a lot of developments are happening even at the material level, what materials which are corrosion resistant. But having said that, what do we do for the existing bridge inventory, which are already built with pre-stressed systems, right? So the moment the corrosion reaction starts, because of the rust formation, the cover starts cracking, and then the corrosion can get accelerated based on many factors, right? So we know that what kind of environment, what kind of the concrete composition that you have, all these factors will. On top of that, the moment cracks come, we know all of that pre-stressed, if it is a crack-free concrete, it is a happy concrete, right? So we always try to design a crack-free system, at least under the service loads, so that your deleterious substances that cannot really enter and reach the level of steel to start the corrosion. So that's the whole idea. But the moment you crack it, then on top of that, you also have a lot of structural load, then your deterioration is going to happen in a much faster stage. Right, so these are all the things that maybe for the benefit of time, I'll just skip. Anyway, so we have destructive testing methods to assess as well as non-destructive testing methods. And we all know that we want to limit destructive testing as much as possible and use NDT techniques so that at the same time, we cannot completely avoid the destructive testing also, because NDT measurements have to be validated somehow through some physical measurements. And we all know that you cannot take so many cores, you cannot take so many rebar samples, right? In that process, you will be damaging the structure. But however, NDT helps you to cover wide area, and it is repeatable in nature, highly cost effective, and so on. Now, what are the techniques typically for corrosion we use? We use half-cell ground-penetrating radar to locate the ducts, locate the PT strands, and ultrasonics, and acoustic emission, and also thermography. So these are the things that we typically commonly use. And typically, these NDT methods have two common mechanisms with which they work. One is a mechanical method, which is called stress wave method. So what we try to do is we generate some form of a stress wave. That stress wave travels in the medium. Depending upon the travel characteristics that we try to sense, we try to see how good is that internal system in the concrete. So stress waves actually travel in solid analogous to sound waves. So you have two sensors typically. You have the transmitter and receiver. Depending upon the time that is taken for the travel, we'll try to infer how good that particular medium is. And these sound waves are actually either it is produced by an impact or a high frequency transducers. And you can see here, depending upon the sensors that I use and the characteristics of the wave travel, if I have a high frequency waves that I generate, typically they will have a smaller wavelength, and the penetration is going to be small area. That means only very small area I can get some information. But however, it will have a high resolution. But if I'm using a low frequency waves, then they're going to have a larger wavelength and it is going to have a larger penetration. So basic idea is how they are getting reflected at these interfaces because of the impedance mismatch, we can understand what is going inside the concrete. Now, electromagnetic spectrum also we use it. And you all know that from the physics, high school physics, as we go into the realm of radio waves or microwaves, you can see that they are going to have larger wavelength. That means they're going to have low frequency. And this can be used for larger penetration in terms of detection. Right. Now, when we try to use NDT methods, typically we use ground penetrating radar for locating the rebar grid, PT duct. And typically, this system can detect more than roughly up to 0.7 meters. When we use ultrasonic pulse echo, we try to use them for voids, delamination, honeycombing, and so on. And we can go higher than 2 meters as well. And eddy current methods, typically your regular cover meters that what we use, the profometer or cover meter, they work on the principle of eddy current. When an alternating current is passed through the probe, it creates a magnetic field. When it is getting contact with the metallic substance, then there will be change in the eddy currents. So that will help us to locate where the steel is actually located. So these are the commonly techniques, but the major problem is I cannot really use one technology. I have to use combinations of them to really get a good idea. For example, if you see electromagnetic waves, they get reflected at steel. So they cannot, if you have a large number of steel rebar layer, I cannot really see past the steel. But however, if air is a medium, electromagnetic can see beyond the air layer. But if you look at the ultrasonics or mechanical waves, they can see beyond the steel layers, but they cannot see past the air layer. So we have to somehow combine multiple technologies to get the full picture. So it's not like one solution is for all the problem, right? Right, so we have to have some monitoring strategies, and typically these are all the common things that we use. Half cell potential, we know that we measure the potential difference from the standard electrode, and that gives only the probability of corrosion. Then LPR, we measure the current, and that gives you the corrosion rate. And advanced NDT methods like XRF has been used now for detecting the corrosion. And then we also have acoustic emission. Again, this problem with this acoustic emission is I need to have large deployment of sensors, right? Then only I can get some idea about how the system is actually behaving. Then we also use ultrasonic pulse echo, and then guided wave is also being used, especially for a thin, long members like pipelines. Typically, pipelines are also now being made with pre-stressed concrete pipes, and they can undergo corrosion, especially if they're transporting water and other chemically aggressive substances. Right, now, this is what it is. So usually, we want to extend this initiation phase. Now, how do we extend the initiation phase? We need to monitor them closely. Either you look at the existing data or do visual inspection. Nowadays, drones are used, and then RGB cameras, thermal cameras, all those things can be used to get some idea. And then the moment it starts cracking, then of course, you can use your regular rebound hammer, ultrasonic pulse velocity systems. And then the moment it goes into, so the whole idea is to somehow we are in this regime, either before the initiation regime or before the propagation regime. We don't want to really go here because prevention is better than cure. Somehow we need to make sure that we don't get into this realm. Otherwise, corrosion is actually an irreversible process. And then fixing at this stage a structure will be very, very difficult. Right, so nowadays I think in addition to that, we also get some samples, and then especially when you're going into this regime, then you take some samples, and then you try to see what is the level of carbonation, what is the level of chloride depth, and so on and so on. Right, so half cell potential, and you all know that typically what we do is we try to connect the standard reference electrode, typically a copper sulfate electrode that is connected to the negative terminal, and your rebar where you are measuring, you cut open it and you connect it to the positive terminal, and then you keep moving and try to see what is the potential difference between them. That kind of gives an idea what is the potentiality for corrosion. Right, so now this is the typical standard values. You know that typically if it is above negative 200 millivolt, that means if it is going to be, we are looking at negative regime. So if it becomes more positive, there is no corrosion or less than 10% probability of corrosion. And if it is going to be less than negative 350 means it is going to be less negative. So it is going to be 90% probability of active corrosion. But the limitation with this method is they don't give you an idea of corrosion rate. They only say the likelihood of corrosion, and the results can be quite erratic depending upon you have surface moisture, temperature, cover thickness, and electrical continuity of rebar, and so on. Now, ultrasonics, we know that also can be used. For example, you take two transducers, right? And then you keep moving along the length by forming a grid. And these are at different instances. This XY is actually plan, and we are measuring at the depth of about 45 millimeter, exactly at the level of rebar. Now you can see from the color, this at certain point of time when the corrosion is not there, this is the location of the rebar. As corrosion is propagating much faster, after a certain point of time, you are not able to really actually locate the rebar. So from these characteristics, again, this is approach one is called compression wave method. We send compression waves and it gets reflected at the interface of the rebar, and some of them will get transmitted. So based on the time travel, characteristics of the signal intensity and the time travel, we can locate this rebar. Now, if you're not able to locate the rebar, that means that at this particular depth, the bar is actually corroded, right? Now, we can also use Rayleigh wave characteristics. This is only helpful for near surface defects. And again, from here, we are trying to see what are the micro defects are there. So if more micro defects are there close to the rebar, that means that at that location, the rebar is actually corroding. So this is one way of doing it. Now, we also use acoustic emission. Basically, these are nothing but your sound waves. So sound waves we try to hear. But these sound waves, when the cracking is happening at the concrete, they will be of high frequency and we will not be able to hear it. So we need to have special devices to hear them. And typically, this is what we do. And we try to use wire band sensors or resonance sensors. And typically for corrosion, we try to use this resonant type sensors that will give us an idea of, basically, again, the elastic waves will be generated because of if some fracture is happening or if some cracking is happening, it's going to give some sound. So that sound waves are nothing but your elastic waves. They will travel. Now, we are trying to hear that sound and trying to make sense out of what is happening inside. So that's what we are trying to do here. Now, with respect to PT, post-tension systems, again, as we said, because the high energy steel and it is going to corrode. So most of the problem will come from this anchorage zones. And this is a case of a unbonded system. But in India, typically most of the applications we use bonded systems. There, if the grout is of not good quality, then again you will have corrosion problems. But the majority of the problem comes from this gap that you put if you don't grout the anchorage pockets and if you have some cracks in the anchorage zones, then your water, oxygen, and chloride can enter and then it can create corrosion. So that's a problem. Anyway, so this is now quickly on what we are trying to do at IIT Hyderabad. Can we use acoustic emission to really identify this level of corrosion in an existing system? So we have fabricated some small pre-stressed post-tension prisms. This is only a first level of testing. A simple 150 by 150 mm section that we took, and we applied some post-tensioning cable. And again, we given some power supply, and now I put some resistor, and then I try to measure what is the current that I am measuring. Again, this will also have a standard cathodic element will be there that will be connected to the negative, and the rebar where we are measuring the corrosion will be connected to the positive terminal. And we put it in a very high alkaline environment with an alkaline solution of 3.5%. And then we say, okay, if you have three types of specimens, uncracked and cracked and notched, what is it that it is doing? So the whole idea is, for an existing structure, same with acoustic emission sensors, can we really try to get some idea whether it is corrosion is happening or not? So that's the idea. So you see here, this is again a setup. Let me just quickly. So these are some three simple specimens that what we have. One is basically uncracked. Another one is a cracked. And we looked at two different crack levels also. And purposefully, before putting it in the alkaline environment, we cracked it. And this one had about 0.3 millimeter crack, but the depth was almost up to 110 millimeter from here. And this, we provided a notch. Of course, as expected, the notch specimen is going to corrode faster. And that, how do we take out of it? So this is a quick results. And you can see that the specimens with the notch, in the solution, you can clearly see a lot of rust formation. and that is what it exhibited, the maximum current flow based on your Faraday's law. You can calculate what is the current flow, and corrosion products can be seen. And this is only for 3 weeks. So this is a very accelerated corrosion test, and this is way that we have kept our sensors. You can see these are your acoustic emission sensors. They keep listening to the sound. When the corrosion is happening, it is going to crack, right? So we want to hear those sound and then trying to make sense out of the data. Right, so this is the sample data. You can clearly see that for the uncracked or cracked, the 2 different levels of cracking, there was no big difference in terms of ultimate strength, right? So there is no big difference. However, if you look at the notched ones, the area of actual mass loss was much higher, and this is a theoretical mass loss that is calculated, and this is the actual mass loss. They were nearly, within the acceptable regime. So it gives us an idea. So now what do we do with this? So basically, if you look at this cumulative signal from these acoustic emission sensors, we can, if we can somehow come up with this value, critical value, for example, here we said 0.25. The moment it reaches 0.25, all the 3 specimens, this is your corrosion initiation stage. So the cracked one started corroding at 11 days. Notched ones really corroded in a big way at 7 days. And uncracked one, it took almost 18 days for it to reach the level of minimum critical corrosion. So from the signal characteristics, now we can get an idea what is the level of corrosion. So that's what we are trying to get at it. Anyway, so this is again another ongoing thing, large-scale testing. Now we want to do, now that the mechanism is working, now we want to do the large-scale testing, and we want to apply 2 different levels of service loads, and then we will employ different levels of corrosion and see whether the acoustic emission system is actually able to capture this corrosion rate. So that's the whole idea. Okay, so anyway, maybe I have a lot of other things, probably due to the paucity of time.
Please conclude, sir. Time is already up.
Yeah, okay, I'll just conclude. This is one important thing that we can see. See, for an existing structure, now there is going to be loss in pre-stress. Now, how do we estimate the loss in pre-stress, right? You know, if you want to evaluate how much is the pre-stress in the stand, it's a very difficult thing to do. So typically what we try to do here is, we cut open and expose this rebar, and then you pull on it. How much force that you require to pull on that cable indirectly will give you an idea how much tension. If the cable is really tensioned, you need to apply more force to pull on it. So this way we can actually get an idea how much is the initial tension. Anyway, so case study is, I'll just probably, because of time, I will skip. But one thing that we would like to tell is, nowadays, even though I'm expert in FRP, we are proposing this, but whenever you have a corrosion as a problem, first we need to address the corrosion, then we need to go for any remedial measure. Without addressing the corrosion, if you're going to put FRP or any other jacketing, over a period of time, that will also come off. So that we need to be very, very careful of. Right, so anyway, with that, I would like to conclude. And I will like to, only one thing that I would like to highlight. So in IIT Hyderabad, we are going to start this course on GFRP rebar by a renowned faculty, Professor Hota Gangarao. For the interested participants, we are also going to do it in a hybrid mode because we are talking about ultra durable structures. And GFRP rebar, in my opinion, is a very good solution if you want a very durable structure. And this course is a 10-day course from August 4th to August 14th. So interested participants actually can enroll and benefit from the expertise because he's a veteran. He has written a book on this and he's from West Virginia University. So I encourage the participants to make use of this opportunity. So with that, I'll stop. Thank you, everyone.
Thank you, Professor Suji Prakash, for giving insights into research, what is happening in IIT Hyderabad on corrosion of pre-stressed concrete structures, both like laboratory studies and also large-scale testing. And also you have given a lot of information on how the corrosion can be assessed in structures, and very interesting work. So we'll be taking the questions at the end. So I request the participants to give the questions in advance so that we can discuss them at the end. So may I request Professor Radhakrishnan Pillai to make his presentation. Sir, you have 20 minutes.
This is forward and this is rear. Sir, I'll just make a disclaimer. Don't mind. Sure. engineer should have a thorough knowledge of the materials science also. What is happening in Indian market? I was headed the design team. अरे मेरा काम नहीं है. Material engineer will do. He'll pass on all the design parameters or the investment parameter to me. I design considering that. So no, that is not the correct. The designer should also have a accounting knowledge about the materials, especially high durable materials, so that whatever you are considering design parameters, which is going to implement at the site without any compromise. That is not happening in India. Please make a note of that. Thank you, sir.
Yeah, thank you for the wonderful presentation about the corrosion control. And I think now we can take a few questions.
Sir, can we just, sir, if you don't, he is already there. Sir, please hold on, sir. Please hold on. He'll just complete and then he'll come back to you, sir. Please be seated, sir. We'll come back to you next. Audio desk, can you please switch on that microphone?
Hello. The quantum of information what we got in this seminar, as far as the three presenters, extraordinary, unimaginable. In fact, you have dug into our lot of questions we had, and that got reduced. And of course, we have the chairs and co-chair, very knowledgeable, practical basically, both the chair and co-chair. Now we are thankful. However, in addition to this message, I have questions for all the three who spoke on this subject. First one is for Jayant Saha.
Sir, can you hear us? Yeah.
Yes.
Yeah. See, I am or any of our engineers, we are all ordinary, regular, civil, structural engineers. We don't want any corrosion in our reinforcement, whatever we provide. Can't we make an alloy which is very high tensile strength and no corrosion except for galvanization? That is number one. And is there any method which has higher durability than galvanization? Higher durability than galvanization with a zinc plus steel is equal to alloy. That is external surface. Is there any other material to replace the zinc? See, even with the zinc galvanization also, you have certain durability of say 50, 60 years. But we need to go for something bigger. This is a quite old technology. Is there anything like that?
Yes.
Yes, sir, that's all.
Yeah, very interesting question. You have asked the first one is how to have durable reinforcements for the RCC. The first one is, we all know that the conventional grades of stainless steel as per IS 1786, it goes up to 550. Normally we are using. The 450 is now, it has become obsolete. We are talking about that 500, 550 grades. Now there are three types of grades are available in the market. Number one is the normal grade. It has a normal corrosion activity. Number two, we call it the copper bearing or copper phosphorus is added to give additional corrosion protection properties against the concrete when the alkalinity starts dropping. We call it the corrosion resistance reinforcement bar. All the major steel companies and some of the secondary steel manufacturers, they have in their kit up to 500, and some people they will have up to 550 grades of the TNT bars. this is the first question to your answer. So that means we have a concentration rate for all the major manufacturers like Tata Steel, RINL, then go for JSPL, JSW Group, and of course steel group. And there are so many secondary steel producers, they also have this. That's number one. Number two, their production resistance index is coming to 1 to 1.5. That means in any type of environment, if the concrete starts degrading with respect to the body of alkalinity, so this will last for 1.5 times. That is the normal activity. Second one, as you said, whether we can get rid of galvanizing. It's very old and still it's relevant, the technology. Now, usually the galvanizing, you have to compare in the structures, what is the durability of the structures we are looking for.
Yeah.
Now, in case of galvanizing, as you rightly said, the 40 to 50 years, there are some structures already in place in India where these customers and owners are looking for 500 years plus life, or if they are looking for more, then you have to go for various type of materials. The material, the type of protection it provides, no coating can provide as on date. So then there comes the hybrid material, we call it the duplex grades of stainless steel. If you calculate the life cycle analysis, there you will find that duplex grades are still cost effective when you are talking about 300 years, 500 years of life. So there are grades are available in India, and we also have an Indian standard for that. So the duplex one, like there are so many monumental structures, like in outside Kolkata, the ISKCON temple has been made with the duplex grades of the reinforcement. That main temple has been made with that, and they are predicting the life to be 500 years. There are few areas where you will find the galvanized rivers are used. Again, the galvanized river, it depends on how much coating thickness you are providing, because it gives the cathodic protections the way that is a. But at the same time, you have to find out what is the coating thickness, and that coating thickness will give you directly the durability of the structures. Now, this is the second option, and the third option. Now there is a lot of hybrid coating have been generated. That means people have started using. On the galvanizing, you can have some sort of organic coating on that, and that organic coating has got a very good addition to the concrete. So that type of options, and there are various patented technologies are available in the country by the various leading institutes who are working on these areas. Those are also can be tried, because they have a lot of source spec tests saying that this may 1000 hours of source spec can withstand. That means even the concrete alkalinity drops, your structures will not be spaced for a longer period of time. That's all.
Thank you, Mr. Saha. I have now a question to Professor Surya Prakash. Of course, Surya Prakash, myself, and many of the stalwarts sitting in the front row here are all the members of the B8 Committee of Indian Notes Congress. We interact a lot. In addition to whatever he was telling about the things here, the corrosion is irreversible process. It is a dangerous statement for us. How to stop at its initial process and the midway? This is my first question.
Yeah.
And my second question, in fact, I am asking for so many experts in the field. See, we use the galvanized strands with grease coating and polymer, whatever we use, even in the Nelmangla flyover here, even Mr. Pillai also knows very well. We used the galvanized pre-stressed strands. Kindly see, when we put the wedges, the wedge is a high strength steel, extremely high strength steel, which has to catch the pre-stress strand. Strand is already galvanized. See, the alloy already formed from the galvanization with the zinc and iron will not be of the capacity of the hardness is that of this wedge. Definitely, wedge is going to punch the galvanization and it goes in.
Audio desk, can you please focus on this? Microphones are not working, please.
Once this wedge goes inside and damages the pre-stressing tendon, then how to manage? Because this question has been asked, because we do this wedge anchorage plenty. Day in and day out we do. And every may not be today, maybe after some time. These two are there in my mind. Professor, you can answer.
Yeah. Anyway, thank you, sir. I think Professor covered the first question. We have to be very careful with your material selection. We have to make the concrete really highly impermeable as possible by using, supplementary cementitious material. That's one thing. Second thing is also careful about nowadays, in the US, I know they are using stainless steel for pre-stressing application. Even the wedges that you're mentioning is made up of stainless steel. So then you can really aspire for 200 years minimum service life. But I think the most important thing is the careful selection of the material and also the execution. And I think, again, Professor Pillai mentioned the grouting. And it's very, very important. If you don't do it properly, you are allowing the entry for deleterious substances, then the corrosion. And it is a irreversible process. The problem is, once the rust is formed, I cannot convert it back to a solid steel, right? So that is a major problem. Maybe we can reduce the loss of section and contain it using sacrificial anode or ICCP method. So many methods are there. But whatever I lost in the form of rust, that is lost. So that reduced area only, I have to use it in my calculations. Yeah.
Thank you, Professor. Hope my colleagues here in the audience, they are listening. It is a very serious statement. Once the corrosion starts, that's all. It is not, you cannot take it back. Now, be absolutely careful about it. Professor, I have one question.
I would like to add to the last question which you had about the anchorages. And I think this is mentioning about galvanic action between the different materials also. But if you can control moisture and oxygen, I think we don't really need to worry much. The problem is we don't control moisture and oxygen. And I think I don't want to see the bulbs at the end on any structure. That is only an architect's, it looks good, but let's be engineers more. And we want to cover it, not with a 1 centimeter thick recess. I have seen even as I came from airport, I was just looking. You will see that many of them has a flat, it's not full circle. It goes like this and there is a flat thing at the top. That means it's not grouted properly. And you have to provide a plastic cap, impermeable, so that no oxygen and no water gets in. That I think is the key in ensuring this anchorage.
And Professor Pillai, I have a third question. I mean, it must be some 1, 2, 3, 4, 5, fifth question. You said about the reduce the cement, whatever the ultra high puff. You said cement, reduce as much as possible cement, add the cementitious materials into it so that whatever the final product must be very good. Now, suddenly when yesterday we had brought this ultra high performance reinforced concrete people here. Of course, good presentation and all. They are also already doing UHPFRC works there. It is based in Pune and they are doing in Nagpur also. Here, they are using 1,000 kgs per cubic meter of concrete, whereas we don't permit at all. No, these are all special, not beyond the. In such cases, of course, they are also using the No, not fly ash. Not fly ash. Yeah, they are using. When they use this fly ash or slag, definitely the reactive silica, whatever they use, the highly reactive silica in that, it will reduce the pH value of cement. 1 minute, please. No, question to the chair. No, question, please, no, decorum of the house is there. Your question, if you raise, if the time permits, then you speak. Then, when the quantum of the pH gets reduced from 14 to downwards, whether we will not, whatever the protection we give it to the steel in the form of the pH will get damaged.
As is mentioned, it won't affect that much, and you still have enough buffer pH in the system which will give the protection for the steel.
Okay.
And you don't, in this kind of systems, the carbonation and the chloride ingress are so low that you don't have to worry that. You are reducing the weight of the structure significantly, and those advantages are much better than these other things we can easily handle. It's not a problem.
Okay.
But one thing that we need to be careful is see the creep, all these effects will be much lesser. But again, the grouting has to be done properly. Again, otherwise the precessing steel, even though we use concrete of good quality, if the grouting is not done properly, and you're not solving the problem. That's a major issue.
Thank you, Professor. Thank you.
Sir,
you want to tell something, please?
No.
Feel right.
No, it's okay. I wanted to mention one thing. It's connecting to what Dr. Saha was mentioning. See, when we select the concrete reinforcement, two things I want to mention this. One is, don't go by corrosion rate alone when you look for a better quality reinforcement, because I am using steel in concrete, and by the time chloride reaches the reaches the steel, it's already several decades. And in my concrete structures, I don't want a state where corrosion started and then I want a low corrosion rate. That's not my design philosophy. My design philosophy is corrosion should initiate at the end of service life. That should be the boundary condition. So looking at corrosion rate as a phenomena for selecting a rebar for putting in concrete is not the right way. What we should look at is chloride threshold and pH threshold, because these are the two major deterioration corrosion mechanism, one because of chloride, other because of carbon dioxide or pH reduction. So those are the factors. So if you see a new rebar, you look for chloride threshold and pH threshold. In addition, you can put corrosion rate as a parameter, not the corrosion rate as the first parameter, because we are not allowing the steel to corrode in the very beginning. That is after the design life. So our system is different. Metallurgical, that is different. Our concrete systems are different. That is one thing. Other thing which, because many practitioners here, many are asking me, I have brown rebar, can I use? Because rust layers are there. My answer to that is, if the rust is light enough, whether you can rub it and go, it will go. If it is atmospheric rust, I think let's not worry about it. And do one thing, that do a proper high spray water wash on the rebar and then use it. Don't worry, nothing will happen. If we say we cannot use, no construction will happen in our country. So we have to, and also this rust, as you vibrate the concrete and as the cement starts hydrating, there are all mechanical and chemical actions which will move away all these deleterious elements which we have. So that is not something which we need to worry. But I'm not saying if you have flakes of rust, don't use that bar.
Okay. Please introduce yourself, sir, before you pose your question. And keep it brief and to the point. Thank you.
I'm Dr. Narendra.
Please hold the mic closer.
I'm Dr. Narendra. I'm GM Planning and Design from Kerite. I have two questions. I think partially it was covered by Rajgopal sir already. When it was mentioned in your presentation that one has to go up to 25% of fly ash to minimize to have, not minimize, to have good resistivity. So is that reactive fly ash or non-reactive fly ash, 25%? Because one is cementitious, the other one is non-cementitious.
Class F, the one which is
Class
reactive.
F. Okay. So,
C, you can go higher.
okay. So class C means already it has got substantial cementitious
Hydraulic
property
nature is also there.
because
so
it
you
is
can-
lignite based. So can I reduce it? That's what my this one is.
Reduce what?
Can it be less than 25%?
Which one? The
The
reactive?
class C ash.
So then no use. You should use more.
Okay, fine.
Yeah, you should use more. The ring. One more thing. We all worry about cracking of concrete, especially when we talk about large size elements. You go and add fly ash and slag, you will have less problem.
Fine. Then could I put it like this? If it is a non-reactive fly ash, 25%. If it is a reactive fly ash, I can go further.
Yes, 40. You can go higher.
40% replacement. Fine. Next, coming to the one more, this one which was.
So
posed
don't
upon
go by exact 40. You do some
Fine.
trials and see.
Design mix. Okay, fine. Yeah.
Huh?
Okay.
Now, class C has both pozzolanic nature
well as,
and hydraulic.
cementitious.
So, it will have, it's okay to go for higher replacement.
Okay, fine. Next, coming to this ultra high performance concrete, which was just brushed upon. See, that particular material is now in vogue. It's been used very extensively in Mumbai region and few highway projects across India also. So they go for really high cement content. Are there any researches where they have gone for replacing it with fly ash or something? Means that's too high. So,
No, but that includes fly ash.
No, there is a rider there. Although the cement content is high and the material used is, cement content is high, the size of the member will be substantially low. That is the advantage with that. So what is your observation on that, and can we go for that?
Yeah, we can
Considering,
go for that.
considering
not for
the carbon
normal
footprint and sustainability.
Yeah,
from
not
that
for
perspective.
normal structures. Also, if you're looking at carbon footprint and sustainability, you should do that analysis not at a member level, but at a structural level. Because the entire cement which you will use and other materials you are reducing. The total project you have to look at, not look at one member and then say I am using this much extra cement per unit volume of concrete. That's not the right way to assess the carbon footprint of UHPC systems. You have to look at the project level because the structural system itself will change when you go for that. Other thing is about UHPC is he has done much more than me on UHPC. We are talking about mixes with 800, 900 kgs, but member thickness is very less. So you save a lot. So there are different aspects, but I don't think we should go for UHPC in normal, regular structures. It's only for special applications.
Fine.
Thank you, sir. Thank you.
Accepted.
I think we are run short of time, sir. I request you to please stay back. You will be right through the day, and you can return the mic to the esteemed chair and co-chair for the concluding remarks. No, we will, sir. I request you kindly, sir. We can take it at tea break, kindly, sir. You can please hand it back, and I leave it to the chair.
Let us thank all the three speakers for very comprehensive and informative presentation. And in fact, it should have been for a day at least, so that
Absolutely,
more questions could have been taken. But I think those questions can be discussed during the tea time. So thank you very much. Let us give them a big hand. So showing our appreciation.
Thank you.
Sir.
Thank you. Thank you. Yes.
Yeah,
Yes, sir.
thank you very much for all the speakers. So now the designer can have the material properties also in mind while designing that. Same can be achieved, adapted in your design, and same can be implemented site. I think you have to have 3 steps. You have to have a thorough knowledge of the materials, switch over to your design parameters, then execution with the same parameters, then performance. All these 4 have to be integrated as a bridge design engineer, especially bridge design engineer. So many designers, they will brought some design parameter which are done by somebody. They blindly designed it, passed into tendering section. This is not the way. So all efforts, yesterday's and today's seminars, these materials properties, designer should have a thorough knowledge and convert it to design parameters. Same thing you will for designs. So give it to your super agency, contracting agency. Those engineers again consider same parameter, achieve your all design parameter and close it.
Thank you
Thank you very
sir.
much.
Now may I request all the esteemed speakers as well as the chair and co-chair to please come on to the center stage. I request the chairman of ING-IABSE, Burji sir, Jayagopal sir and Arvind Salechaji to please come over and do the honors on behalf of ING-IABSE. Nagesh sir, please join them as well. Jay Prasad sir, request you to please join us on the stage. Sir, please move on.
Bani. Don't waste time.
Sir, bani sir. Bani, join them, sir, please. Tea break at 4th floor and 7th floor.
Bani.
ಆಯ್ತು ಕೊಡಿ ಈಗ ಬೇಡ ಆಯ್ತು ಕೊಡಿ ಕೊಡಿ ತೊಗೊಂಡೋಗಿ ಗೋ ಅಹೆಡ್ ಟೇಕ್ ಇಟ್ ಪ್ಲೀಸ್ ಗೋ
All doctors, we are very happy and privileged to get this doctor.
ಸರ್
I'm between the doctors.
Can I request the audio desk to please project the photograph of Mr. Jayan Shah, please, so that we can also see him watching the program. Mr. Jayan Shah.
Mr. Saha's memento will be couriered.
ಆಯ್ತಲ್ಲ Okay, ladies and gentlemen, now you can please applaud the esteemed speakers and the chair and the co-chair. Thank you all so very much. So we have an announcement to make, please. The engineers from the government departments are requested to please make note of your attendance in the list which is maintained at the reception. This will be sent at the end of the day to your secretary and the chief engineers, please. Thank you so very much. Now we break for lunch, for tea, which will be for about 10 minutes. Sir, tea break.
Please listen. Don't argue. Please announce their consent.
carbon emissions by 2050. With a strong belief in the Indian philosophy of Vasudhaiv Kutumbakam, we strive to empower local communities by providing comprehensive healthcare, education facilities, and vocational training for promoting self-reliance and also augmenting their employability. As a proud manufacturer of stainless steel, Jindal Stainless is continuously advancing the landscape of the country with a vision of shaping a truly stainless world. Jindal Stainless, because it's not just steel, it's stainless steel.
Buildings and bridges in India, they undergo severe degradation due to corrosion of using steel rebars as reinforcement. At IIT Hyderabad, we have been promoting a new reinforcing system called glass fiber reinforced polymer rebar, and they are relatively new to Indian construction. However, they have been used in the developed countries for last 20 years. India, with a long coastal line of about 7,000 kilometers and with most of our big cities are located in the coastal region, corrosion has become a big problem for civil infrastructure. And India invests about 5 to 7% of GDP for tackling issues related to corrosion.
FRP rebar is an innovative reinforcement material which is being used as a reinforcement in concrete structure around the world from 3 decades. GFRP can be used in a reinforced concrete structure where steel cannot be used as a reinforcement because of corrosion issues. At Cascon Lab, IIT Hyderabad, we have developed a reinforced concrete system using GFRP as a reinforcement along with the discrete fibers such as synthetic and hybrid combination of hooked end steel and synthetic polyolefin fiber. Main objective of our study is to develop the reinforced concrete system which can deform more when it is loaded under combination of axial load, axial compression and the bending loads. GFRP RC columns or beams failed suddenly because of its brittle nature. These rebars can fail suddenly under the action of axial or combination of axial and bending loads. So we are introducing the fibers, discrete fibers into the concrete so that we can improve the deformability. GFRP is proven to be the most effective alternative reinforcement in place of steel where corrosion is a big issue, where non-ferrous reinforcement need to be used in reinforced concrete structures. And some of the special applications involve soft tie application in the tunnel boring machine or construction of tunnel segments itself. And MRI equipment rooms will be having these GFRP applications.
Safety and serviceability of GFRP reinforced concrete structure is as important as any other structures, and serviceability includes deflection, crack width, durability and vibration aspects. In case of GFRP reinforced concrete, under service load to improve the performance, addition of discrete fibers make the GFRP reinforced concrete more stiffer, and hence serviceable performance of these structures can be improved. And durability, when it comes to durability, steel reinforced concrete structure are susceptible to corrosion and the durability is poor in case of marine environments and any other corrosion dominant environment.
Though these materials have several advantages, they also come with some disadvantages. So by carefully tackling these disadvantages, we can build a more sustainable and durable infrastructure. That is what we are trying to do at IIT Hyderabad. And we are also helping Bureau of India Standard to develop specifications and developing guidelines for helping the engineers to how to use this material for designing concrete systems.
Your projects. Have you found a robust material that stands tall against challenging and corrosive environments? And are you at the forefront of sustainability in the nation's progress? Discover stainless steel, one answer to all your problems. The fastest growing and safest material globally, which is now becoming the material of choice for India's diverse landscape. Still curious why stainless steel should be your material of choice? You see, building a bridge is not just a task. It's giving millions the liberty of an efficient commute. When you connect two parts of the city, it's not just a highway, but the road to progress for a nation. Our buildings must stand tall because they house thousands. Our flyovers must stand the test of time. Our future generations must progress, but not at the cost of the planet. Presenting Jindal Infinity Infra Solutions. Stainless steel solutions for success that lasts centuries. We advise on projects. We customize. We provide fabricated components for ready usage. And we provide world-class stainless steel. Build responsible and sustainable infrastructure. Let's pledge to make progress our shared mission. Jindal Infinity Infra Solutions, where the trust of decades meets innovation from the future. Can our country? A sustainable world is no longer an aspiration. It's a necessity. As sustainability becomes a key driving force in the era of climate change, Jindal Stainless is forging the path towards a cleaner, more sustainable future. With a green metal that is infinitely recyclable. Stainless steel. It is everywhere, from the spoons on your dinner table to skyscrapers, marking the horizons of our modern world. Stainless steel is the metal of the future. Corrosion resistant, durable, strong and light at the same time. Founded in 1970, Jindal Stainless stands as India's largest stainless steel manufacturer and is counted among the world's top 5 players in the sector. Jindal Stainless has an annual turnover of INR 35,700 crore, and we are ramping up our facilities to reach 3 million tons of annual production. We have 2 stainless steel manufacturing facilities in India, in the states of Orissa and Haryana. The company is backed by a robust network of 15 countries and a service center in Spain. along with 10 sales offices and 6 service centers.
Request everybody to please get inside the auditorium, please. We are starting now.
Our product range includes
Girish,
stainless
sir.
steel slabs, blooms, coils, plates, sheets, precision strips, blade steel and coin blanks, all acclaimed for their superior quality. Our company
Namaskara. I think we should start now without any further delay. So for the next session, Chairman, I would like to invite Dr. Narendra, GM K-Ride, to please come on the stage. And Co-Chair Mohan sir, former Chief Engineer, KPWD. Mohan sir, please come on the stage, sir. Girish sir, HR Girish sir, please come on the stage. Okay, I would now like to invite the next speakers on stage. Mr. Samir Sulekar sir, please come on the stage, sir. Mr. V.N. Hegde sir, please Banne. And Alok Bhaumik sir, kindly come on the stage. Mohan sir, co-chair, please come on the stage, sir. Okay, as we are... okay, fine, no problem. Okay, as we are running short of time, what I will do is we will skip the introduction. The introduction we'll keep when we are presenting them the memento. At that time, we will give the introduction of all the speakers. Now I request the chair and co-chair to kindly conduct the proceedings. Thank you.
Good afternoon. So the first speaker is Mr. Samir Sulekar. So I request Mr. Samir Sulekar to start the presentation.
Hello, audible? Good afternoon, senior professionals and junior professionals. Huh?
This is here.
Yeah, just how is it?
What is this?
Fine.
This is
back.
front.
Huh?
This is back.
This
This
front.
is laser.
This is front.
This is back.
I will use only two buttons.
Right.
So thank you very much. It's a beautiful topic that we are having. Conference on emerging technologies for design, construction, maintenance of ultra durable structures. We heard a lot of technologies yesterday, like Internet of Things, machine language, AI, digital twins, how that can help us to make our future structures durable. But there are also, let us come to the ground level. I am basically from the construction chemical industry. And I'm looking at the bridges. I'm talking only about the concrete bridges, I'll be talking. And I'm also very thankful to both our professors, Surya Prakash ji and Radhakrishna Pillai. for giving an excellent introduction, what is corrosion and all. I will not go much into that details. You can all relax because in my presentation, there are no equations, there are nothing to read, only pictures are there. So don't have to take too much stress. So most important thing is today's sustainability. Sustainability is a function of durability. As a construction chemical manufacturers, we have a lot of materials which can make the bridges durable when they are constructed. Example, when you are making an underwater concrete, we have anti-wash admixtures, because a lot of our right from the beginning, and this becomes a danger when we are thinking of leave it for about 200, 300 years. When we build the bridges in sea or deleterious ground conditions, you can also use corrosion inhibiting admixtures. Very simple things, not complicated. Concrete is not complicated. Concrete is very simple. And what is most important thing, if you can take one word, not even a sentence, home today, what is most important thing is the cover of the concrete. When we talk about the durability design, performance-based durability design, we are talking only about the cover. The moment at cover, with whatever great things you have, great type of admixtures you have, you cannot cast a cover. The cover, which is supposed to be your frontline defense, should have maximum protection quotient, but unfortunately, in the reality, it is having one of the worst sort of composition. The moment the concrete, it is breached, whether it is by chlorides or by anti-carbonation, this carbon dioxide, we have problems. And this is the reason. I'm just giving you very few reasons. In uncontrolled permeability formwork, the cover water cement ratio is 0.1 more and cement content is less. So we are having a bad cover to start with. The whole repair and protection is nothing but creation or recreation of cover. It is so basically simple, nothing is complicated. The strength of material, the mechanics, the strength of the repair material should only be about 10% more than the strength of your original concrete. One more thing, concrete is porous. No one can avoid the cracks and the capillaries. These cracks and capillaries are the conduits for corrosion controlling constituents like chlorides and carbon dioxide to enter, reach the reinforcement, corrode it or rust it, very simple thing. The volume expands, you saw from both the professors, 6 to 10 times there was some discrepancy. It exceeds the tensile stress of the cover and the first crack starts. The crack starts, the whole deterioration process begins. As a part of construction chemical manufacturers, you can use the self-compacting concretes. The advantage of self-compacting concrete is not only that it is easy to flow, but it beautifully covers the reinforcement if you see. So there are no water lances below it. And that is the reason why that sort of a concrete can remain for a very, very long time. Secondly, use good quality cover, What is available cover blocks mostly in the country are not tested. We are making, we means the industry can make today cover blocks. We have made for bullet train up to about 80 Newton. And you see the quality of the cover blocks. Cover blocks is your ultimate strength for, that is excellent. This is a process of carbonation. I think yesterday Jai Gopal Saab explained it in a proper way. Environment. The whole service life is in the environment. So then there is this is what happens in reality. Corrosion, and two frightening slides shown by both professors. You could see those structures literally lingering on the brinks of destruction. Not only they were dangerous within 10 years to 15 years. Why do we wait until that time? I think from yesterday, all the speakers and all the people who are present, you know that as our very senior person, Jai Prasad ji said, clean and maintain, inspect, clean and maintain. If you want a durable thing, it's same like your human body. When you become a 40-year-old person, you need something extra. For eyes, you need glasses. To keep the glasses, God has given you ears. Because He has given you ears, you need hearing aids. So you need some extra things to keep you living for 100 years or more than like what Japanese are doing. So this is carbonation. This is chlorides corrosion, which is beautifully explained by both, so I don't have to go in details. The pitting corrosion, which is a very dangerous type. And when there is carbonation as well as when there is carbonation and chlorides, it is like having two villains in one movie, like Prem Chopra and Pran. So that the rate of corrosion, what determines the distress or what determines the deterioration is the rate of corrosion. And I think what you should really check, and not only theoretical rate, but the practical one, only 4 things you have to remember. Nothing more, nothing complicated, simply rusting. We studied in 10th standard. Chemistry, electricity, initiation, propagation. Stop the initiation, start protecting the concrete from day 1. The discussion is over. Corrosion does not get initiated, no question of propagation. So this is what Professor Radhakrishnan Pillai talked about. What is now concerning is the durability of repairs. The durability of repairs is a major problem because if your structure should live for 200 years, the repairs should live at least for 40 years. And this can be very, very easily done. You can see, right from the beginning, your rust. And this is an AI-generated image, but this is very, very important because when you do the repairs, you have to stop the corrosion. If you don't stop the corrosion, because corrosion is a cathodic, this cathode, anode is an electrochemical reaction. At a particular place where the cracks has come or the delamination has come, the corrosion has reached that threshold to destroy that cover. But what has happened is at a place which is very near to it, the corrosion percentage may be about 80%. Now what will happen? This will be excellent. But that portion will start cracking. You'll call the contractor and say, aapne repair kiya tha, wo toot gaya. No, it's not like that. You please mark the places where there is a way to solve it. There are something called anti-carbonation coatings. If you coat the anti-carbonation coatings on the structures, the last step of repairs must be anti-carbonation coatings. Discussion over. Because if you coat the whole thing, then the corrosion, as you said, is non-reversible process, but you can maintain it to that status quo so that no further deterioration takes place. So this is the, how much in 5 years, 10 years, it gets destroyed. And the reason, I would like to only put 2 reasons for that, there are so many reasons. One of them is materials, we are the people to be blamed. You already connected me to the mic? Oh, that's because I feel like hiding behind this. So, this is good. So, you can see here, first is the wrong diagnosis. Second is inappropriate design. Third is the inappropriate specification. In India, I would reverse it. In India, the inappropriate specifications will be 40%. This is international. One more thing. When you ask me questions, if any, please don't say you said. I am not saying anything. These are all copied from some international journals. So I am not responsible, like IABSE said. Waiver. So try to understand, pure workmanship is only 19%. Nothing can happen to material because materials are made in factory. Then the other thing, I think some people present here know it. You say the guarantees. They are asking the manufacturers guarantees. And in one case, we have a case in which we just lost the business because they asked for 100-year guarantees. I could have easily given because I am already more than 70. I will never live for 100 years. But I still, as a matter, I did not give it. It's just very, very simple. I went to a Parsi person who was about 95 years or 98 years old, bending. And he said, how much guarantee? I said, lifelong. He expired within 2 or 3 years. It was not my life, it was his life. Anyway, but guarantees are not helping. What we need is quality assurance system. So this is only what I said. Any repair system designed with predetermined materials in mind will lead to failure. And these are the fundamental things that we should really focus. Now I'll be this is the background, I'll be going quite fast. This is the de Sitas law. If we don't do repair today, it is going to cost you more and more. So I think we should, with limited resources that our country has got, the department has got, we should focus today more on maintaining the infrastructure that we have built rather than going on continuously building. Our asset management systems have to be put in place. We are providing only for the capex. We are not providing anything for operational opex. And then I think it should be more than 50 to 60%. And if you say, maybe it is 100% when you talk about 200 years life. Nothing can remain without maintenance. Now to come back to it, there are also numerical models to do it. This is one of the platforms. You should do all the non-destructive testings, few semi-destructive testings, and other destructive testings to know exactly, and you should do the service. Suppose there is a breach. First thing you have to find out before doing the repairs, how many years is the residual life of the structure? And this can be done today. The more, this is a particular platform called Stadium, which I think IIT wanted to bring, but I don't know what happened. So you can do this but data should be complete. It is not only you take a Smith's hammer and you take one checking something and concrete is condemned. No, you have to do all the tests and then do the real testing of the cores from that site, because every salinity is every condition, and then do the proper analysis. It's a Canadian company. Unfortunately, you have to send the cubes to Canada. I think we can easily do this type of things. Here you do how much time the chloride will take, and if you see here, probably I don't know, it will really give you the time. If you see the down graph, it will give you the number of years for the corrosion to reach that threshold to destroy your
Sulekar, last 2 minutes, please.
2 minutes, it won't happen, but give me 5. I will show you beautiful Rekha's picture, which is more important. Students will be happy, because she is the sign of durability. You see here, no, this platform generates not only what is to be done, but this will give you also which repair system to choose. To get the point, which repair system to choose and how many years it will give with respect to money, the cost, because what is important is cost. I have only finished 13 minutes up to now. Senior citizen 50% discount. So we have got, please follow, as engineers, no adjectives, please follow the course of practice. We have beautiful codes made by stalwarts like Jai Gopal, Hegde Saab, and Alok Saab. We have got complete specifications. EN 1504, it explains every type of repair to be done. The last step is most important to maintain the status quo. Very simple things are there. You said only 2 types of material, 45, 25. When we said we make a grout, it is not necessary. People ask us, give us 80 Newton grout. Why do we need it? Simply give a proper grout which is with a low permeability, flowability, and without putting chlorides. My job is over. Shrinkage, simple way to check this. These are the 4 things internationally specified. We give complicated specifications. That's our problem. Low shrinkage, high tensile strength, enough flexibility, strong bond. So civil engineering is very simple. Performance criteria must replace the prescriptive criteria of specifications. So coming to things, injection technology, you can do a lot of things. There also people ask us, do you have a red foam, blue foam? There's nothing like that. But with this injection technology, you can lift the slabs. You can do so many wonders with it. You can settlement of what is happening in the settlement of the embankments and all these things can be taken care of. It is not necessary to inject, epoxies are not the only things. There are polyurethanes now, external polyurethanes. structural polyurethanes, which are very compatible with the moisture. And this is very important. This one should not miss. What the country needs is a case like this. This was a bridge which was only 12 meters with ultra high performance concrete. Probably this is very interesting. With the same structure, they extended it to 24 meters. Most of the carbon footprint goes in the foundation. No foundation. In Bombay, what is happening? The whole roads down are having foundation to build the metro, and there are no roads left. So this is a beautiful case history. Arch bridges also we can rehabilitate with the injection technologies. And coming to this has got a life of 120 years. Life of the material. So coming to the last point, which will take 2 minutes. You see here, it is durability design. There is an initiation period and there is a propagation period. You can apply the anti-carbonation coating at any time unless it is structurally damaged. So this is what happens. Yes, Jayaprasad ji said yesterday, you see the people trees, the roots are very powerful. The moment you see it, start repairing. What you need is only a good hammer. Periodical, I would say periodical inspection and perpetual maintenance and eternal vigilance is the price of durability and sustainability. One good year, one good eye, and maybe a bottle. Bottle means no, not other bottle. Bottle of phenolphthalein. No, just please be serious. So this is the anti-carbonation coatings. Recreation, this can be calculated. Engineers need calculation. This can be calculated. The equivalent cover can be given. This is how it is calculated. So, sir, most important slide. So, if there was no protective coating used by, well, she's the one who has proved it today. I saw her dancing the other day at 82 or 83. So, and she would have happened like this. So every time you see a bridge, please, okay, these are the specifications. It should have different type of breathability. The water inside should be able to evaporate so that the concrete becomes dry. Yes, sir. Test about 18 tests. Feel the blowholes. हो गया सब. Thank you. आ गए. Yeah. No, let them see anti-carbonation coating. They look good also here. Color. This is in Kerala, and one is Hyderabad probably. We did the first Hebbal bridge here, long back. So this is finished, sir. So forget everything. Protect your concrete, and steel will take care of itself. So simple. Very small conclusion. Factor of safety is this. Be careful of safety. Don't do this. Don't be oversafe. Thank you. Let us build together.
Thank you, Mr. Thank you, Mr. Samir Sulekar. Thank you for the presentation.
18 minutes.
Yes, sir.
Good.
No, I correct you. It's 19 minutes.
Huh?
Yeah. The next speaker is a well-known speaker, Sri V.N.
Time difference.
I invite Mr. V.N. Negde to start the presentation.
I'm sorry, I did not say. I think you'll have to see yours.
No, thank you very much. So I think the introduction is going to be done by during the momento, so I don't take the time to introduce myself. So far we have been having, theoretical talk. As the conference progresses, normally come to the case studies. Basically, we are going to have in this particular session couple of case studies, and one on the rehabilitation of the concrete bridge, and the other is on the rehabilitation of the steel bridge. The first one, the rehabilitation of the concrete bridge, I'm going to talk about. I have chosen this to suit this particular theme of the seminar or the conference. That is, goal is to achieve the 200 years of construction life, service life for the bridges. That's what the goal of this. In view of this, the revision of the codes which has been taking place, I think that many of the bridges require the seismic retrofitting, which is required because the seismic demand is going to increase quite a lot if the
the present code, seismic code, which is under the revision, really gets implemented. And I've chosen a case study over here, which is, in a way, can be adopted to the seismic retrofitting of the future bridges if this code is implementing. In a way, it is the prolonging the life of a structure, but in this particular case, it is not because of the seismic demand the retrofitting has to be done. But in this case, which I have chosen, the retrofitting during the construction itself was necessitated. The retrofitting of the foundation, retrofitting of the substructure, that is pier, retrofitting of the superstructure. So it includes everything. It is like, retrofitting the structure for the seismic, additional seismic demand. That's why I've chosen this one. This is a story of a longest span cantilever girder bridge, which is constructed in India, which took 20 years. It's a story of a Bakchal bridge in Himachal Pradesh, as you can see here. A beautiful bridge. Ultimately, when it was constructed, you can see around here, the bridge was having a hiatus of around 8 years in between because of the geotechnical surprises which was encountered during the construction, as you can see here. Now, this is a bit, I just go to the, I'm sure that I'll be given a lot of alarm for the time, that's why I don't want to waste a lot of time in explaining certain things. This is a general arrangement of the drawing. It's a 185-meter central span of a cantilever bridge, which is the longest cantilever girder bridge in India. When it was conceived during the tender stage, it was around 60 meters on one side of the abutment and the 72.5 meters on the other side of the abutment. And the foundations were at the precipice of the cliffs, as you can see here. On either side, the original founding level was around 460 meters on either side. Finally, it got converted to a drilled shaft foundation, as we call it, at around 474 meters. At that particular point of time, there was no guidelines for the design of the drill shaft foundation as far as Indian consideration is concerned. Original design was envisaging the independent two foundations that you can see, which was merging into the superstructure, and it was, after the award of the job, it was converted into a plate pier because there was no ledge at the location of the foundation to accommodate these two foundations, as you can see here. Interestingly, these two foundations were to be constructed only during March to January because it was on the backwater of Bakranangal Dam, which is called the Govind Sagar. And we had only 4 months, as you can see, of March to June. But in principle, the working window available was around only 3 months in principle for that purpose. So that is a bridge, as I said. And when the river reservoir is full, normal reservoir level normally used to be around 514 meters, as you can see here, and the 580 meter is the HFL, since it is a Bakranangal dam, as you can see here, and the top of the foundations were around 482 meter, that is RL 82 meter. Just imagine 514 meter to 482 meter, that's around 18 plus 14, that's around 30 to 35 meters. It's always a standing water is over there in this particular. This is where the foundation has to be done. Basically, this is where the foundation has to be done. You have got around 3 months to construct this foundation. So the design of the foundation has to be done in such a way that it is possible to construct this foundation, because the contract period is already defined in the contract. You cannot do anything about it, and no client would like to compromise on the contract period which they have got. So this is the location of the foundation, as you can see here, and drilled the shaft foundation, which was thought because to mobilize the equipments, plants and equipment for the deep foundation like the pile foundation and well foundation is very difficult because it was the precipice of the cliffs, as you can see here on either side. So we had to have approaches made on one side. We made approaches on the one side. It is planned to make an approach on the one side. That is on the P1 side. And from that, the equipments and the plants have to be transferred to the another location through the barges, basically, because on the other side, it was not possible to have there was no approach road in principle. That's how it was planned. So the drill shaft foundation required only the excavators as well as rock hammers. If it is a rocky strata, is there to excavate it. And it was around the 8-meter depth in case of the P2 foundation, and it was around 6-meter depth in case of the P1 foundation. So ideally, the drill shaft foundation was found to be suitable on the basis of the geotechnical investigation, which revealed around 4,000 to 5,000 ton per meter square of a strength of the rock. That's why it was conceived in the beginning stages. These are some of the views of the construction, as you can see. However, in the first session, when on the P2 side, when the next season came after the construction of the foundation, because once the foundation is done, only in the 3 months you cannot do the work. The water is full. We'll have to wait for another season, March, and till that time. On the other side, especially on the P2 side, it was sort of felt that the rock may not be competent because there was some erosion of the soil on the one side of towards the river side of the foundation. So what we did is to strengthen the material, the strata there on either side, P1 side as well as the P2 side, as you can see here, we did the pre-stressed concrete anchors, it is going into that, some of the plans. This is the elevation, as you can see, elevation in the sense front side of the elevation, and here it is, to what depth it is going, it is just, let's assume. And while doing the pre-stressed concrete anchor, especially on the P2 side, we found that the rock was disintegrating, even when we were doing the pre-stressed concrete itself. So we got alarmed, this is a situation, and at that time, a couple of mishaps of the company's execution, which I was involved in, also took place, and I said, I think we cannot go ahead with this construction now. And we stopped this construction, and we did the re-evaluation, redesign of the entire superstructure, assuming on one side there is no passive resistance or the rock resistance which is available, socket resistance for the pier, the foundation is not available. And on the other side, we felt that, it was not a disintegration. P1 side seemed to be competent in rock. There was no problem. So that's how we did this, this particular, this one. And when we did this, we found that it is possible for us to go ahead with the work only by another 2 to 3. Already by that time, by the time it happened, we had already constructed the piers and the cantilever, construction on either side of the pier, either side of P1 and P2 had already started. Then we came to the conclusion that we can go ahead without considering the socket resistance of the shaft, excavated shaft, only by a couple of segments, especially on the P1 side. We thought that we can go up to the 6 segments. On the P2 side, we can go up to only 4 segments. That's what, without considering the resistance of the socket resistance. We did that, and we stopped the work, and the further investigation started. How do we? We are in a situation of rehabilitating the bridge during the construction itself now. That's how the situation there. Very interestingly, and there were various alternatives were examined, and Dr. V.K. Raina happened to be there in Himachal Pradesh. She was giving a lecture and training the Himachal Pradesh PWD people, and the work was stopped, and we didn't know how to go about it. We gave a lot of alternatives to go ahead with that, but the clients were not happy with that. And at that particular time, they took Dr. V.K. Raina. He's a very good friend of mine. In my opinion, he's a maverick and very, very intelligent, and he has written authority in the bridge engineering. Many of the books, in fact, we all grew up referring to his books when the working stress design of the bridge was being done. And a lot of interaction I had. He's a good friend of mine. And incidentally, my my colleague here, Mr. Alok Bhaumik, started his career with Dr. Raina, and his contribution also come here. I'll come to that later. Raina explored a lot of alternatives, along with us, like that's we as a designers and he as a consultant to the client. Raina doesn't have people to really do the computations, so we give the support to him and the computations and analysis and kind of thing. He gave it a solution first. As far as the P2 is concerned, P1 is concerned, P2 is concerned, he said that like you can have the competent rock is available all around. There is no problem. The drill shaft is working. Nothing to be done, but to be on a, abundant, as a matter of abundant precaution, what you can do is to take the momental action. When the vertical action is resisted by the friction as well as the end bearing, to take care of the momental action, accidental momental action which then comes, we'll go for, like 16 number of 19K 15 priestess concrete acres going through this a shaft. It is though it's called a drill shaft, it's an excavated shaft in fact, and going up to around 17 meter below, 88 meter below, and not much, like just to take it, calculation was done. It's a measure of abundant precaution because it was already working. That is as far as the P1 side is concerned. I think, yeah. But the P2 side, I said that, it was not having a competent rock. That is also pointed by Raina. Dr. Raina came out with a couple of suggestions. The first alternative was to have micro piles, as you can see here, all around, integrated with the pile cap on top of the shaft over here, and integrated to the pier also, so that the momental action is completely transferred to this micro pile. Mind you that the micro pile guideline is not available in our country. Many of us are IRC 78, all of us, many of us are here. I think we'll have to bring out one micro pile guidelines. And, but he himself was not happy with this proposal. Like after having spent 1 year on this proposal, he said, see, Mr. Agda, I'm not happy with this proposal because I'm not sure whether the integration, the moment transfer mechanism which is being integrated with the pile cap to that of the pier is correct here. I'm not sure about it. And he's very, he was also not sure the load sharing between the existing shaft as well as this rehabilitated micro piles over here. I'm not sure about it. I would like to go for another solution that you work on that. He said that is, I would like to go your micro pile through the existing bulb, like that pressure bulb itself. Then I'm very sure that the load transfer is, taking place, and it will be acting as a pile cap, a rigid pile cap. Your shaft will be acting as a rigid pile cap, and he had the robust truss which is embedded in the concrete and integrated with the pier as well as the vertical pier cap here, as you can see here, and almost around 62 in a various direction. As you can see here, one is in the transverse direction, some of the piles are in the vertical direction, some in the longitudinal direction. This is around 300 diameter micro piles, and he said that it has to be, I am sure about the load transfer over here, and also I am able to establish this proper mechanism of transferring the load from the pier to this one. In this contract was, for a river bridges, our IRC 78, that time was saying the minimum diameter should be 1.2 meter dia piles. The client said it is not satisfying the contract condition, that is 1.2 meter diameter pile. You cannot go for the small diameter pile because it is the original design. You may say it is a rehabilitation design, but it is not it's an original design. We would like to have 1.2 meter diameter pipe. Now it is changed to 1 meter, of course. And also another problem in the design of the 300 dia piles, the small diameter pile here, which is referring for the design, structural design, and the geotechnical capacity design to this IRC 78 in turn. Unfortunately, there is one clause in this particular clause that it says that the friction capacity should be further limited to the depth of the 6 diameter of the pile. You have got a micro pile, a small diameter pile, 300 dia. It is socketed into the rock. 300 into 6 times is 1.8 meter. This clause is, in fact, unfortunately, it was introduced by myself and Dr. Naik 20 years back. Now it is hurting us. It was hurting us actually in the clause. It was a mistake. Actually, the idea was when in this particular class was introduced, normally we have a socketed pile. That is at the, there you got an overburden below that socket is there. That socket length should not be more than 6 times the diameter of the pile. But not for the, completely socketed pile. Completely socketed pile gets its capacity from the friction capacity as well as the end bearing. That is not applicable to that. But they said that this particular clause says you can take the capacity of the micro piles with the 300 diameter piles, only 1.300 into 1 point. That is, I think the whole purpose is on this ground, this particular proposal of Dr. Raina, he was very furious, in fact, and he said this, he said that. I think it is applicable to many of the rehabilitation. I think here is a lessons to learn here. And for Dr. Raina's statement here, one does not have the luxury of designing such foundation from scratch. We must work with the patient, the existing compromised foundation, and devise solutions that are both structurally sound and practically constructible. Even if this means deviating slightly, yet safely from codal norms. You cannot just appear to. In such engineering exercises, conviction born of experience is paramount, often requiring a calculated risk and hard choices, where in the end the boldest solution should prevail. That's what he said, and he signed off, saying that I'm not interested in continuing with this sort of this one. So, but we are left with, we'll have to find a solution because it's almost this one. Then similar grounds on the P1 foundation side, there was no problem. Instead of having 12, 16 anchors, we designed with the 17. Here I'll have to say that here is where the dramatic entry of Mr. Baumik took place. Baumik came into the picture. Dr. Raina, gave into the back seat. His disciple, Baumik, I think, who started this one. Baumik was engaged by the client as a proof-checking consultant to find a solution at this particular point of time. By that time, 6 years had elapsed. The work was stopped. And as far as the P2 is concerned, P1 is concerned, I think the Raina's proposal was acceptable. Only thing is, which was done was we reduced the number of, on the basis of the calculations, 7 number of, only the precious concrete anchors was done. It was embedded into the rock almost around 17 meters below the shaft foundation. And also we developed another some sort of a shaft on top of this existing shaft to ensure that there is a proper bonding, proper integration between the existing pier, because on the basis of the revised analysis, we had to jacket this pier also. I'll come to that, because whole boundary condition is changed. Now it is additional thickness as there. I'll just come to that later. So it was accepted, we went ahead with it.
Sir, 5 more minutes, sir.
Yeah?
5 more minutes.
5 minutes, I'll just try to complete. So as far as the P2 is concerned, we came out, we said that, okay, fine, that you are not going to have this micro piles. We went around with the 8 number of, the 12 number of the 1.2 meter there piles. As you can see here, this is 1.2 meter, 30 meter depth, completely bereft of this existing shaft foundation, neglecting this shaft foundation. We had around 3.5 meter pile cap on top of that, and fully integrated with the pier through the pre-stressed concrete pier cap. And this pre-stressing was going through the pier. This is I have put it, rotated this pier cap and put it over here to accommodate this particular slide over here. This is the pre-stressed concrete 19K15 pre-stressed concrete anchor, pre-stressed concrete strands. It was completely pre-stressed. It was integrated. 30% of the steel, pre-stressing steel was going through this pier, as you can see here, including the reinforcement at the bottom of the pile cap over here. And this integration was achieved, and 30 meter, 1.2 meter pile cap was done. This was the final solution. It was satisfying the requirement of the contract also now. There was no issue as far as the clients are concerned. And at the time of this, because of the boundary condition has changed, geometry of the bridge has changed. When we did this bridge, now in this particular location, at the P2 side, it was at the P1 side, it was possible for us to really extend this. If you really look at it here, this particular slide, make it symmetrical. We did it 12.5 meter and 72.5 meter and 72.5 meter. So this introduction was there. When it is introduced, and also when you are putting the 3.5 meter pile cap over here and 2.5 meter, this one here, whole geometry of the bridge has changed. The stiffness boundary condition has changed. When we did the reanalysis, it was necessary that we'll have to do the 300 mm jacketing all around the pier. It was necessitated. And at that particular point of time, we did not done the ductile detailing also. I know it was not required when it was designed first time in 2000 or 2006, but even the ductile detailing could be also, included in our revised design, as you can see here. At the end, to take care of the uplift, earlier we had the girder which was going inside the abutment. We have gone, this neoprene pad. As soon as the uplift was there at the end over here, it was coming up, and it was resisting. That was the kind of arrangement we had. We completely changed it in the revised design. We went for, put the dead load, sufficient dead load on either side of the cantilever to counter the uplift which was coming over there. So that is how the revised design was done. It was very important to ensure in the jacket is completely embedded into this, like the pier table, which was over there. Not only at the bottom, also the integration of the jacket that was properly ensured. Mr. Bhomik made sure that all this integration of this one is done. This is a theory of the interface shear, which is coming because of the additional shears, as well as the additional bending moment. When the interface shear, you'll have to take care of that. That's how the design of this was done. And the superstructure also had to include many external pre-stressing cables, actually speaking, because of the revision of the design. It was not sufficient. We introduced some of the external pre-stressing. It is possible to take the internal pre-stressing up to the 12.5 extended cantilever pier also. So I think we introduced this already. It was the first bridge conceived with the combination of the internal pre-stressing as well as the external pre-stressing when it was conceived, and there was sufficient the space for accommodating the additional strands in the external pre-stressing. We increased that external pre-stressing strands also. You can see here, this is the location of the external pre-stressing, as you can see here, and that's how it is. Now, these are some of the construction views. This is the anchoring of the P1 foundation is going on, and the pre-stressed concrete anchoring, all of you know, I don't want to spend time. This is a load testing of the PSA anchors on that side, and after that, once it is done, on the P1 side, you can see the construction of this shaft on top of the existing shaft, and then the jacketing, which is in progress. And also, like when we did the cores, like to do the pre-stressed concrete anchors, I think these are some of the core qualities, which was beautifully, captured, and the concrete was very good condition, as you can see here. The challenge was the construction of this, the hybrid foundation, shaft plus pile foundation on the other side. That is on the P2 side. There was no road. And now we had to move everything from on the other side.
Sir, 2 more minutes, sir.
I'll finish it in 2 more minutes. So on the other side, we had to bring this 44 kilometer, all this equipment, RCD equipment was required for doing 30 meter piles in the rock, and also the cranes were required. All has to be brought from 44 kilometer. It has to be transported, make an additional road here. A road has to be done in a step fashion. All of you know. You have to bring those equipments, all this equipment in this location. Hill also had to be cut to accommodate this particular foundation. These are some of the views of how it is transported to the location. Very tricky condition, as you can see here. And this is how it has been done. The same explanation is over here. Some of the views of here the combination of the RCD rig as well as the conventional method as well as the hydraulic rig has to be used. It was not easy for us to do that rocky strata to do the pile foundation. First, we used the hydraulic rig up to 8 to 10 meter. Then below 20 meter, we had to use the RCD rig. So 2-3 types of the conventional as well as other methods also used. And this is the pile cap, well cap, the pile cap construction. This is the location of the pre-stressing. It was constructed in 2 lifts, as you can see here. And this is the construction of the jacket. And this is a cover meter test, Dr. Surya Prakash. We have to do it to find out the location of all the, like reinforcement, so that the anchoring of the piers and other things can be done over here. And the construction of the balance superstructure, we took it out because of it was standing position for 8 years, and entire NDT was to be done, half cell potential test to find out whether the initiation of the corrosion has started in the pre-stressing stance. Those has to be done. After having done all these things, after repairing this, even the form travelers, which is in the existing condition over here, completely refurbishing and load testing, I think the work started. As you can see here, we had to have one treasure support for the balance cantilever construction to go on at around 8 segment on either side. And after that, the balance cantilever construction went up to the 12th segment over here, and the free cantilever construction continued over here. The bridge construction carried on, and finally, you can see the beautiful bridge over here, standing 185 meter. In conclusion, I think I would say that this is a very good case study for us. I think we are getting ourselves, we thought when we are doing this, in view of this revision of the seismic codes which is undergoing, which is going to have a lot of seismic demands. I think this could be the one of the way of retrofitting the foundations, retrofitting the substructure, also the retrofitting the superstructure for the existing bridge in the future to achieve that 200 years lifetime. Thank you very much.
Sir, for the wonderful presentation, I would like to invite Mr. Alok Bhaumik as a speaker.
Yeah. Good afternoon. It's very difficult to speak after such an excellent presentation by my colleague, Mr. Hegde, and by the chairman, session keynote speaker, Mr. Samir Surlakar. The topic which I have chosen is a similar rehabilitation scheme of a railway bridge, a very old bridge and very renowned bridge actually in Bihar. That is a Mokama bridge. And I think it's very difficult to see that side and, speak. If I need a collar mic, yeah, that would be helping. Which is a forward one?
This is the forward, this is the back, and this is the laser.
Okay, thank you. So, this is the broad content of my presentation. I'll try to make it faster because I have a limited time. Otherwise, I can have a 1 hour lecture on this. So first, let me give a little bit of background of this project. This is a bridge which was constructed way back in 1959. Prior to that, the only bridge over river Ganga was available at Varanasi, that is Malviya Bridge, constructed in 1887. And there was a bridge presently in Bangladesh, those days within India, at this place, which is called Harding Bridge, constructed in 1915. So, and this distance is about 1,000 kilometers. So there was no connectivity in Bihar till this bridge is constructed. That was the significance of this bridge. And because of this non-connectivity, the northern Bihar and the southern Bihar was completely alienated. Northern Bihar was suffering from droughts, the southern Bihar was suffering from floods, and so situation in Bihar, socio-economic situation was pretty bad. So there was a need, and the bridge was conceptualized in 1954 and finally executed and opened to service in 1959. And the person in 1956, it is Mr. M.J. Hempton, who was appointed by the Railway Board to investigate and look at the best site, and he chose this site. That is a bit of background. The bridge is about 1.7 kilometer long. It has 14 spans of about 123 meters, which is a trussed span, you can see. But at the end, there are 2 spans on either side, which is about 35 meter span. And this one is a double intersection Warren truss, these 14 spans. And these are simple built-up section on the 32 meter spans. Mainly, my focus will be on the central main trussed span. This is the cross-section. It's a rail-cum road bridge. You can see the bottom, the rail is we are having the rail traffic, and at the top we have the road traffic. And this is a view from the bottom showing the rail track, single track, and this is a view from the top of the deck showing the road traffic. This is the detail of foundation. It is a well foundation, double D well foundation in concrete, and it has got a framed type, twin circular pier and a frame type, a very robust. If you see the dimensions vis-a-vis today's scenario, it's a very robust kind of a substructure, and all made of concrete. Of course, those days concrete used to be coalcrete or M20 concrete, things like that. This is a very interesting story. When we were asked to do a structural audit, that was last year, 2023, we were at a loss as to how to proceed because we had no information about this bridge, and the railways only could supply the as-built drawings, nothing else. So we were hunting for information, some papers related to bridge, and in the process, I approached one doyen of civil engineering in India, Mr. Ghoshal, because I thought if there is a steel bridge, Mr. Ghoshal must be having information. So I approached him, and he said that I don't have any information. I have not worked in this bridge, but there is because this was done by Freeman, Fox and Partners, British firm. He says generally the Britishers have the habit of, end of the project they write papers. And one can search the Institution of Civil Engineers library where you will get that. Now, Institution of Civil Engineers UK, I am not a member. So he says there is one gentleman in Kolkata who is an ICE member and representing in India. You can approach him. So I approached him in the evening. He was kind enough to give me his mobile number. So I talked to him, and he says, let me search, because those last year I'm talking about, or Institution of Civil Engineers, all the journals were, in the soft mode, available readily. So the next day morning, I am surprised that I get a paper from that gentleman, from Institution of Civil Engineers. This is a paper, you can see, written by, one Mr. Turley, who was there, a senior engineer, Freeman Fox, Mr. Savarkar, who was the HCC. HCC was involved in the construction of foundation. And there was one from John Williams, who was representing BBJ. The BBJ was involved in construction of the superstructure. And of course, from some person from the project manager construction. And normally those days, any paper is followed also in the next issue of the journal, a discussion. Because every paper is actually discussed, and during the discussion, who has told what is the view, and then the reply by the author, that is also very well covered in another paper, which is a discussion paper. And together, these two papers have given enough information to me, which made my job much, much easier. So, and another thing I want to mention, that the as-built drawing which I received from the railways is something unique, which today's as-built drawing, we do not have this information. This is a typical as-built drawing where they have given a chart where for each load combination, what is the load of superstructure, superimposed loads, the pier load, pier cap load, everything, every details of the design is reflected in this particular chart. Not only that, even the sequence of construction, what is done is covered here. This is as-built drawing, they call it as-built drawing. In addition, for the foundations, the as-built drawing also reflected what are the important dates, when the well curve was grounded, what was the average level of cutting edge, what is the tilt and shift. If each and every foundation, this information is recorded in the as-built drawing, and which today it's a learning for all of us, because the as-built drawings that we produce nowadays, we do not give these informations. So, foundation, it's a double D well foundation used with plant dimension of 16.3 meter by 9.75, 55 meter deep. Concrete grade bottom plug is 1:3:6. Steening M12 and M20 equivalent and well cap. These are all volumetric mix. So that's why I mentioned equivalent. And well cap is M20 equivalent. Substructure RCC twin column 4.57 meter dia. These odd dimensions is because those were in feet converted into SI system. Concrete grade M20 for the pier substructure. The design was based on IRS code only, not based on any British code. Those days, railways have had this codes, 1941 publication, 1936 publication, and 1941 steel bridge code. These were followed. A bit of history of rehabilitation. We collected some information about the past history of rehabilitation on this bridge. Railways had this data, fortunately. That was also very heartwarming. And what we found is that the East Central Railway carried out some repairs already in 2010. And they have also put it in a nice form. And for the approach two spans, this is some of the members had to be replaced, and mainly because of the distresses that they have noticed there. And on the main bridge, also some elements have been done. Existing cross-girdle webs were strengthened, you can see, for the main span, but not much repair. After that, also they observed some distress, some cracks in the main bridge, because railways their inspection is very, very regular and frequent, and they have an inspection sort of diary maintained, so they are very particular about it. So they appointed CSIR SERC to do a thorough structural audit in 2011. They worked for 5 years. They completely analyzed this structure, and there were some problems identified in the cross girder which was supporting the highway deck at the upper level, and this was diagnosed by them, and they realized that in the deck, there was a detailing problem at the expansion joint of the highway deck, which caused some torsional moments on this particular cross girder, and that was diagnosed as the reason for cracks. So SERC, they proposed that all these cross girders be replaced by a box section, and that would solve the problem. In addition, there were some problems on the main railway stringers as well, and they they have done a very detailed analysis, and I don't want to read these documents, but based on that analysis, they have given certain proposal. But all those proposals given by SERC was not really followed by ECR, East Central Railway. They have their own review process, and based on those review process, they have carried out the damaged road cross girder at the stringer expansion joint location has been replaced. They did not do box girder, they replaced by eye girder only instead of proposed box section, and the stringers are made continuous. So there was an expansion joint which they realized that the expansion joint can be done away with at the deck level. So they removed the expansion joint, and that decision was taken. In addition, the main span rail cross girder has been strengthened at its mid span, both at the flange and at the web. So very interestingly, what was found is, you see, the stringers connecting the cross girder at the rail level. At the rail level, on the two rails, just below that, there were stringers. And these stringers are spanning between the cross girders. And these stringers are simply supported. That means on one end it is free and other end is fixed. And they started from the end, and at the middle, exactly at the center of the span, the cross girder had both fixed. And when they fixed it in the original design, they fixed it as a moment connection. And that resulted in cracks. And very interestingly, when we inspected, all the central cross girder connection had exactly similar problem, and that was very clear that it was related to the detailing. And this was recognized by us during our process of scrutiny. Now, our role as structural auditor, structural assessment, estimation of demand, estimation of capacity and fatigue life. We were asked to first calculate, check whether the structure is safe as per the original design which was done in 1959. B, we were asked to also assess based on the revised loading, revised seismic loading. Also the railway loads have changed. And C, we were also asked to calculate the residual fatigue life of the structure. So these were the three tasks which was assigned to us. First, on the loading part, as far as the original design and the new design is concerned, we noted that there was some minor change in the dead load of superstructure. This change is mainly because the track originally it was a timber plank which was replaced by concrete planks. So there was about 50 tons extra load, not much. 1500 to 1550 is not a very big change. As far as the railway live load is concerned, earlier original design was with BGML 1926, but the new design load was 25 ton, which was plying actually. So that resulted in some change in the load. Highway live load also 70R loading is added later, which was not there in the original design. Seismic load has changed significantly because 1959, it was just a coefficient, some 1.1 and 0.05. 0.1 was arbitrarily chosen, but then by the time, in the new design in 2023, the scenario is different. Similarly, the braking forces have changed. Instead of 25 ton, it is 40. The braking force on railway due to BGML 95 ton, it is 182 as per 25 ton loading. These are the changes. Where there is no change, I have not marked anything, any arrow there, so it is very clear. Original load combination was, this, and the revised load combination is similar, except that we have this 25 ton loading which is changed, and in the highway we have 25 ton loading in the railway, and in the highway we have this class 70R wheel. This is the broad change between original design and the new design as far as the loading is concerned. Philosophically, we had a detailed discussion with the railways, what is to be done. Working stress method has been adopted for the design check as per, as IRS Steel Bridge Code recommends the same. Dead load, live load, wind load and seismic has been considered for the design check. We did not consider SV loading, special vehicle, which is 385 ton loading given in IRC, which was introduced much later, because we told them if we take that load, then your structure has to be abandoned. So they mentioned that we will put some gauge to prevent, these kind of vehicles to come. By the way, when we were doing this exercise, parallelly a highway bridge was under construction. So they realized that this particular, although it's a rail cum road bridge, but on the top they can only allow, sort of light commercial vehicles, and the major vehicles will be diverted once that bridge is completed. And by the way, by now it is completed already. So that was envisaged. Then the congestion factor, there is one congestion factor in our IRC code which we decided by congestion to ho sakta hai, even if there is no major vehicles, but there can be a congestion because there is some accident happened somewhere, the whole bridge can be sort of loaded back to back. So congestion factor was considered. IRC SP 37 commercial vehicle loading has been considered. including the overloading factor. All these things has been taken into account. Now, after carrying out this analysis, the outcome is as follows. The diagonals are main truss. We found that the utilization factor is exceeding only in some of the diagonals. The main members, there was no sort of exceeding the capacity. There was no exceedance, except only very minor. You can see this. Only that too, we will close our eyes. More than 5% we need to consider. So that is why this marking. So this shows the members where the problems were envisaged based on this. This is all based on desk study, not based on the actual observation at site. Then comes the assessment of residual fatigue life. I think this was an excellent exercise done by our office. And how much time I have, I don't think I will have enough time to. Okay, fine. So I will just quickly, very briefly give you basically what is meant by residual fatigue life. The residual fatigue life in case of a steel bridge refers to the remaining time the bridge can safely operate under a given actual GMT traffic before fatigue failure occurs, duly considering its current condition and past loading history. It is essentially an estimate of the remaining service life of bridge from consideration of fatigue. Fatigue is an important consideration for steel, we all know that. And the railway guideline says, as per the correction slip number 42 of the railway guideline, it says that you need to do this assessment when the annual GMT exceeds 40, and GMT is gross million tons annually. Fortunately, being a railway bridge, we have the full history of what vehicle, what trains have passed, what was the total GMT passed annually. The record of the last about 10, 15 years was made available to us. And based on that, and service life greater than 50 years. So if these two conditions are there in any bridge, it is supposed to undergo a residual fatigue life check. So this bridge fell under this category, and therefore we had to carry out the residual fatigue life check. There are many methods of doing a fatigue life check, and there is an annexure G, which is in the IRS Steel Bridge Code, which gives a very simplified, conservative method of fatigue life, which is what followed. I would not like to go into the details because that will be a very long exercise. And moreover, I am not an expert. This is not my domain of fatigue life check. One of my colleagues, Dr. Sumantro Sengupta, has done this exercise, and he would be more appropriate person to go into details of fatigue life maybe in some other program. But the outcome of that residual fatigue life check indicates that for various members this exercise was done, and the connection between the stringer and cross girder actually failed in fatigue as per this analysis. But rest of the thing, and the next is the roadway stringer, which has 22 hours. These two are actually I would say the area of concern. Rest of all are more. But let me tell you, this kind of exercise is a very theoretical exercise, and generally it is a conservative. It is recognized in the railway code itself that this is the first approximation method, and which is what followed. Now, what are the structural interventions proposed? The structural interventions proposed by us finally, after doing all these exercise, is following. On the main span, the rail level stringer connection with the central cross girder, where crack in the weld connection appeared and was later replaced by rivets with cleat angle by East Central Railway. The inclined members of the portal frame above the road level, which was damaged due to heating. Some members were, at the portal frame at the entry of the truss. It got damaged because of some over consignment vehicles must have passed, and so those have been changed. Roadway RCC deck has been damaged, and the entire deck is being relaid. That was a decision which was taken because there were a number of corrosion related problems as well as cracks in the deck slab which was observed. That is for the main span, and in the 30-meter approach span, diagonal cracks appeared in the upper part of the web of the railway stringer near the support. So, if you see in the main span, these are the two stringers where the connection was a problem I explained because of the fixity. And this connection detailing we changed. And what we did is
2 minutes
we
left.
produced. Sorry?
Last 2 minutes.
Okay, I will be able to finish. So we basically removed this moment connection here, and we introduced this extra bearing arrangement with a fixity, which allowed fixed and free arrangement. And this moment connection, the flange connection at the top we removed. That was not required. It was not designed. The cross stringer was not designed for a fixity there actually, but it was provided. Then for the 33-meter span, we witnessed some cracks which are primarily fatigue cracks, and this was observed at almost all the cross girders there, I mean both sides. So we we put a web plate there as seen here, and this is the inclined member which got damaged due to hitting by oversized vehicle, and that was replaced. And the relaying of deck slab, and since the bridge was operational, we could not be stopped, so it was done in two parts separately. When first part is done, the second part was operational like that. So it was done in two phases. You can see the construction. When one phase the deck slab is being relayed, other phase it is operational like that. So I have come to the end of my presentation. To summarize, I would say, just to summarize, original loading, railway loading, broad gauge standard main line, BGML 1926. Highway loading was class AA and class A, and original wind and seismic load. But new loading, railway bridge, broad gauge 25-ton loading 2008, highway loading, single lane of class 70R or 2 lane of class A. But with this, we found that all members are adequate except the roadway cross girder and stringers. And therefore, revised new loading, based on discussion with the railway, they said you don't have to take 70R. Originally also it was not taken, and we will put some height gauge to prevent the heavy commercial vehicles to come. So with that, all members were found to be safe, and new seismic load and wind load also, of course, was considered. Now, working for repair and rehabilitation of Mukama Bridge was a huge learning experience for us. First and foremost, we learned how important it is for engineers to write articles about the project they are involved in, for the sake of posterity and for future repair and rehabilitation and retrofit. Learned what all information should be included in the as-built drawings. Huge learning on determination of fatigue service life of elements. This is our learning. Thank you very much.
Thank you, sir. So the session is now open for few questions. Due to time constraint, hardly I can permit.
Sir, sorry, we are run out of time. So probably we'll take the questions. They can forward it to you or me, and we will get back to them with a response. Sorry.
Okay.
Mr. Jayagopal, sir, will address for 2 minutes.
Sorry, the time was running out. That's the reason question and answer. Because we heard so much important things about 3 giants of the construction engineering in this country, especially Mr. Samir Surlekar, construction chemicals, the ultimate expert you can call, and his presence here and has enlightened us huge. And other 2 speakers, of course, they are the ultimates of the bridge engineering in this country. They are the designs, construction, and they are lights of the Indian Roads Congress also. And they are involved in many of the codes
finalization. And where Mr. Hegde was mentioning about the friction capacity to be restricted to 6 times the diameter. Every alternate day when we come across the designs in my office, this question comes out for the piles. And that has been written in the IRC code, and we cannot shift out. So we keep quiet and restrict the whole thing up to the 6. And next time when the revision comes or when revision happens, we will again examine. In fact, it was revised, and this point was not revised. And we are very conservative as far as the designs are concerned. We don't want in the foundation to take a lot of risk on that. That's the reason it is here only. And one announcement from our ING-IABSE Karnataka Center, the sessions were so good, and our members were very much interested, especially our the treasurer, R. Jai Prasad, and our other members also. They said, each session, whatever we have conducted here, every month we'll repeat that for next 1 or 2 months, giving more time. We have given hardly sometimes 12 minutes, 10 minutes, and 20 minutes, which is totally insufficient for our other members. So we are thinking on those lines. To every month, only one, either the last Saturday or like that, for half a day we'll take that full session into consideration. And that is the thinking, and probably we will be implementing that from the KC, Karnataka Center of ING-IABSE. Thank you.
Thanks for that very important note that these sessions will be aired again, either virtually or in person. Thanks for that, Jayagopal sir. Now to do the honors on our esteemed speakers, chairs and co-chairs, I request all of them to please move on to the center stage. And to do the honors, I request Mr. Vasant Naik, the Chief Engineer of KIDCL, and Mr. Prameet, the Superintendent Engineer of KIDCL, along with our ING-IABSE office bearers, Mr. Burji, Engineer Jayagopal sir, and Arvind Salechaji to please come over to the dais. I also request Engineer Jay Prasad sir to please join us onto the dais. As the honoring goes on, may I quickly read out the introductions, because you have heard them, how technically their technical prowess is. Mr. Samir Surlekar is a civil and structural engineer from VJTI, Bombay, with over 45 years of national and international expertise and experience in the concrete technology, construction chemicals, concrete repair and protection, injection systems, waterproofing. He has also worked across various projects across Europe, Asia, and India, and he is the owner, founder, and director of Assess Buildchem Private Limited, which is a leading manufacturer of construction chemicals. He is the pioneer, the cause of manufacturing of construction chemicals in India with a German joint venture, which is started in mid-1980s. He is also the founder and director of Institute for International Talent Development, which is a skill development and training firm under certification from the CIDC. He has been honored with various awards, such as the ACC Gaurav Award, Outstanding Contribution of Concrete Technology Award by the Indian Concrete Institute, the ICI Outstanding Concrete Engineer Award, amongst many other awards. He has also been awarded the CIDC Vishwakarma Award in the category of Industry Doyen, and also the Lifetime Achievement Award 2024 by the Waterproofers Association of India. He is also on the various ACI and BIS committees and subcommittees. Hello? Hegde. Sir, V.N. Hegde is the former Chief Executive of Stoop and the former Executive Director of Gamuts. He is presently the founder and CEO of Decon Complete Solutions. He has varied experience of 4 decades in the great separators. In fact, Mr. Hegde is from Karnataka, and he is a doyen well known in the arenas of highways, bridges, energy structures, chimneys, cooling towers, and various environmental, marine, and hydraulic structures. He is also the recipient of various awards and is from IABSE and Fellowship 2023 from the FEB. He has over 220 publications to his credit. He is on various committees and subcommittees of BIS, FIB, and IABSE. He is also on the editorial board of ING-IABSE. Thank you. Mr. Alok Baumik. Mr. Alok Baumik is a stalwart in bridge and structural engineering, and in fact, he is the managing director of B&S Engineering Consultants Private Limited at Noida. He is a former office bearer of the Indian Concrete Institute and the past president of ISTruct-E. He has over 4 decades of expertise and experience in transportation infrastructure. He holds a postgraduate in structural engineering from IIT Delhi, and in his firm, the firm delivers innovative design across highways, bridges, flyovers, precast segmental construction. He has over 60 technical presentations made and also papers published, and also the numerous contributions he has done to IRS and BIS code subcommittees is exemplary. He has been awarded the 24th S.B. Joshi Memorial Award for his excellence in bridge and structural engineering. In short, Mr. Baumik is a bridge design code making authority, academic contributor, and a mentor, all rolled into one. So now, ladies and gentlemen, now the full stage is that of all these luminaries. Let's all give them applause. Thank you so very much. We have a small presentation from ASEPL, please. Yeah. Commercial presentation from ASEPL. would like to thank AACPL for all the support and sponsorship. Our deep gratitude to you on behalf of ING-IABSE. Thank you. And now, ladies and gentlemen, we have got yet another highly experienced speaker, a speaker with a core competence and expertise in the arena of bridge bearings. And to introduce him, I will request Engineer J. Gopal sir to say a few words before Engineer Nagappa Hebiji comes over to the stage.
Here, we have one Nagappa Hebbi, engineer, worked in the metro projects. I had patented a system where the superstructure goes in a gradient. We have some restrictions in the Indian Roads Congress. You will have to overcome that. And he made the patent using all these restraints. And metro is supposed to do, metro or even the K-ride also, or even our bridges, wherever it is in the gradients, we'll have to take care for this type of a new method which he has made. It is a very simple one, and he wants to explain that here, being a civil engineer, it's our business to allow him to present it for not more than about 4 to 5 minutes, and let us have a look at it. If metro persons or metro engineers are there, we will let them see, or else we will transmit back to them. Mr. Hebbi.
Thank you, sir. Myself, Nagappa Hebbi. I did my engineering graduation from Bagalkot Engineering College in the year 1989. Thereafter, I joined Konkan Railway. This is my service particulars. As the technologies are commenced, the construction methodology changes. Earlier, our bridges are used to construct most of in situ concreting. Nowadays, all are precast one because of lot of advantages that everybody knows. So, because of pre-construction, our bridge bearings are not sitting, that too elastomeric bearings in the gradient condition not sitting properly because of the gradients. Back. So I'll explain how my journey was started. You see this photograph, this is from Delhi Metro Airport line. In the year 2012, there was a hue and cry on this subject, and Railway Board has issued one directive letter to MOUD. This is the letter. After this receipt of this letter, I have started thinking, what is the solution for that? You see, in the gradient, there will be a triangular shape of gap will form. To make 100% seating on the gradient, we need to introduce a separate element. Nowadays, that is being done in a precast condition, in the casting yard itself, because of predetermined surface that it is not sitting properly. So my concept is, instead of precast, we want to go the particular zone with the in situ concreting. The how to do and all is my R&D and my patent. See, presently, different metros, they are using the different methods. If you see in the entire India, they are following 4 or 5 methods. There is no uniformity. that blue, the first method is placing the grout below the bearing. You can see in these photographs, bearings lifted, touch the girder and put the whatever the gap between the bearing and pedestal with grout. Next. The second method, they are putting the grout above the bearings. You can see here, they put the grout above the bearings. This is one method they have followed. Next. The third method, placing the steel plates below the bearing. That also they have tried. Next. Presently, most of the metros, they are using this method, plating the steel plates above the bearing. For this, there is a restriction in IRC. The IRC 40, in that they have mentioned the restriction of use of steel plates. Next. Because of the steel plates, it will not have proper adhesive to the parent concrete, because the width of the steel plate restricted in the IRC is only 200 mm, whereas they are using more than 500 mm. Because of that, these failures are occurring. Next. You see, you can see in this photograph, that glue material, it is very good, fantastic. There is no failure in the glue material, whereas the skin concrete has come along with the that plate and glue material. This is failed in doing construction itself. Next. See, fourth method, some people have tried to grind the surfaces to make it true horizontal. Even that also it is not worked. So, because of this practical difficulty, I started thinking and how to do, what is the solution for this. Then it has came to my mind, so better go instead of precast, the particular zone, where our bearing is going to sit, that much only with a in-situ concreting. How to do and what are the challenges, what are our technical requirement and science, that I have made R&D in Ahmedabad Metro with my own, and finally I have succeeded in making the mock-up and publishing in the International Conference Journal, and in patent also I applied, and it was published in patent journal also, and finally I got the patent in 2024, last year. Next. Back. Then next. You see in this photograph, sir, the first one, what method they have used, placing the grout below the bearing. What are the things you can see here? That half of the bearing depth is taken away by our grout. This will happen because in order to flow the grout inside, it required a head. That meant head is created, and it was eaten away the thickness of bearing. It is very much clear in that photograph. Next. Back. You can see in the second photograph, there is no contact in the girder and bearing. This is all happening. It is there in almost all metro, but people are not exploring. They are hiding the fact. These are all real photos, what I took from my camera. Out of 4 bearings, 1 bearing is in the air completely. It is there in all the metros. Next. See how to do the innovative method. Just I want to explain in brief, sir. We can click and move. This is the model. There are 2 setterings. One is top mode, but one is bottom mode. Top mode is that a simple trapezoidal shape, but we are going to create a cavity inside the girder. We need to make a room for seating the secondary concrete, minimum 100 mm thickness. For that, I made a room inside the girder by providing the top mold. And bottom mold, you can see there are 2 parts. One is green, one is yellow color. Yellow color is a fixed height. And green one is variable because our gradients are varying to accommodate the exact shape. That variable wedges you have to use depends on the site condition. Next. So you can see the research has been formed. This is a U girder. This was dropped in Google SketchUp. The cavity has been created with the help of top mold. Next. This will not work. This is in SketchUp. This will not work. Skip this one. Next. You can see in this figure that blue color is there. That much will be inside the girder. That is the cavity which was made intensely during casting. And bottom one is below the girder. The total thickness is more than 100 mm. And material is microconcrete, strength minimum M65. And it satisfies all the properties of the concrete, including RCPT value. The RCPT value what I have tested is less than 800. Next. These are some elevations and are there. You can see in this elevation that the green is wedge shape variable shuttering, bottom is fixed height shuttering. Next. See this black one, I made a provision for air vent because when you pour the grout from the top, there will be inside air that has to be taken away. So for that I made the top mold in a sloped condition because grout will go to the lowest point and it will bring air one side and it will push through these pipes. Next. 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 These are the photographs what I did during my R&D. This is the arrangement of bottom mold. There are 4 pieces that will be, next. It will be fixed like this. Just some photographs are there. These are very clearly you can understand. After, come, next. No, next, back. No, go further. Next one. You can see in these photographs the top portion, that is my in situ concreting is going to come at the site. Just you have to imagine that line, that center line is dividing. Above is inside the girder, bottom one is below the girder. It will be exposed and it will be 100% contact on the bearing. Because it's the green concrete, it will fill all the gaps and there will not be any voids. This was I did, back. See, this I did January 2020. During COVID period, there was no other work, so I started doing this kind of activities. Next. Click the. This is one videograph where I did this casting in the the bottom mold and top mold, you can see the top one is visible, bottom is not down. The flow is excellent, sir. 650 mm flow is there with our all testing is done in my presence only. All concrete property testing. Except physics that I have given to IIT Mumbai. Next month they are going to give the complete result. Presently this material is, I have requested Fosrat Chemicals to do mix design and supply to me. For each and everything I was witness. Once you start pouring, no, it should be continuous. There should not be any air entry.
और बनाना पड़ेगा ना अभी
You have to imagine up to funnel there is a girder. It is imaginary. Up to funnel is our girder height. Top mold to funnel, that is our girder height at around 2 meter depth. Next. I did one mock-up in the casting yard with the same shuttering. What I am going to intend to do, that all I did in casting yard. Only the height of my thing is only bottom 500. Instead of 2 meter, I did only 50 centimeter height. Next. You can see in these photographs, the reinforcement, everything is as per the design. There is no change in reinforcement. Next. You can see here the air vents, the black pipes. That is for provision for air vents. Next. See, bottom 500 depth only I have casted. Because my intention is to study the bottom only. Why to cast the full height? Next. This is the mold after casting. Next. You can see the bottom, the cavity. In the cavity I made a dowels. It will act as a shear reinforcement as well as the holder bar for my secondary mesh. There will be 2 layers of mesh. This is my patent granted last year. Thank you, sir.
Thank you, Engineer Nagappa Hebi, sir. May I request Mr. Narendra to please come over to the stage to do the honors on to Mr. Nagappa Hebi. Because he has created something and you'll be using that. So perhaps in some of the projects. Sir, may I request Burji sir to please join us to do the honors. Sir, please come. Arvind. So please come, sir. Instructions of the Honorary Secretary. Thank you, sir. In fact, you have also encouraged youngsters to just not go ahead with innovations, but also ensure that patents are filed as and when they come to that stage. Thank you so very much. So now, ladies and gentlemen, we break for lunch. Lunch, as usual, is being served in the first floor. And for all the speakers, it's at the 7th floor. Request to all of you to please join us there. We will meet in 30 minutes' time from now. Thank you so very much.
Can our country's infrastructure last for centuries? Are high maintenance costs and efforts slowing down your projects? Or worse, do they create a financial burden and disrupt services in your projects? Have you found a robust material that stands tall against challenging and corrosive environments? And are you at the forefront of sustainability in the nation's progress? Discover stainless steel, one answer to all your problems. The fastest growing and safest material globally, which is now becoming the material of choice for India's diverse landscape. Still curious why stainless steel should be your material of choice? You see, building a bridge is not just a task. It's giving millions the liberty of an efficient commute. When you connect two parts of the city, it's not just a highway, but the road to progress for a nation. Our buildings must stand tall because they house thousands. Our flyovers must stand the test of time. Our future generations must progress, but not at the cost of the planet. Presenting Jindal Infinity Infra Solutions. Stainless steel solutions for success that lasts centuries. We advise on projects. We customize. We provide fabricated components for ready usage. And we provide world-class stainless steel. Build responsible and sustainable infrastructure. Let's pledge to make progress our shared mission. Jindal Infinity Infra Solutions, where the trust of decades meets innovation from the future.
C.V. Kumar?
Can our country...
Another 10 minutes, the
a sustainable world
program will start.
is no longer
Then you can
an
start your
aspiration.
presentation. Another 10
It's
minutes.
a
please.
necessity.
Sorry for the delay.
As sustainability becomes a key driving force in the era of climate change, Jindal Stainless is forging the path towards a cleaner, more sustainable future.
May I request all the
With a
delegates
green
to
metal
please
that
come
is
into the auditorium
infinitely
so that we can begin the next
Stainless
section
steel.
immediately.
It is everywhere, from the spoons on your dinner table to skyscrapers, marking the horizons of our modern world. Stainless steel is the metal of the future, corrosion resistant, durable, strong and light at the same time. Founded in 1970, Jindal Stainless stands as India's largest stainless steel manufacturer and is counted among the world's top 5 players in the sector. Jindal Stainless has an annual turnover of INR 35,700 crore, and we are ramping up our facilities to reach 3 million
Audio
tons
desk,
of
we
annual
will
production.
start with the session,
We
please.
have 2 stainless
close this
steel
presentation.
manufacturing facilities in India.
So welcome
in the
back to
states
this
of
post-lunch
Orissa and
session.
Haryana.
Now this particular session will be on health monitoring of structures, and I request the chair, Pravinderji, Pravindra Kumar, General Manager of K-Ride, to please come over to the dais and take his place on the stage, please. May I also request the co-chair, Engineer Arvind Salecha ji, to please take his chair on the dais. May I request the keynote speaker, Mr. C.V. Shashikumar, President, C.V. Associates, USA, to be ready, sir. We will shortly present you to the audience. I request the first speaker, Dr. N.C. Pai, former Engineering Chief, PWD Government of Odisha, to please come over to the stage and take your seat there. May I request Dr. Lakshmi Parmeshwaran, Chief Scientist, retired, CSIR, CRRR, our second speaker, to please come over to the dais, ma'am.
Yeah. Come, sir. Thank you. Welcome, sir.
Please come.
Welcome, ma'am. Please.
To the chairs and co-chairs, sir, we have this session, and perhaps Lakshmi ma'am has also a flight to catch. So I request you that you are being given a schedule. Kindly stick to those timings. And if the prolonged duration is happening, we will alert you so that we can curtail the session a little short of what has been planned. The first speaker that we have, he is Mr. C.V. Shashikumar P.E., who will be presenting his views from online from the USA. A very quick overview of Mr. Shashikumar's profile. He graduated from NIT Mysore and completed his ME in Civil Engineering from the Indian Institute of Science, Bangalore. With the goal of pursuing higher education, he went to Canada and then to US to pursue a PhD at the Rutgers University in New Jersey. However, financial necessity forced him to abandon his studies and take up a job. His first job, working in Manhattan, was at a 100-year-old company called Hartstein and Hanover, which specializes in bridge engineering, and that laid the path for his interest in this particular field and his company, which is very live and flourishing today. Mr. C.V. Shashikumar holds professional engineer license in the states of New York, New Jersey, Connecticut, Pennsylvania, and Texas. In 1995, he started his firm called the C.V. Associates, a multidisciplinary consulting firm located in Hermann, New York, and has grown from a staff of 2 licensed engineers at that time, starting to around 80 engineers as on today. In 2006, he was one amongst those honored with the 2006 Outstanding Asian Americans in Business Award at a function held in New York City, where with the keynote speaker was the US Senator Hillary Clinton. As an individual, Mr. C.V. Shashikumar supported and supports scholarship programs at the Bhagini Seva Samaj in Mysore and at Monroe Woodsbury High School in the US. He also supports the Kannada Chatuke Sahitya Parishad, Kannada Sahitya Parishad, and the Hindu Samrakshana Samiti, the National Association for the Advancement of Colored People at USA, and various other social causes. He is married and he has got 2 wonderful daughters. May I request Mr. Shashikumar to please make his presentation now. Mr. Shashikumar, can you hear us, please? Okay. No, I think. Mr. Shashikumar, can you hear us? Okay, please, sir. Thank you for joining us, and we apologize for a slight delay, sir. It's now all over to you, sir. You may start now. Thank you.
And my name is C.V. Shashikumar, and everybody here in the US calls me C.V. Of course, all my friends call me Shashi. My company name is C.V. Associates, right? And I'll go slide by slide. I have a lot of slides. I have been given 15 minutes time. I have to start my timer also here so that I. Yeah. Let us see how I can cover it with my experience of more than 30 years in bridge maintenance inspections. I have to concise it in 15 minutes. We'll see how it will go. Yeah, our company name is CA Associates, right? Ignore this one, right? We work for around 20 different public agencies, and most important thing for our company is quality work, timely work, value work. What is the value work? You take a dollar from somebody, please return the dollar in the form of service. And we do different types of, we provide different types of services. I listed here. Okay, we will start from, I started doing maintenance inspections. I used to bridge designs. From 1993, I started doing the maintenance inspections actually. So from year 2000, I have collected a lot of bridge collapse photographs and information, probably from 14 different countries. Here I am trying to address what happened in the past 25 years with respect to bridges in India. And similar, not to the same extent, but I will address that one, but a similar circumstance, what was done in USA. That's what I am going to address here. And probably for the next 40 pages, you will see in the chronological order the bridges that collapsed in India. Of course, very first one, and when I started collecting, this happens in Tamil Nadu, Kadaludi River. The train was going from Mangalore to Chennai. This is another one where more than 100 people were killed, Rajdhani Express. Here they closed the bridge at the top because the pedestrian bridge, they forgot what is below. The closed pedestrian bridge collapses, killing 2 individuals. Here you see the truck right below here, right? And another one, everything apartment, the pier is there, apartment, everything is washed out. Another bridge has collapsed here. This is in Vasanagar. Another one, they are doing construction. The train goes due to vibration, the bridge collapses. Another bridge collapse in Delhi. Another one here in Hampi. I believe that was Tunga River. And here is in New Delhi. Just I will go to these things. I want you to understand how many bridges collapsed, whatever I collected in the last 25 years. Probably it's around 70 bridges have collapsed based on my collected information actually. Here is another one. I think I will go through these things quickly. Here is another one. Here is another one. Cantilever portion on one side is hanging there. Here is one in Ahmedabad. Another in Andheri. A sign, this is in Marathalli. The title at the bottom is written in Kannada. In Marathalli, a sign collapses during construction. This is a tragedy in Kolkata. It couldn't have happened if they had known the construction procedures. And another bridge here. This I go through these things very quickly. Here, this is a video. I have just put a photo. These three are crossing the bridge. While they are crossing the bridge due to flood, the bridge washes out along with the 3 people who are on the top of the bridge actually. This is a good bridge actually. 200 years it survived. That's the bridge they built after 1799 after the Fourth Mysore War. Another bridge collapse here. Another one. Right? I try to cover it as fast as I can. And this is in Gurugram. Right? You see the bridge is down there. Here is a bridge, and this is so sad actually. 135 people were killed as they were worshipping on a pedestrian bridge. Very simple solution was we use yellow color circular drums, which are diameter 1.5 feet. They could have just nailed them and bolted them to the surface. It would have limited the number of people standing on the top of the bridge. Very simple solutions will save a lot of lives actually. Another bridge here. This is last year, 12 bridges in Bihar collapsed during construction. So I was telling Nagesh, not only a new bridge, old bridge needs inspection, maintenance inspection, even a brand new bridge needs maintenance inspection. This happened just 2 weeks back, right? You can see that this is in Pune. Sorry, this is not 2 weeks back, this is 1.5 months back. Here is the bridge which happened like 20 days before. You see the truck is just parked there. Parked there means it is right at the edge of the bridge without falling into the water. Now we will come, why I showed all these pictures, because I wanted you to know around based on my calculation, minimum 560 people died in these 40 bridges collapse. We need to have a regard for each and every life actually. So we will start with this one. All the bridges that collapsed that you saw, right, they were all in India. They are from the past 25 years. And to repeat, 560 people died, or maybe more than 560 people died. So, again to repeat, I have photographs of 14 countries, but at this time I'm focusing on only two aspects. One is the US aspect and one is the Indian aspect actually. So this is how the bridge inspection program or bridge maintenance program started after 1967. A bridge called a Silver Bridge collapsed in Ohio, killing 46 individuals. Now, what happened? Immediately, the House of Representatives, you can call them members of parliament, and also the US senators, they sat to them. They said, what are we going to do now? The bridge collapsed. We don't want any of the bridges to collapse. What shall we do? So they passed the bill. What is the bill? Every 2 years, every bridge, which is more than 20 feet in length, needs to be inspected, mostly with the federal funding, 90% of it is federal funding, to be inspected, and the report needs to be submitted to the owner as well as the federal government. A program was started to stop the collapse of the bridges. And basically the program effectively started in 1982 in New York State. I live in New York State. And I'll address this one. Here is a ship comes and hits a bridge in Tampa, Florida. I'll address this issue at a later time. Here is another thing happens. In 1983, Interstate 95, a bridge collapses, right? And here it is a pin and handle connection. It is corroded and the bridge collapses. What did we do? Immediately we said all non-redundant members of the bridge needs to be inspected, and it's called as hands-on inspection, and we should be within 1 feet of the non-redundant member. Okay, whether it is a truss, whether it is a girder, whatever it is, the inspector has to be within 1 feet, and he should check all non-redundant member. It's called as hands-on inspection. Now next what happens? In 1987, this is around 100 miles from where I am sitting actually, there was a spread footing, and the flood comes, and it undermines the footing, and of course it takes away the pier, right? And 10 people died. Then what did we do? Immediately we said, right, we called all the inspecting engineers throughout the country. Even I attended, I was one of them to attend in 1991, I believe. They said, we are going to assess every bridge in the country over the water. Right? Again, this is around 85% of the bridges over the water. Every bridge needs to be assessed for hydraulic vulnerability assessment, whether the bridge will collapse due to floods or not. So we classified all the bridge as high risk, medium risk, and low risk for hydraulics or the flood action. Then what happens? Again, this one I addressed, here is a part which the bridge and the bridge collapses. Right? Here is another thing. In 2005, what happens? This is a rocker bearing, right? Due to rust, it was frozen. And fortunately, if you look at the left side part, right, with my arrow, you can see that it is supposed to fall down by 85 feet, 83 feet. But fortunately, the cabin holds the span actually. Nobody was killed. There is a sudden drop of 2 feet on the roadway. But what did we do? We said every rocker bearing needs to be plumbed or a vertical drop. 1/3 of the bay, within the middle 1/3 of the bay. So we went and checked every rocker bearing in the country actually. Next what happens? Here, and this is in 2006, these two are the culverts. This is an interstate 88 between Binghamton and Albany. The culverts wash out because the soil around the culvert washes out. These were 5 culverts. Soil washes out, and then 2 trucks fall into the ditch and they die. 2 truck drivers died. Immediately what did we do? They never inspected culverts between 5 feet to 20 feet in 2006. Now they introduced a new program. Every culvert on every state route or the interstate needs to be inspected every 4 years. Right? So that new program was brought brought in and as a pilot program, and we define the whole program, how to inspect these are called as small bridges, also in some states, small bridges are large culverts. So what happened next? And this is just seeing the anchor board was not good, this is in Boston, it collapsed and it did an inhibition. Now, I was interviewed on this bridge collapse in National Public Radio. I was also interviewed on ABC News and CBS News. Interstate 35, here the maintenance inspector, bridge maintenance inspector, might not have found the cause for the collapse. The reason is, the original design itself was wrong. The design was before the collapse, 40 years before 1967, they designed this bridge. Bridge design was correct, but the gazette plates were wrong. Size of the gazette plates were wrong, either in the area or larger area of the gazette plate or the thicker cross-section of the gazette plate. Now the bridge collapses. Though it was inspected for 40 years, why it collapsed? Because the inspector did not know that the design was wrong. When we do the load rating, which I addressed the later pages actually, when we do the load rating, we address the girders, we address the truss, we never address the gazette plates. Now, immediately after that, 54 bridges in the state were inspected for that particular condition. Here is a collapse, here is another collapse, the truck is running out of time, I have to go faster, I'm sorry for that. And here is another bridge collapse, another one. And this is one of the, it is there, it was there, I don't know why it failed actually. Any flammable material below a bridge is a flat condition. It needs to be removed because when it catches fire, it will melt the bridge or it will break the bridge actually. So we have a forum for that and here I don't know why the inspector mistake, he mistake and there was flammable material, it collapsed the bridge. Here, it is during construction, they go and tighten the bolt more than what car is supposed to be put. It led for 5 people stand. Here is another one. Right, I will just keep moving because I want to show you. Old bridges, low weight posted for the load posting 3 tons, 5 tons. Local trucks go through thinking that it is safe. And also coming back, I have to address one more thing. When I showed this picture of the, sorry, I'm quickly going back, I forgot to mention this. The reason why this bridge survived for 40 years, you all know that there is a factor of safety with respect to the material strength, both concrete and steel, and also there is a factor of safety with respect to the light load, and also the condition under which the rolling hooks are located, right? So it will also give another factor of safety, therefore that bridge did not collapse for 40 years. Okay, now let's go, these are some more collapses that happened, right? This is one of them, my inspector was not right there on the near the bridge to a pond for the drone underwater inspection, and the bridge collapse was right in front of the side actually. So this is the one I showed you the 2 pictures before where a barge hit and a truck, ship hit the Tampa bridge. This one shouldn't have happened. I need to blame NTSB, National Transportation Safety Board, the collapse of this bridge. Because I have designed vessel collision protection devices for a bridge called as outer bridge crossing, where the displacement weight tonnage was 35,000 tons. This ship from Singapore had 93,000 displacement weight tonnage actually. And the vessel collision protection devices were inadequate, which should have been seen before. Now only they are analyzing which bridges are susceptible to H-shaped weight actually. It is so unfortunate that this bridge collapsed and now they have rebuilt it, spending at least $1 billion. So these are the recent collapses. This bridge, yeah. Construction methodology, I did this design, which was built in 1937, designed in 1937. I did the analysis for the approaches for this bridge. 40 pages is the design when it was built in 1937. 60 pages were the construction procedures, how to construct this bridge. These are the assessments that we need to do for every bridge, hydraulic assessment, not every bridge, depending on the situation. Hydraulic vulnerability, collision vulnerability, overload, seismic, concrete details, industry details. And we have worked on, I again forgot to mention, we have done around 32,000, actually exactly 32,616 bridge inspections. And we use this one very essential thing, I'm up for 15 minutes. We have a centralized system where the inspector goes to the field, right? He prepares a report, whether he has completed half the report.
Sir, can you conclude in another 2 minutes, CV, sir? 15 minutes.
Yeah. So, whether it is half the report, full report, the report is always accessible at the Albany office, for the project manager office, the regional chief engineer, and so these are some of the tools that we use. This is what I want to say. Like if you look at the ratio of the number of bridges to the number of vehicles, I have taken the four-wheeler vehicles actually. The number of deaths was 560 deaths in India, whereas in the same period over 25 years, it's like around 40 deaths or 50 deaths. The ratio is 1 to 10. Again, number of kilometers traveled, 16,000 kilometers, I don't have the number of kilometers traveled with Indian vehicles. Then it may become 1 to 50 ratio. Safety-wise, if you put Indian bridges at 1, US bridges at 1, it is unsafe with the ratio of 50. These are some of the basic equipment that we use, right? And this is a D-meter, which measures the thickness, diameter, to determine the crack in the bridge, load posting, every bridge we do load rating. At the end of the inspection, if the capacity is less, we put a load posting. And this is just a report, a sample that I wanted to show you. Quickly, it's around 70 pages, and bear with me. And this is a sample report of a bridge inspection. As I said, after doing more than around 35,000 bridge inspections, 15 minutes is too small for me, and this is a report of the bridge. That basically concludes my report. It's a flag issue, which red flag, safety flag PA, concrete connection, yellow structure flag, red flag PA. There are 5 different types of flags that we inspect. That basically concludes my presentation. I'm sorry I'm over by 1 minute. I'm at 16th minute. I'm sorry. Thank you.
Thank you, Shashi sir, for the wonderful presentation. Next, I request Dr. N.C. Pal to kindly.
Sir, Arun sir, there is a small rescheduling since ma'am has to catch her flight. We have requested Narayan Pal sir, and he has been kind enough to say that let ma'am present first, and then he will take over from there. Over to you, ma'am, please. Sir, Shashidhar sir, you can choose to remain online. We have got 2 more speakers, and after that we'll be taking up the Q&A, sir. Perhaps you can mute your video in case that's convenient to you. We are okay with... Right. Thank you. Thank you.
My presentation. Please load my presentation. Lakshmi Parmeshwaran. Okay. Laser.
This is forward. You can press it.
Okay.
Press it. Yeah. It goes forward. If you want to come back.
Yeah, thank you. Good afternoon, and respected chair, all distinguished dignitaries and students and all participants. The title of my presentation is Structural Health Monitoring of Bridges, Past, Present and Future Trends. So first, I will explain what is structural health monitoring. Basically, it is a non-destructive in situ testing where the structure will be connected with many sensors and from which the data will be collected, and it will be analyzed, and the condition will be assessed, and it will be used for further interventions, etc. You can just imagine that you are falling ill and you are going to a doctor, and doctor asking you to undergo an ECG. So there some wires will be there, some electrodes will be fitted to your body, and from the records, like he will judge the condition of your heart. So something similar to that here, the structural engineer, he is the doctor for the bridge, and he is assisted by many other expertise like electronics engineer, communication engineer, etc., so that this structural health monitoring can be done. So the basic objective is the damage detection, and also to understand the severity of damage. And it in fact consists of two aspects. One is the non-destructive evaluation, which is done for identifying the local damage. So like you can do some ultrasonic pulse velocity testing or rebound hammer testing or the cover meter test, which you have seen in the morning. So such things like you can do, or for the steel, like the dye penetration test or ultrasonic test, etc., can be done to identify what are the damages there. So it encompasses both non-destructive evaluation as well as structural health monitoring. So why we have to go for structural health monitoring is, that is like to understand how the condition of the structure is during the construction stage. For example, during the hardening of concrete, there is a lot of heat of hydration. So if you have embedded some sensor inside the concrete, that will give you how much is the strain because of the heat of hydration generated. You can also validate the design assumption, because you do the design, you know that what is the stress range you are expecting or what is the deflection you are expecting. So after the construction, like if you are monitoring the structure, you can validate the design assumption and also essentially to see that the structure is in the elastic range. Then improve the design specification. That is an outcome of SHM, the data collected from the SHM that can be used for upgrading your codes of practices. And also, it helps to reduce the frequency, that is the inspection of the bridges. That is a time-consuming process, and also with large number of bridges, it becomes, it requires a lot of manpower as well as like money to do the frequent inspections. So if the structures are having some health monitoring system, that can be used for doing the condition-based management of the bridges. So it helps to assess the integrity of the structure, even like after the event like cyclone, earthquake, etc. And also another important usage is that, like if you are doing a strengthening measure, after the strengthening measure, whether that is effective or not, that can be assessed with the help of structural health monitoring. So first, like you have to understand what are the levels of structural health monitoring. That is first, that the structure is having a damage. So the damage is to be identified, that is the level 1. And level 2 is that it is not only the damage, where the damage is there. So the location is also identified. The third is that the extent of severity of the damage along with the type of damage and its location. And the fourth is more sophisticated. There you get more details about the damage, its presence, location, severity. In fact, that can be used for evaluating the safety of structural system. And one thing you have to remember, that with the increase in the level of your health monitoring system, the money you spend in that and also more sophisticated equipments are also required for that. Now, if you see the categories and subcategories, the first thing is the static field testing, I think which many of you must have done, like the load testing, what you do. And there, what you are trying to understand is that the damage which is happening to the structure or the bridge, that is going to change the property, like the displacement, because there is a loss in pre-stress of the bridge. The displacement is going to increase, or the rotation is going to change. So such things you will be able to monitor. Then the dynamic part of it is that because of the damage, that is the stiffness is going to reduce, so there will be change in the frequency, there will be change in the damping, there will be change in the mount shape. That means like you are going to capture the dynamic characteristics, so that is the dynamic field testing. Then the monitoring can be periodic. Like for example, when you are going to the doctor may ask you to do a test maybe every 6 months you can do it. That is the periodicity in which that can be done. So similarly here, the testing can be done periodically, like we do for the bridges, like in summer how they behave and in winter how they behave. So that is one type of periodic monitoring. And another is the continuous monitoring, where like again, like you can have two type of monitoring, that is passive monitoring. That is the bridge is not under the ambient condition, like you are measuring the response of the bridge, but in the active case, like you are exciting the bridge and then like you are measuring the response of that particular bridge. Then again, like the load test, what I said, like you will be measuring the response of the bridge under ambient traffic condition, or it may be, you may be doing it for some heavy loads which you have to pass on that, or like it may be a proof load test, that is for the design load, whether the bridge is having sufficient capacity. So there can be different type of tests, like you can do that, especially these things are used to rate the bridge. And also like for your rehabilitation, you want to know what is the existing load carrying capacity of the bridge, because that is the starting point. So where like you don't have the drawings for the bridges, there the load test is generally done to assess the existing load carrying capacity of the bridge, so that like the strengthening measures or rehabilitation measures can be designed. So what are the processes involved in that? First is the conceptualization of SHM system. And here I want to say that this has to be done during the planning and design of the bridge itself. During that stage itself, this has to be planned. Okay, because in the case of concrete bridges, like many of the sensors, they have to be embedded. So you have to identify the location and the type of sensors which have to be embedded. Okay, so that is why we said that it has to be done during the design stage. Then during the construction stage, like the design and installation of SHM system, so that like as I said that you get the information of what is happening during the construction, that also can be captured by the sensors which are installed. And also in that time, if some extreme event like cyclone or wind happens, that also can be measured. So that helps in during the construction phase. After that, like the initial test after the construction, you do the load testing. There also the sensors can be of use. Then in the operation stage, like you measure the continuous health monitoring, like settlements, tilting of the pier, or like corrosion, if you have some corrosion sensors installed, carbonation, etc. Then also like you can, otherwise after some extraordinary events like natural hazards or traffic accident, vandalism, extreme weather like that, the response of the structure can be obtained. So you can see that some of the actions side, what we measure, for example, the traffic load, the axle load and the spacing that is required, seismic ground motion, or the temperature, humidity, wind speed and direction, then the water level, and the geotechnical aspect like the differential ground settlement or landslide due to that, what is the movement. Then the behavior part, we measure generally the displacement, strain. Again, the strain, you can have different type of sensors used, like their strain gauges. You can use either the electrical strain gauges or vibrating wire strain gauges or fiber optic sensors, etc. Then the velocity and acceleration, essentially you measure it with accelerometer, either like it has a single degree of accelerometer or it can measure the acceleration in 3 different directions. Then the chemical deterioration, I think carbonation, chloride ingress and corrosion rate we discussed in the morning also. Then there could be some crack because of the fatigue action. Again, that can be monitored. Or another important aspect is the scour depth. In fact, in US, like they have identified many of the bridges which are scour critical with the help of the monitoring the scour depth, and there they have more closed inspection or frequent inspection, they carry it for that. And as my earlier speaker, Dr. Sashikumar was telling that after the collapse, they did something in US, but India is not different. After the collapse of Mandavi Bridge, like 2 aspects has taken place. One is consideration for durability in design of bridges that started after the publication of IRC SP 33. And second is the instrumentation of bridges. And it started in late 80s in India by Ministry of Road Transport and Highways. And you can see that these are the bridges, all major bridges in India, and you can see different support condition like balance cantilever, simply supported or continuous, and all those things that has been instrumented. And at that time, there was no guideline, only by looking into the literature of various sensors and with the analysis of these bridges, after checking the sensitivity parameters, various sensors were selected. And this was done at the time, like SCRC Ghaziabad, and in the ministry, it was Mr. K.K. Sarin, who was the DG at that time, and SCRC was having Dr. S.P. Sharma as director, and our senior scientist, Dr. M.G. Tamankar and V.K. Ganokar, they were involved in this activity. And one of this I am just showing for you. So what are the important aspects to be considered? That is, first is the sensor selection. So suitability for embedment in concrete, and they have to be rugged enough, because while you are doing the concreting, the sensor should not get affected by that. And long-term stability, that is another important that there should not be any drift, and there should not be any degradation of output signal, because you have to understand that our bridges are horizontally spanned structures. So from one end to another end, when the signal is coming, so there could be some degradation of the signals because of the long cable. So you can see that this bridge, it is actually having around 300 meter span, and one of the first kind having a single box girder at that time, like in 95, 96, with 16.3 meter wide. And you can see that it has been provided with this vibrating wire strain gauges in the longitudinal and transverse direction, both to measure the strain as well as the thermal properties. And you can see that how they were embedded before the concreting was done. And you can see that these are some of the measurements for the temperature. During every hour, the data was collected. Even the deflection of the bridge span was monitored. And you can see that the thermal gradient, which is used in the design, in fact, what is there in IRC 6 that has been validated with the data which was collected from all these bridges, and also the shrinkage strain, creep strain. In fact, the bridge monitored in Thane Creek, there were some big concrete samples have been placed inside so that when you are measuring the field monitoring, at the same time the creep and shrinkage of the concrete samples were also monitored. Another example is the Zuari Bridge, which is a balanced cantilever bridge. And you can see the cracks developed near the support, and external pre-stressing was used to strengthen this particular bridge. And here also, during the external pre-stressing, whether that is effective or not, for that the structural health monitoring was adopted. So these are just two examples I am giving because of the time. And these are the things which we did before some guidelines were existing all over the world. But you can see that from 2001, there are some attempts in various parts of the world to prepare the guideline for structural health monitoring. And in Canada, you can validate the interventions. Similarly, in European Union, and 2012 in Austria, 2014 in China. And you can see that Chinese guidelines, probably they are the most advanced, and they claim that, okay, they can be used for developing guidelines for other countries, because that is a very practical one, what they have developed, because they acquire data, check performance, and also they see that whether it is complied with the design specification. And Italy and US, they have also developed theirs, but we are not that back because we have prepared the health monitoring as a chapter in the guidelines which we have prepared for integral bridge, cable stayed bridge, extradose bridge, and arch bridges, and also sea-link crossings. So I will just give you a glimpse of what has gone into our guidelines. One is the important aspects to be considered while designing the SHM, that is the functional aspects, what are the different modules to be considered, how you will be implementing the SHM. So first thing is that the system has to be very advanced and also long-term stability, and also how you will be transmitting the data to the long distance. And also, like you have to see that the sensors, what you are using, there should be some provision to calibrate them. And also the system has to be reusable and upgradable. In fact, yesterday there was a discussion that the sensor is not having a life as that of the bridge. So what will happen to the SHM system? So the various modules like sensory system, data acquisition and transmission, data processing and controlling, health evaluation system, structural health data management system, that is very important. From there, like you get the data for the bridge
2 minutes more,
maintenance management. Yes, I will complete that. So these are basically the various type of monitoring parameters, like global response parameter, local response monitoring, and also the load and environmental parameter, which I discussed as as action earlier. Okay, and these are some of the SHM, how like you can do the actual installation of sensors. So the first question which comes into our mind is like which type of sensors to be used, where to install them, what should be the basis. So what we have given is that the selection of location sensor that has to be based on the 3D analysis of the structure, because there you know that where are the critical stresses happening, and you know the values also, so that values can be taken as a benchmark for selecting the sensors also. So it has to come from the bridge designers, that the locations of the sensors, and also that has to be included in the structural drawing. Just like Mr. Baumik showed in the morning, the drawing of the railway bridge, there all the critical stresses are written. So we should also adopt a practice like that for our highway bridges. Then, like you can see that, as I said, design verification, we can do at least one unit if it is a multi-span extradose bridge, or if it is for traffic management or structural maintenance, it has to be a long-term monitoring to be done. Then, like we have given that the bridges which are having span more than 200 meters, then you have to select SHM, or the bridges which are having some special features like seismic isolation, bearings, etc. So there, like you have to go for SHM. Then how do you use the data, what you are collecting from the SHM? So the safety warnings criteria that has also been included, both yellow and red warning, how like you can decide whether it is acceptable or not acceptable. Those things are included in the code. And also, like we have the structural safety evaluation in the first level. Like one is that the acceleration, if you are monitoring, like it can be compared with the theoretical value. If they are close, then it is fine. If the measured values are on the lower side, that means there is a stiffness degradation, so that can be identified. So if that is the condition, then you have to go for secondary level validation. Just 1 minute, I'm just completing. So in this method, basically the finite element model is made, and also the design loads are to be used, and also the monitored load can be used to reanalyze the structure, and then like you can use them for the safety reserve estimation of that particular bridge. So the future trend is, one is about the drones which can be used for monitoring the structures, but you have to remember that we will be able to do now like up to the level 2 measurement. And another is the LiDAR which can be used for the remote sensing of the structure, and because it works even at the night, and also it is easy to apply and apply evaluation standards. And you can see that it can cover large area, easy and up-to-date data collection can be done. And you can see that various elements, various parameters can be monitored, and it can be used for FE model updating, and also even for pre and post extreme event assessments also this LiDAR technology can be used. And this is how this remote sensing operation can be used for health monitoring. So you can measure the surface information, structural model, and these, whatever you measured, they are directed with the crack, structural strength, etc. also. So if you make a comparison with between the photogrammetry and LiDAR, definitely LiDAR will be more better. You can see, you can compare the photograph. This is the LiDAR one, and other is the photogrammetry. So it will be much better, but again, it will be more costly. So what are the lessons which we have learned? This is the last slide. So it basically helps to monitor the condition of the bridge, and it will tell you, okay, what is the displacement, what is the, like you can say, acceleration or strain, etc. But it cannot relate the distress history. Actually, the mathematical modeling of structural and material behavior, that is very, very essential for the interpretation of the data which you have collected. And you have to understand that in all SHM, like there may be some mortality of the sensors, instruments, etc. So you have to cater for that during the planning stage. And also, it is an expensive proposition. So the sensors are embedded in concrete, and you have to be very careful about them while you are doing that. And while doing the continuous monitoring also, like you have to plan the sensor type, data acquisition, etc. carefully. Then protection of the SHM system, installed cables, etc. Because we were using cabled system, but after 2000, we have used some wireless sensors also. Because wired sensors, we were having some experience that people just cut the wire and removed that wire, they stole that wire. So because of which we couldn't collect the data from the sensor. So we have to be careful with that. And what is more important is high degree of commitment required for long-term monitoring. If you see the current tender documents, you will see that the SHM will have to be there 5 years or 10 years. But the problem for the bridge is going to happen maybe after beyond 10 years. So what you will be doing with that? If it is a steel structure, it is much easy for you to install them while they are in service. So these are some points for your thought. Okay, thank you very much for your kind attention.
Thank you, ma'am. In fact, Dr. Lakshmi ma'am has got a flight to catch, so we will do the honors on her and then continue the session. For that, may I request ma'am to please come onto the center stage. Pearl sir, kindly join us, the distinguished speakers, chairs and co-chairs. Burji sir, please join for the honoring. Mr. Mohan. A very quick overview of Dr. Lakshmi Parameswaran. She is a distinguished scientist whose work has significantly advanced bridge resilience and structural diagnostics. She is the former chief scientist in the Bridge Engineering and Structures Division at CSIR, Central Road Research Institute at Delhi. She is a renowned structural and bridge engineer, and she is having a PhD from IIT Roorkee in 2002, and then she has served in leadership research roles at the CRRI ever since. She has played key role in natural technical committees of various committees. She is also on the IRC committee and the BIS. With an impressive H index of 8+ and over 250 citations across 34+ publications, she has been an influential peer reviewer for premier journals, including the ACA Material Journal and the Journal of Indian Road Congress. In today's focus on ultra-durable structures and life cycle resilience, her insights into bridge integrity, diagnostic, innovation, and sustainability make her the perfect voice for our program. Thank you so very much, ma'am. May I request all of you to once more applaud her. Thank you very much. Thank you, ma'am, and have a comfortable flight back home. Thank you so much
for inviting me. If you have any questions, please feel free to send emails to me. I'll be answering that. Thank you.
Now may I request Dr. N.C. Pal to please make his presentation. Thank you. Sir, what do you?
Forward. This is backward. This is laser.
This is forward, backward.
Please backward.
Can you please load my presentation? No, Dr. N.C. Paul. I think because of ma'am flight, she has to rush. So I will request chairman to give me more 5 minutes then. I will show you two cases, not on bridge, and one live example of heritage structure to understand SHM. Thank you. I think my presentation has been eased out by the first keynote speaker, Shashi Kumarji, who has explained in his presentation so many bridge failures, and subsequently by Ma'am Lakshmi Parameswaran, who has also shown most of the cases which I may repeat or I may skip them. My first slide itself speaks the title that I'll talk on bridges, but of course at the end of my talk I will link to heritage structure, why I do special work in Puri Temple and Konark, which are UNESCO heritage structures for the monitoring for the last 8 to 10 years. Similar issues are here in bridges. It's not going. Yeah. I think in the yesterday introductory session, our great Jai Prasad ji has already said that bridges one constructed should not be forgotten. That's my first line. It's a misconception that bridge, once construction, we have to forget its continuous health monitoring, maintenance, everything. On the road, when we are traveling, we are observing potholes, damage in the road. That's why we are visualizing that, and we are alerting the government and engineers. That's why that takes place. But in bridges, I'm from State PW Odisha. I was former engineer chief in design.
I worked in design, I work in construction, I work in supervision monitoring, and I work in various IRC bridge committee from 2018, drafting some of the national code. So bringing this experience together, I will explain the presentations. You will remember that most of the bridge failure is catastrophic. They will not give you any warning because you are unable to see what is happening below the bridge deck. The thing you are observing over a road, you are not able to see what is happening below the deck other than your expansion joint or handrails. And all the state PWD, including ministry and NHI, they don't have budget in their state budget or central budget for condition monitoring, preventive maintenance, repair. They have budget for new construction of road. They have budget for maintenance of road. When the maintenance, there is a pothole, there is a circular, immediately fill the pothole. They will immediately overlay the road if there is a functional distress of roughness. They will immediately overlay if there is a FWD or deflection lesser than on the road. So there is a huge budget on maintenance of the road, always. But you will find in most of the PWD, I think in Karnataka also, there is absolutely no budget for maintenance of bridges. When the new concept of EPC contract came into this country, then we fold that in the document that the initial 4 to 5 years, now it is 10 years, the structure to be maintained by the contractor itself, for which you have to pay a maintenance money every year. It's not free of cost. You have to pay them. So that is how the beauty came in India. That's actually the practical scenario, what I am explaining. This is the thing that I say, bridge failures are not visible, they are catastrophic. Even the highest quality of construction, if they are not monitored, if they are not routinely maintained, they will also lead to failure. And in the day of modern highest quality of construction, we are going to ultra high performance concrete, we are going to corrosion resistant steel. Even yesterday, one vendor explained in stainless steel, all mismatching. We are observing in yesterday's presentation also in Odisha and Karnataka, bridges made in stone and brick masonry, 2-lane bridges are standing 100 years. Nothing has happened. And name of rehabilitation retrofitting in Odisha, I think in Karnataka people have done without demolishing the foundation and substructure. We may intervene only in the superstructure, may widen it with low density concrete so that load will be lesser and the stability will not be compromised. That's the way we handle nowadays. Returning the old bridges, we call them as old heritage structures. They're all heritage structure for us. In those days, there is no STAD, no CAD, no 3D, no twin modeling, no BIM, nothing was there. We used to do it in M20 grade concrete. If you see the Ministry MRC's drawing, the standard data book, superstructure drawing, there is PCC skin enforcement, M15, the substructure. Superstructure maximum M20-25. Now we are going up to M60 superstructure. Fly ash-based pozzolanic cement we are using. Earlier it was OPC. Entire cement code is drafted based on OPC. Initial setting time, final setting time, definition of FCK as 28 days characteristic compressive strength is because it is OPC. You check any of the slag cement, PP cement, you may get higher strength in 7 days, 14 days. You will never get strength in 28 days. It takes 40, 42 days to achieve that strength. These are the lacuna in the new materials. I'll talk some of these things. So that's a challenge. We have to monitor some of the things. It's not going. I have a problem. Back. This is the road I was saying when we are traveling. You are observing these are the distress. That's why immediate intervention is going. And nowadays in the government portal, normal citizen can tweet to the CM portal and immediately it is attended. This visibility is not there in bridges. If you go below the bridge, you may find this type of scenario. Just underneath the deck, a reinforcement corroded, expanded, spalling concrete already started. Highly severe even bearing, you can see in the left, second one, your neoprene bearing. It's a new bridge, only 2018 it was made, out of place. The rocker bearing is already in the turning situation in the central, it may collapse. The roller rocker, even the concrete has not been removed, the lock between the plate has not been removed. And there are, as I said, old masonry bridges in those days in most of the state. You can see the condition of the substructures. And inside the box, the last bottom middle, this is the inside the reinforcement of a bus girder superstructure. These are the typical scenario happening underneath the bridge. Nobody understands what is going on. So that lead a catastrophic failures many times. This is one example. I think Sachikumarji already saw it. It's about 1 month back. Suddenly something has happened. I came to know that it's only a 40-year-old bridge. Could have been monitored properly, some of the case. These are some of the failure in Odisha. After you can see on the extreme left, a new bridge, open foundation, going to be inauguration. Then before that, this collapse happened. I always tell engineer, even in IRC code writer, that differentiate between stream, nalas, and rivers. When you say river, don't allow small span open foundation. Unless it is a hard rock stratum, unless you have an embedment for at least cover. You will find in many of the states, long bridges, 300, 400 long bridges are made 10 meter span with open foundation floor protection. The code says that floor protection need to be monitored before and after monsoon and flood. Nobody does that because we forget. We don't have any budget now to do that. And this is the scenario of those type of bridges. Left side, so that needs possibly reconstruction of that. Either that span or maybe the total thing. On the right bottom, this is a bridge made by a great agency who had a similar failure in Mandovi. Long span balance cantilever bridges. In most of the bridges of those days, of those design, we have this type of near the central hinge deflection or sagging of about 500 mm stage by stage. And the photograph I have shown in the middle that one of the bearing has slipped. This is from this bridge. This was completed in 2013. In 18 we observed this. So this is a functional requirement. Bridge is still stable, but because of there is a degradation of about 500 mm, people are getting discomfort. So this can be functionally strengthened, and Jaigopalji has gone to that place. That's why I'm deliberately showing that case study. It is in Baitarani Bhadrak, if you remember. Still now it has not been rehabilitated. This is a bridge actually collapsed in Orissa in 2022. It is a masonry abutment bridge. Suddenly one of the abutment crumbled. An entire girder fell down. It is about 40-year-old bridge. Surprisingly, nothing has happened to the girder. 3 girder system, handrail, nothing has happened to that. Possibly, it could have been monitored previously, or even normal visual inspection, these 2 masonry abutment could have been jacketed simply, so that this bridge could have been retained. It happened in 16 August 2022. It's a single span bridge on a national highway. The new bridge adjacent to it is still under construction. I advised in that days that to that chief engineer, since the girder, nothing has happened. You create only one abutment, lift it and place it till it will be functional when the new bridge is over. Present day policymaker, typical eyes don't listen that. Now let's go to structural health one bridge. Bridge is very complex. You can see on the right side, it has so many components. Foundation varying from open to pile to well. Substructure varies. Superstructure varies from simple RCC to post-stress, post-tension, pre-tension, steel. Bearing varies from elastomeric to roller to spherical bearings to pot PTFE. Question is, what is the item you are going to monitor? You are saying it's structural health monitoring. And the misconception of many of people and many of the case studies in the world, they monitor only superstructure. They only monitor superstructure. And mostly they monitor long span high cable status bridge. They don't monitor this type of bridges. So bridge is a complex. There are so many items. Question is, what item you want to monitor? What is the component of your importance which you want to look? If it is a silt, clay bed, foundation where you have a problem of scour, it is better to monitor the scour and the foundation first instead of monitoring the superstructure. If you have issue of bearing, which in the post pre-lunch session, the gentleman from railway wonderfully placed that real problem of tapered location bearing, what actually happens. I thank and salute him that he has patented that. That's a ground problem. We have seen in most of the railway overbridge in state, in Odisha and many places. Same problem. They feel either below the concrete and above concrete without understanding what is the meaning of that bearing. Why you are introducing that bearing? That in elastomeric bearing with elastomer and steel laminate in between for a spring action. Why exactly we are introducing bearing? Nobody understand. They want to pack that only because the bearing has to be given. So question is, because I said which parameter to be monitored, and if you say if it is a concrete one, there are so many cracks. Cracks may happen in your pedestal, pier cap. It may be flexure crack, it may be shear crack, it may be shrinkage crack. Which crack is important to you? You want to monitor a crack? Crack can be monitored by normal crack meter. Every day we are going to do that. Let me explain to the audience. This structural health monitoring, the concept used is sensor. Sensor is similar that ordinary dial gauge we are using to measure deflection in the plate load test or the file test. It is also a sensor. It is sensing the deflection. Na? Meaning of a sensor that it has to sense something. It does not necessarily mean it has to be electrical based, microelectronic based. It has to sense something. That sensing should be authentic and to be calibrated. That is the meaning of a sensor. It can be simple mechanical dial gauge, can be LVDT, can be strain gauge, can be piezoelectric accelerometer, can be vibrating wire strain gauge, anything. But it has to be authentic. That's the meaning of a sensor. When you say that this type of probability will be there in a concrete because of corrosion or load or design fault, question is what to monitor, where to monitor, which span to monitor. A bridge may be 1 kilometer, which span to monitor. So these are so many issues when you talk on structural health monitoring. It is not that simple. So this is in nutshell. What exactly we are doing nowadays, or we have already done, is we go to a bridge for a visual inspection. We do non-destructive evaluation. Sometimes you do semi-destructive coring or maybe destructive testing. Then you do some form of environmental monitoring and load monitoring, like Lakshmi had said, all the load tests, etc., at the time of construction itself. That we do. Vibration monitoring if required. All these in combination is also monitoring the structural health. These monitoring that we do in visual inspection or NDE are one-time monitoring, or maybe frequently we are going. These are not continuous monitoring. When we say structural health monitoring of parameter, we generally feel that it should be continuously monitored. Continuously monitor some of the critical parameter of the foundation, of the bearing, of the superstructure, and try to redefine what is happening, what is the damage, what is the balance lifespan that will happen if that damage continue, what immediate intervention to be need. That's the meaning of real structural health monitoring. This is typical. We have given about 300 bridges to Central Road Division Bridge Unit 2 years back for structural safety audit and suggesting the rehabilitation retrofitting strategy. Madam was there, that entire CRRE Bridge Division is with us. We do like this. We go to a site with the MBI Mobile Bridge Inspection Unit or with ladder and something. We go to do the inspection, even with a boat. And somebody through the manhole, if there is no access through the manhole, somebody has to go through manhole through his head, the last right bottom, to see what is happening in the manhole. Today I was talking to Bhomik ji. He has gone to Odisha last month to a bridge. He went through, crippling through a manhole of a new bridge going to be inaugurated in a 60-span superstructure. Everything has cracked inside. You have to go into the superstructure box. This is the way we do typically one-time assessment. This is high-level preliminary investigation of bridge. From these, we decide what are the secondary items we should investigate and secondary items we should test. And these are the challenges of in situ testing. You have to keep a ladder inside water. You have to go testing. These are old bridges. And while doing the in situ testing of rebound hammer, ultrasonic, carbonation, corrosion, this is the way we usually do it. We want to get rid of this because of, I want to embed a sensor. It is a webless, so I will sit in my room and see that. That is the prime objective of SHM. What the general students, AI, artificial intelligence people used to think. That's not in bridges. This is the way, how we do it. We want to get rid of this. It's not it. Even Jai Gopal ji is drafting a drone. We have said in drone there should be a sensor, thermal sensor, ND sensor. Drone will not capture the image. It will go sit on the pure cap, into the pedestal. It will also take the in situ strength, in situ corrosion level, everything. That should be my drone. It should not be a marriage reception photographic drone. So I think Some of the lines have already told my madam. Structural health monitoring is a non-destructive. Remember, it is a non-destructive in situ sensing and evaluation. And we need variety of sensor. I said your dial gauge is also a sensor, but it is only one time that location, that's all. It should be a variety of sensor are either attached externally or are embedded to monitor structural response, to analyze the structure characteristic, for purpose of, please see the bold highlighting thing, estimating what is the severity of damage, the deterioration, and evaluate what is the consequence thereof, it will, if there is there. And application of the sensor should have construction survivability. He explained that when a strain gauge is to be embedded, and it's a concrete, because of heat of hydration, the strain may be from temperature change because of hydration. It may not be from the structure itself. So all these vibrating wire strain gauge or monitoring system, the data is always corrected for temperature. Unless you have a temperature sensor along with the deflection sensor, you cannot do together. That is the demerit, because any sensor you attach, some signal will come and you will dance after monitoring. That is wrong. That is wrong. So these three are important: sensor reliability, sensor durability, and construction survivability. And this is in nutshell, as I said. Structural health monitoring means you have to use some sensor to the structure. Some data need to be acquired. Data is always huge, depending upon what are the component, what are the parameter. So that means you need a data log, data storage facility, maybe in situ, and also transmitting to your remote location. You have to manage the data, you have to analyze the data, diagnose it, then you have to suggest what to be done. This is a complete cycle of structural health monitoring. This is IRC 40 guidelines. It's very nutshell. It's not that good. I should not comment on that. In fact, we are drafting the SHM code under B8, Jayagopalji, the member secretary. So I don't want to waste my time in discussing IRC. Nothing is there. Nothing is there. So we may measure strain, displacement, temperature, acceleration, load. These are the parameters one can maintain. I'm just keeping this slide with the time. Sensor concept. Please see the bold line. Thus, it should survive during construction. Sensor must be in a protected configuration. And it must be reliably sense the major parameter of interest at the interested location. What is my parameter of interest that is to monitor? Is it a crack or a deflection or is it temperature? That is my parameter of interest at the interest location.
Dr. Pal,
it must be durable. 5 minutes.
Another 3 to 4
Only 5 minutes. Only 5 minutes. I'll quick. And should be sensor life should be life of the structure. We say bridge life is 100 years. What is the life of sensor? This is a typical diagram. Sensor life is versus bridge life. Many of the sensors have very limited life. Can you go again and remove that embedded sensor in that concrete and reinsert in the same location? Because your base data is not there. The day you have embedded, you have a zero base data based on which you are comparing. The day you change the sensor, that day is now your base year, base data. So that is the problem. Like doctor, they check every 3 days your CRP. If you have a urine infection, they will compare with the base CRP only. So that is the meaning of lifespan and breath span. And cost consideration, as I said, it has to be monitoring, should be continuous and depend how many points you want to monitor, how many span, and what type of sensor you are going to use. So it involves a huge cost. That's why it is very funny and new to many of the things. There may be wireless sensors, there may be optical fiber sensors, and there may be acoustic sensors. But there are problems in acoustic and other sensor. I'll just quickly. There may be sensor, and when there are multiple sensors are used, they have to be cable in a one duct, and they have to be taken in one point. That feasibility is always there when you have fiber optic cable. Here your acoustic, strain, temperature, all cable can go, like in strands. It is easy to monitor this type of thing. Less cabling. So I'm just skipping. But if you see two dynamic displacement, the upper one is the, lower one is the typical acoustic emission sensor. The other one is high-grade fiber optic sensor. You can see the amplitude and dimension for the same value which triggered, which is eye-catching to a designer or to analysis. That's the way we always recommend fiber optic sensors with highest reliability for the amplitude and other things. These are the type of thing you measure the strain, go to your new generation modeling, find out, then transmit your data and do your data management. Now I'll give just one or two examples of a prestige bridge and a heritage structure. Most of the bridge in now India, 40 meters span onwards, we are doing prestige construction, either cast in situ or precast, 40 meter to 60 meter. That means there is a tendon, grouted or ungrouted, bonded or unbonded, and there is possibility of loss of prestige. In design, we always assume 15 to 20% losses, but sometimes more losses happen. If there is a breakage in the tendon or there is a corrosion in the tendon, if one tendon breaks, the load transferred to the nearby tendon. It's not it. That means that bundle is now highly stressed. And in that highly stressed tendon, if something has already corroded, then that cable will fail fast. So how to monitor that? That is the importance of monitoring a post-tension tendon. This is what I have written. If the strand fails, if the corrosion is already there, how the load transfer mechanism. One has to understand the basic engineering mechanics of load transfer in that locations. How generally the load transferred. If something goes breaking or corrosion, how the load path is changing. Due to that change in load path, what consequence is happening to the other link structures? That has to be monitored. That need to be monitored. So this is about the tendon and about the grout. Many times the grout also break. And there is a loss of grout in monolexan. Grout is there to protect your tendon. If there is mismatch on the grout or grout breaks and the temperature related crack starts, the tendon starts corroding. And even in the stainless steel construction, yesterday I was explaining, everything in stainless steel, but my cable are high tensile wire, conventional wire, carbon steels. They may corrode. We don't have stainless steel high tensile wire in the country or in the world today. And in the grout, that chemical environment need to be checked, corrosive mechanical structure to be checked. The last part, and thermal condition need to be checked. So I'll skip this, some of the things. This is in nutshell. These are the challenges in SHM. The structure size, location, environment, and network, and the complexity will decide. And large number of sensors, the last line, if the large number of sensors involved, then the cabling and wiring becomes a complex process. And the lifespan of sensor versus lifespan of bridges, these are the example of most of the international bridges that is monitored, but you'll find this is mostly monitoring of superstructures. And all new bridges, not the old bridges, including the cable stayed type of bridges. These are all new bridges. With all the 3Ds, MIDAS model, this is a typical thing where you can monitor your foundations.
Can you
and
conclude,
structure.
sir?
Yeah.
Yes.
I will take just 2 minutes to give one example of a heritage structure similar to this, because as I said, we work in heritage structure. This we did with the association with Central Building Research Roorkee and IIT Madras, Professor Menon. This is a famous Jagannath temple in Puri. Yesterday and today's session is your ultra-durable 200-year structures, sustainable structures. This slide says, what is the sustainable structure meaning in past, what is the meaning in present, what is the meaning in future. And what is the engineering concept in those days, what is the geometry they adopted in those days, the shape and the material they have chosen in those days. Today we are discussing carbon footprint, heat, energy, all those things. What those great engineers of 6th century are much learner, much knowledgeable than what we are today with so many degrees. This is a typical tall temple at Puri, 220 feet high. You can see the main temple is having an aerodynamic shape. For the sake of audience, I just say I have a PhD from Aerospace Engineering Department. I'm not a PhD from civil structure. I've done a lot of work on aerospace structure monitoring in 96 to 2000 and Vikram Sarabhai Space Center, where we are using lights, piezoelectric accelerometer, which are now play games for me in the current area after 30 years. So here actually, you can see the main temple is aerodynamic in shape, the profile itself. The material they have chosen is stone. Itself is durable. There is no metallic intervention, stone to stone joints only. The metallic intervention was for seismic resistance. They use wrought iron as anti-corrosive metal in those days, 12th century, in belt in between. This is the typical concept of this temple in those days in Orissa. This is the present and the future material, steel, concrete, ceramics, bitumen, timber. And we are discussing on corrosion resistance, low energy cement, novel non-traditional binders, nano layers, tougher ceramics, nano filler, all these are our bulk construction material of today, but everything is deteriorating within 5 years to 10 years. That's why we are discussing structural health monitoring. These are of the futures.
Dr. Pal, sir, can you please conclude?
Just 1 minute. Embedded sensor, active nano, self-cleaning, high-performance material, even composites, fiber optic, all these buildings of the futures. We don't have accelerated test value performance to say that they will be durable for next 200 years. Because they are failing on every day in front of us. In third year, the bridge is collapsing during construction. These are the typical from 6th century to 12th century monuments. What we did actually in one of the monument, there is a failure in the Pida temple. 54,000 ton of loading was transmitted to these 4 columns. This is the schematic view of 4 columns which are carrying 54,000 ton of loading through 8 beams, 8 stone beams. All the stone beams cracks, through cracks, flexure and cracks. When you talk to typical archaeologists, they say nothing will happen, we'll monitor it. With archaeologists, historians, they will monitor and record when it was built, when it collapsed. They are not engineers. To me, we did a lot of work. Then we did this typical retrofitting of some of the column with capital confinement of the stone column without drilling the stones. Then typical insertion of frame to transmit the load to the cantilevers. Nothing to be embedded. No, after understanding what is the load path, if the cabin failure will happen in the earth shape, what is the load path? Truss tie concept. Then we introduce secondary portal structure, 3D portal structure, so that the load will transfer from the stone beam to the main steel beam through a foundation. Then ASA people wanted that this will never work. It will be unnecessarily passive. It will never be active. We said start monitoring. Let's see. Then they started monitoring from 2017 onwards through CVRE Roorkee. Unfortunately, they use vibrating wire sensors, which we denied. This is old, obsolete, to monitor load from a sensor. These are the typical model. They use 8 sensors in the model, some beam in column, and sensor means you will get some data like this. They'll correct from temperature. Then they'll give readings, plus, minus. Unfortunately, observing one of the column, the reading is changing from minus to plus. I said, how can the compression will change from minus to plus? Then we asked the CBRE team come and check. They checked the data logger. The data logger is not working. This is the challenge of actually SHM. We talk many things. We use national report, institute report, professor and other, nothing comment to them. But these are the things happening. Similarly, there's National Center for Heritage Structure with IIT Chennai, Professor Menon. We introduced actually 3 sensors. One electrical triaxial sensor, one triaxial mechanical joint meter. Mechanical, you have to measure it physically compared to the electrical data so that both should correlate. And another 3D tilt meter. Because electrical sensor will sense and send 2 signals. But unless it's mechanically calibrated, you cannot compare them. We did that. And we did temperature correction. And we got actually, because there is a doubt the cracks are dead. They are not active. Through this monitoring, we could observe they are active. They are moving. And that's why they recommended that last line, appropriate repair strategy for the cracked beam need to be done. However, they also suggested, in addition to that, monitoring should continue. So this is with these slides. I thank your audience for my kind attention. Thank you.
Thank you so much, sir.
Thank you, sir. Wonderful presentation.
Okay, in this session, we had 3 wonderful speakers. Mr. Sashikumar CV who joined us from online. So he gave us whenever the accidents happen, what are the steps taken, whether in India or in US, and how the history of bridge inspection, bridge maintenance started, and how now they are even inspecting and maintaining the culverts also. And then whenever you are doing that inspection, what is to be noted is the vulnerability assessment, like which component is vulnerable and all, and the load rating of bridges, he had explained. Next we had Dr. Lakshmi Parmeshwaran Madam. She explained on the SHM and the trends, past, present and future. So she went through the overall definition and requirement of SHM. And he had explained also about the static as well as dynamic testing methods which are adopted in SHM. And then most important of that is what is to be implemented, how SH is to be implemented. So that depends on the type, based on the design and construction practices. So at which stage, what is to be implemented, how it is to be done, that is the most important. And different sensors are required for different parameters. And the history of instrumentation of bridges in India was very well explained by her. Then the crucial question of the life of the structure versus the life of the sensor came up, which even Dr. N.C. Pal sir also mentioned. And Dr. N.C. Pal, he gave a lot of examples of the distress, and also he explained that all our codes, all our parameters which we are following in the code, they are all based on OPC. And now we need to upgrade because as even in the previous session, many speakers said that, you are replacing cementitious materials, So those parameters for creep, shrinkage, our strain, stress, strength gain should also be updated. Then what are the objectives of SHM? And sir has explained that 300 bridges they have given to CRRI for monitoring. Sir, I would like to add one point here, sir. In Karnataka, we have PRAMC, so which is an organization, they are continuously monitoring all the bridge and road assets in Karnataka, PWD, sir. Thank you so much, sir.
Dr. Arvind, sir, what we will do is, for paucity of time, since Engineer Shashi Kumar is waiting for quite some time, we will take questions pertaining to him and perhaps a question to Dr. Pal, and then we will close at that. Thank you. Yes, any questions for Mr. Shashi Kumar? Yes, we have a hand going up there. Please identify yourself and keep your question brief, please. Can we have a microphone there, please? Audio desk? Audio desk? Can we have a microphone there?
Myself Jagdish, I am structural consultant from Stedland Technical Private Limited. I have one question as per Paul sir told. We are doing a 3D model analysis and all those things for the bridges and all those things. Where strains and stresses and strains are measuring the analysis only, FEM model only. Why we are monitoring in the site? That's my question.
For whom? The question is for whom? Mr. Shashi Kumar?
Sir.
Yeah, we'll take that question, but is there any question for Mr. Shashi Kumar? Okay, okay, fine. Thank you. Sir, kindly keep your question
one
brief,
observation only. You made one point very clear. After every failure, you are trying to say how to avoid those failures in the future. So you are not finding fault with any person. So that should happen here. That is what I learned from your so much of good failure showings on the screen, where every time you told such bridges should be again monitored. I think you have given a good lesson. I thank you very much. That's
sir.
what I want to tell you.
Good point, sir. Very good point, sir.
Very good points he has told.
Sir.
Here
Thank
we are
you.
trying to find only personal defects in this country. So you have shown that what is you have done, it should be followed here. Thank you very much.
Thank you.
Shishi, you want to add anything to this?
Yeah, I don't know, of course, the two speakers, they spoke about the advanced techniques, but as I said before, we have done 32,616 bridge inspections in the last 25 years. We need basic tools like a hammer, beam meter, die penetrant gauge, right? This one, slide calipers, screw gauge. These basic equipment, even without going for the strain gauges and health monitoring, continuous monitoring. The basic things are, if I am given say 650 engineers, fresh graduates, and 650 engineers with 4 years experience, prefer with bridge-related experience. We can monitor all the bridges. Of course, the equipment are needed to reach the different parts of the bridge, particularly non-resident members, and also driving inspection is needed along with that. First, an inventory needs to be created throughout the country at Delhi level, at the central government level. And at least the first inspection of all these 167,000 bridges that are existing needs to be inspected. Like, to repeat, if I have 1,300 engineers, in 2 years I can come up with the inventory, and in 2 years I can come up with the load capacity of every bridge. And when we do the load rating, every time we inspect a bridge, right, we do the load rating. And the load rating, there are two softwares. One is called Workpiece, again used by ASTO, American State and Transportation Officials Association. And also we use what is called ASTO-Ware or VRR, where we input or incorporate, say for example, if it's speed structure, we see 10% section loss in the bottom triangle, the average loss is 10%. Then we incorporate that 10% section loss, and then we come up with the load capacity for each bridge, and we do the load posting. So first, the basic program is this is what we do. We create inventory of all the bridges, do at least one inspection for every bridge, come up with the load capacity, and continue to do the same thing every 2 years. That is what is essential for the country. Otherwise, last week that bridge that collapsed, that shouldn't have happened. And one more thing in my presentation, what I meant was, if the bridge collapses for one reason, say one particular reason, then no other bridge in the country, India, should collapse for the same reason. That is the formula that is kept here in the USA. Same thing should be there in India. Thank you.
Thank you so very much, sir. Answer, I think we can take that last question.
I think you have a question that why we are monitoring even after doing a finite element analysis. I don't think you have ever designed any bridge. Don't take it otherwise. Finite element analysis to analyze what is the load, moment, shear, bagara bagara. What type of element you use? 2D node element or 3D element or 4-noded element, 8-noded element. What is the element you have used in analysis? I think through only software mouse clicking. Is not it? Yeah. I am the code writer of many of the packages, that's I know. Finite element analysis gives analysis of the load system. Design is based on IRC code design principles. Design is something else, analysis is something else. All the 3D or 2D or any finite modeling has certain limitation. Orthotropic concept we use in the concrete which is highly heterogeneous. With embedded steel, something is different. With the foundation with soil structure interaction, no model is there. We use spring coefficients. The model has so many assumptions, we used to validate the model from the FEM to actual results. That is something different. Then once you designed, the design are guided by national codes. That minimum thickness has to be that, minimum cement content of this, highest grade of concrete that. Then based on the design, we implement soft drawing and go on constructing. During construction, there may be construction issue, there may be over-designing or under-designing, there may be mismatch of the material. I have designed the material with M60, actual strength is M10. These need to monitor during construction stage. Only construction is over, it in service. There's a dynamic loading, other loading. So you need to know what is happening because of all these combination. Along with highest floor level, there's a load combination in IRC6. The combination says there will be 70R vehicle, HFL, we will load everything in together. We design, because that is the factor of safety immediate. So we need to monitor that. That is the meaning of monitoring, either in construction or after construction. Please first clarify your concept, we are going to be a bridge engineer in future. That is my advice to you. And just to supplement one line to Shashi Kumarji and to this fellow. Sir, in Odisha actually we first commissioned, developed road asset management and bridge asset management web-based through a World Bank funding. Based on that and based on development, Karnataka and NHI, the country code on asset management, IRC 130, published in 2020, drafted under my chairmanship. Now we are doing a bridge management policy for the country and for the state also. And Odisha is doing this bridge auditing last 10 years involving CRRI. This through auditing, then deciding the strategy, BAQ, rehabilitating, retrofit. It's a continuous operation. It is not auditing, collecting data and keeping in dustbins. This is a continuous operation. And there is a frequency of inspection, frequency of observation, depending upon IRC 35 and 40 stimulations. That's for your kind information.
Mr. Shashi Kumar, this is Jay Gopal
from Banashankari. My name is Jay Gopal from Banashankari. I am a ex-Public Works Department, SDO, and we had a policy in 1984 that when the Mandvi Bridge collapsed, there was a circular that each and every bridge in the country has to be inspected by the rank of at least assistant executive engineer by going below the bridge, checking it, certifying it. Then onwards, the Government of India and the respective state governments in the country, India, it is a relentless effort to inspect, check, rehabilitate. All, and especially from the last about 4 to 5 years, there is a continuous high-speed monitoring and inspection of the bridges because of, we have seen many negative things, maybe because of the material fault, maybe because of the maintenance deficiencies like that here. And we are also looking at the USA model, what you people are doing there. And as and when we see that somebody is doing a better job, we try to catch it up. This is for your information only. Thank you.
I think with that we will go ahead with the honoring of our esteemed chairs, co-chairs and our esteemed speaker. Shashi Kumar sir, please be online and because we cannot do it in real time in terms of you not being in person, we will honor your very close friend and associate, Mr. Nagesh, and through him, I'm sure you will be able to receive our gratitudes. Thank you.
We welcome our Managing Director.
I take this opportunity to welcome MD KRDCL to at least the concluding session. She has been very helpful in deputing engineers from our organization. I will be always telling her, in the history of KRDCL of 25 years, this is the first lady MD we have. After going through all the presentation, they are not only bad, others are also equally bad. Wherever the pictures are coming down.
ನೀವೇ ಹಾಕಿ ಶಾಲು ವರಲಕ್ಷ್ಮಿ ನೀವು ಹಾಕಿ ನೀವು ಹಾರ
ಇಟ್ಕೊಳ್ಳಿ.
ಹಾರ ಶಾಲು ಕೊಡು ನೋಡ
Madam, on behalf of ING-IABSE, we would like to convey our deep gratitude and thanks to you, Srishalima ma'am, for providing us such a wonderful, venue for us and all the support that we require online with organizing this two-day international conference. Thank you so very much. In fact, while the dignitaries are interacting, let me complete the introduction that we normally have for our keynote speaker, Dr. N.C. Pal, before he is being honored. Dr. N.C. Pal was the former Engineer-in-Chief Design at the PWD Government of Odisha at Odisha, and he has been an university gold medalist in civil engineering with higher specialization of MTech and PhD in structural engineering from IIT Kharagpur. His doctoral research was from the Aerospace Department of IIT Kharagpur on the coupled fluid structure interaction problems of FRP laminated composite containers. In 1995, Dr. Pal was study fellow in University of York, United Kingdom, for a course on structural conservation of heritage structures. He has over 35 years of exemplary experience in design, planning, procurement, both EPC and PPP projects, and experimental assessment of quality of works in roads and bridge sector, besides structural conservation works, including rehabilitation and retrofitting of bridges, monuments, heritage structures. He has published over 40 research publications across various journals nationally and internationally. More importantly, he took on the lead role in development and commissioning of web-based ORMs, Odisha Road Asset Management Systems, in the state of Odisha, which was funded by the World Bank. Ladies and gentlemen, that is Dr. Narayan Pai for you. Thank you.
I must thank the Managing Director for her so much interest she takes in especially the technical things. Last time when we met about a month back in this boardroom, and we invited many engineers of the KRDCL. Many engineers. Of course, only a handful of engineers came with one SC, 2-3 executive engineers, and few assistant engineers. In the meantime, MD came, MD sat there throughout. She is not an engineer, she is an IAS cadre. But the difference between what we were just discussing, difference between an administrator and engineers. Our engineers were supposed to show more interest in gathering more information because the information was coming from Japan. What we have seen in Japan was being explained there in detail. My request to my other engineers who are here or not here, kindly show interest, gather more and more information. Otherwise, the losers are engineers only. Thank you.
Mr. Arvind Kumar Salechaji is the Director of Chetan Infrastructure Consultants at Bangalore. He is a structural engineer with over 25 years of experience. He is an alumnus of IIT Bombay and he is also the alumnus of University of Oklahoma. He designed over 600 bridges and 22 metro stations and is recognized as the Eminent Engineer 2024 by ACC Bangalore. He actively contributes to national engineering bodies and knowledge sharing. He is the Honorary Secretary of ING-IABSE. Ladies and gentlemen, now we'll break for tea for about 10 minutes and assemble back for the last session of this conference. Thank you.
Yes, sir. Thank you so much.
Can our country's infrastructure last for centuries? Are high maintenance costs and efforts slowing down your projects? Or worse, do they create a financial burden and disrupt services in your projects? Have you found a robust material that stands tall against challenging and corrosive environments? And are you at the forefront of sustainability in the nation's progress? Discover stainless steel, one answer to all your problems. The fastest growing and safest material globally, which is now becoming the material of choice for India's diverse landscape. Still curious why stainless steel should be your material of choice? You see, building a bridge is not just a task. It's giving millions the liberty of an efficient commute. When you connect two parts of the city, it's not just a highway, but the road to progress for a nation. Our buildings must stand tall because they house thousands. Our flyovers must stand the test of time. Our future generations must progress, but not at the cost of the planet. Presenting Jindal Infinity Infra Solutions. Stainless steel solutions for success that lasts centuries. We advise on projects.
Request all the esteemed delegates and speakers
We provide
to please
fabricated
enter the auditorium and take
for
your
ready
seats.
usage.
We will begin
And we
the
provide
last session of the
world-class
two-day
stainless steel.
international conference
Build
in the next few
responsible
minutes.
and
after
sustainable
that, it will be
infrastructure.
followed by
Let's
a very
pledge to make
interesting but a
progress
very
our
brief
shared
panel
mission.
discussion of
Jindal
very erudite
Infinity
speakers and
Infra
experts.
Solutions.
Request all
Where
of
the
you to
trust
please
of
enter the
decades
auditorium
meets
and take your
innovation
seats
from
very
the
swiftly,
future.
please. Thank you. May I request the volunteers of ING-IABSE at the reception to please escort all the delegates into the auditorium so that we can begin the next session shortly. Request all the volunteers to escort all delegates into the auditorium, please. Request all the delegates to please enter the auditorium and take your place for the concluding panel discussion, and before that a concluding session, please. request Jayagopal sir to please join us on the stage, please. Welcome back after the tea break, ladies and gentlemen. We begin the last session, or rather, I would say the concluding session of the two-day international conference. May I request the chair, Engineer Jay Prasad sir, to please grace the stage, and may I request the co-chair, Engineer Srikanth Chanalji, to please come over to the stage and take your seat there. May I also request the erudite speakers, Engineer Arvind Salechaji and Engineer B.V. Nagesh, to please come over and take your place onto the stage. Dr. Yoshio Sakamoto, are you able to hear us, please? Okay. Thank you. In fact, today we have a very unique person with us today as the co-chair. Engineer Srikanth Chanal has been nominated as the first president of KCPCE, Karnataka Council of Professional Civil Engineers. Let us all applaud him and wish him all the best for his tenure. Thank you. Sir, this session, the first speaker will be Engineer Yoshio Sakamoto. We have a recorded video, and that video will be for 15 minutes and followed by 20 minutes each to
Good
each of the
afternoon,
speakers.
everyone.
Over to you.
I'm Yoshia Sakamoto, belonging to Honshu Shikoku Bridge Expressway. I'm glad to have the opportunity to give a keynote. Now, I will introduce about maintenance of long-span bridges. This presentation will mainly show two topics. The first is the outline of Honshu Shikoku bridges as long-span bridges. And the second is the maintenance of Honshu Shikoku bridges. First, I introduce the outline of Honshu Shikoku bridges. Honshu Shikoku Bridge Expressway manages 3 routes connecting Honshu and Shikoku in Japan. These routes have 70 long-span bridges like suspension bridge, cable-stayed bridge, arch bridge, and truss bridge, as shown in this figure. And you can see the size of these bridges has varies. The eastern route has 2 suspension bridges. Akashi Kaikyo Bridge was built on Honshu side. The center span of this bridge has been the longest suspension bridge in the world over 20 years. But it surrendered its position in March 2022 to Çanakkale Bridge in Turkey. Onarto Bridge was built on Shikoku side, and this bridge is located in harsh natural environment with strong winds and strong currents. The central route is connected by Seto Ohashi bridges, which consist of 3 suspension bridges, 2 cable-stayed bridges, and 1 truss bridge located in straits, with a width of 10 km continuously. And this is only route that has railway beneath expressway. Finally, the western route connects 7 islands between Honshu and Shikoku. And this is only route that can be crossed only car, but also bicycle and pedestrian. This route has 9 long-span bridges. Among them, Tatara Bridge was the longest cable-stayed bridge in the world when it was open to traffic. And Kurushima Kaikyo bridges are the first 3 continuous suspension bridges in the world. This is the experience of Honshu Shikoku Bridge Expressway. Honshu-Shikoku Bridge Expressway began to field investigation for construction in the 1950s, and it was chosen present route based on the field investigation. After that, Honshu-Shikoku Bridge Authority was established to construct Honshu-Shikoku bridges in 1970. Our bridges had been built for 30 years, and all bridges were completed in 1999. After open to traffic, Honshu-Shikoku Bridge Expressway was established in 2005. And we are continuing to maintenance of long span bridges after completion. So we have many experiences, not only construction, but also maintenance over 30 years for long span bridges. Next topic is the maintenance of Honshu-Shikoku bridges. This is a feature of Honshu-Shikoku bridges. First, volume of maintenance target is massive. Signature example is 4 million square meters painting area of external surface of steel structures. Second, for new materials or unique structures utilized in the bridges. Its maintenance experience is scarce and durability is not fully known. Third, since they are located over straits, they are considered to be in very harsh corrosive environment. And since superstructures are in high location over straits, they are not easy to access. Fourth, there are no alternative route. So repair works and the traffic closure are unfavorable. Finally, since construction cost is huge, so replacement and large-scale repair works are difficult. From these features, the maintenance of Honshu-Shikoku bridges is implemented based on preventive maintenance, and it is aiming to ready long-span bridges for use over 200 years through preventive maintenance. In order to carry out preventive maintenance, it is necessary to accurately grasp the state of deterioration through inspections. On the other hand, Honshu-Shikoku bridges are located over straits, with cars passing above ships under the girder, while trains run through the girder of Seto-Hashi bridges. Under such severe environments, inspection for these bridges are conducted using maintenance ways and maintenance vehicles, as shown in these pictures. There are over 100 maintenance vehicles located across the Honshu-Shikoku bridges, including maintenance vehicles for inside girders, for outside girders, for towers, for cables, etc., according to each bridge structure type. The maintenance vehicles were developed considering maintenance after completion through construction. And we conduct inspection by using these maintenance ways and maintenance vehicles and evaluate soundness of bridges based on the inspection results. The inspection for Honshu-Shikoku bridges are implemented by close visual inspection, as with general bridges basically. But some members couldn't check their condition by close visual inspection. For example, suspender rope couldn't check inside the cable by close visual inspection because the rope consists of some wires under painting. So we have implemented using non-destructive testing as detailed survey. Detailed survey for suspender rope are implemented by non-destructive testing called total magnetic flux method. This shows the principle of total magnetic flux method. In this method, we strongly magnetize the suspender rope, measure the magnetic flux in the suspender rope, and estimate the decrease in cross-section area due to corrosion, comparing them to sound area by using the proportion of the magnetic flux to the cross-section area. This figure shows the cross-section rate using this method from top of the suspender rope. In this figure, the line of 100% means the sound of ropes. And you can see the cross-sectional reduction from this figure. By using this method, it is possible to determine the location and amount of corrosion in the suspender rope, since the corroded steel material becomes non-magnetic. In addition, it is enabled a reduction of the labor required for maintenance by using this method. In addition, we are also conducting fatigue survey for orthotropic steel deck using temperature gap method. In the steel deck, fatigue cracks may occur due to the repeated live load. However, cracks in steel material covered with paint are difficult to discover through visual inspection. And then, this is a non-destructive inspection method using the phenomenon, in which heat transmitted from the surface is cut off in areas where there are cracks. This video shows the situation of actual inspection. The temperature profiles of line A and B are shown in this figure. When you find a sudden drop of the temperature in this figure, it shows a candidate of cracks. We evaluate the soundness of bridges based on inspections and surveys, and implement repair works as needed. This figure shows the detail of repair cost for Honshu-Shikoku bridges until 2100. From this figure, our bridges need to have various repair works in the future. And you could understand the half of repair costs for repainting, as Honshu-Shikoku bridges has repainting area of 4 million square meters. So, it is important for us to reduce repainting cost to reduce repair cost. Painting is important for long-span bridges built in corrosive environment. So we painted the heavy-duty coating system for external surface of steel structures from construction stage. There are 4 layers in the heavy-duty coating system, consist of inorganic zinc as base layer, undercoat, intermediate coat, and top coat. In our heavy-duty coating system, base layer is upright. That has a strong corrosion protection performance due to sacrificial anode action of zinc. However, base layer is difficult to repaint on site. So we have adopted a strategy of repainting only surface layer while keeping soundness of base layer intact. The optimal timing for repainting is determined based on predictions of paint deterioration estimated from the result of the fixed point coating survey. This survey is implemented periodically, and the survey items have thickness of coating, luster degree, and adhesion. This figure shows the estimated thickness reduction rate of painting film based on this survey. From this figure, we determine the optimal timing for repainting to finish repainting, not to expose the undercoat. In addition, we are also developing new coating materials to reduce repainting cost. This is painting specifications at construction stage. Among them, we developed a highly durable paint that can be supposed to extend the painting cycle for top coat. By developing its highly durable paint, it is expected that the painting cycle can be exceeded from 30 years to 40 years. And since painting has generally multiple layers, we have to consider drying interval. So we also have developed new low process paint that can replace the functions of top and middle coats with a single layer of paint in order to reducing work period. And we implement test coating before applying new coating materials. The main cable is the most important member of suspension bridge. Therefore, it was taken the countermeasures as corrosion protection as shown in this figure at construction stage. However, several years after completion, it was confirmed that rust had occurred when the corrosion protection was removed for survey. From this survey, corrosion protection by only surface treatment was insufficient. And then we developed the dry air injection system to dehumidify inside the main cable by sending dry air in addition to corrosion protection. This is the outline of dry air injection system. Dry air is made from the equipment installed on the girder. Dry air sends inside the main cable from the inspection cover, and then wet air exhausted by the exhaust cover, and the inside of main cable is dehumidified. In this system, we set 40% as our management target value of relative humidity on the safe side because corrosion occurs to 60%. As a result, the main cable of Akashi-Kaikyo Bridge, which has been using this system since construction, has shown no rust even 20 years after completion. At present, this system is standard technology used suspension bridge in the world. In addition, to achieve efficient operation of dry air production equipment, we installed the additional pre-cooler equipment to lower humidity of high humid air in times such as summer season. Honshu Shikoku bridges are located over straits so that the concrete structures are exposed to harsh salt damage environment with a large amount of salt wind from the sea. Therefore, we estimate future conditions based on interval surveys for concrete structures and take the countermeasures as needed. This shows the procedure from survey to countermeasure. The survey item has density of chloride ion, depth of carbonation, concrete cover, and corrosion of river with self-potential method. Based on the result of these surveys, countermeasures are implemented. In addition, we also check the condition after implementing countermeasures and evaluate the countermeasures. In particular, the anchorages of suspension bridge located in straits is mass concrete. So implementing countermeasures for all of them would require huge cost. So we also estimate the range of corrosion of steel bars due to salt damage within the target period based on survey for chloride ion on site. And surface coating is implemented only as needed. Specifically, the density of chloride ion in each location is measured, and the area estimated the corrosion of steel bars due to salt damage within the target period based on survey. This figure shows the estimated density of chloride ion on the river for vertical direction of each site. From this figure, you can understand the density of chloride ion for east-west is smaller than it for north-south. So it was possible to minimize the countermeasure range for east-west to reduce the repair cost based on the estimation. So, in addition, the effectiveness of the surface coating is confirmed through periodical inspections and surveys after implementation. Similarly, most of foundation of Honshu Shikoku bridges are located in underwater. Most of these foundations are adopted a laying down caisson method widely used, in which various shaped steel structures with outer walls is used. This method is after this sinks to the shaft. Then concrete is poured inside it. An investigation of the steel caisson outer wall 11 years after its completion. Corrosion of steel caissons occurred as shown in these photos. This corrosion could affect the concrete inside the caisson in the future. And then we took the countermeasure, separated underwater to splash area and tidal area. For underwater, we developed and adopted the electrodeposition method, in which by running a weak magnetic current through the seawater, positive ions in the seawater such as calcium and magnesium ions are guided to the steel caisson, and the coating mainly composed of calcium carbonate and magnesium hydroxide are made to adhere to the surface of steel caisson. For tidal area, we adopted both the cathodic protection and the electrodeposition method. This is because the electrodeposition method always could only be used underwater. So it is used combination with the cathodic protection to complement its functionality. And for splash area, we conducted the last proofing beer painting in atmospheric environment using dry boxes. Based on this deterioration, for Kurushima Kaikyo bridges and Tatara Bridge, the cathodic protection was installed after painting on the surface of the steel caisson during construction. In addition, we are developing a next-generation long-span bridge maintenance system to improve maintenance of long-span bridge efficiency. Specifically, since plan to check action called PDCA cycle for bridge maintenance is important. So we aim to improve maintenance of long-span bridges efficiently by evaluating soundness with AI, monitoring using sensors, using automatic painting robots, etc. at each stage of PDCA cycle. One such initiative is the development of inspection support system. Long-span bridges require significant time for inspection and record-keeping tasks to have the complex structure and large number of components. And then, to improve the efficiency of inspection work for long-span bridges, we have developed an inspection support tool called BigSci. BigSci could utilize MR technology to seamlessly integrate the real-world view with BIM and SIM models in real time, displayed on a tablet device. This device enables inspectors to tap on the components shown on the tablet screen to record photos of the damage, details of the damage, and precise location information. Additionally, past inspection records can be easily reviewed and updated on-site, enhancing the inspection process. This is the conclusion. Honshu Shikoku Bridge Expressway aims for keeping the condition that could use long-span bridges over 200 years or more through preventive maintenance. Specifically, to keep the soundness of long-span bridges, we have been continuing reliable inspection and proper repair works after completion. In addition, Honshu Shikoku Bridge Expressway aims to minimize life cycle costs through technical development about inspection, surveys, repairs, etc. My presentation is finished. Thank you for your kind attention. If you have a question, please send me an email. I'll check it and answer for you. Thank you.
That is from
Dr. Yoshia Sakamoto from Japan. So far we were listening about the superstructure monitoring. I think underground also has been covered in this thing. Now, the next will be from Engineer Arvind Salecha, MD CICPL, Bangalore. Sir, you have 10 minutes.
Okay. Okay, so I'll go very fast. So I'm just going to run through some of the case studies that I've gone through and downloaded from the internet. Okay. Next, please. Okay, so first is, why are we aiming for 200-year life? Aren't we not happy with 100 years? The issue is very simple. Okay, this is 100-year life. So at the end of 100 years, if you want to extend the life, the cost goes up like anything. But if at this stage itself, you are designing it for 200-year lifestyle, your cost increase will hardly be 15%, right? But you will be saving 25% in the later stage, after 100 years. So your lifestyle at 200 years, the overall cost will definitely come down. Okay, so what are the design philosophy? Basically, we have learned since 2 days that, it's basically all the materials, right? So you should have robust materials with low deterioration rates. You need protection from chloride, UV, fatigue, etc. So now I'll just go directly to the case studies. This is a case study from Finland. It's called the Kruunuvaari Bridge. Oops. Okay, so this is the portion of the bridge which is called the Kruunuvaari Bridge. It has 2 spans of cable stayed, and it's a curved bridge. Other spans are 46 to 48 meter composite girder bridges. So how was this selected was in 2012, they had a design competition to design for connectivity. And this is the location where it is proposed. So this is Helsinki, the capital, and it's very close to that. And WSP-led group that won the competition. Competition was in 2012, okay. Then they started discussion on that and they started working on that. The overall length is 1.19 kilometers. The cable stayed is about 260 plus 260. The central is a diamond-shaped pylon. Approach spans of 48 to 46 meter continuous composite girder bridges. It is designed, though it is 15 to 19 meter width, it is designed only for tram and bicycle and pedestrians, because there they are very much conscious about the carbon emissions and all. So emergency rescue vehicles only are able to use the vehicles in case of any emergency. The owner required 200-year lifestyle. So 200-year lifestyle is designed for pylons, piers, deck and steel work. So this is currently in construction. It will be set to open in 2027. So what are the durability metrics? What have they chosen? So if you look at, these are the component, the material system they have adopted, what are the protective measures, monitoring and inspection, and what is the target life. Okay, I'll go very fast now. This is only for the edge girders. They have used UPHC because edge girders are prone to chloride spray from the sea, right? So what they have done is stainless steel rebar they have provided inside at 40 mm. That is not the main rebar. Main rebar they have provided at 100 mm inside. That is taking care of the main reinforcement. And for monitoring, they have embedded chloride and RH sensors are provided. And the target life of this is 200 years. The main pylon is with concrete core and steel box. They have given epoxy painting and PU paint, polyurethane paint on top. So they have inspection every 5 years. That projected life is 200 years. Stay cables, the projected life is 60 to 100 years. So what they have made is what Mr. Sakamoto had presented earlier, dehumidified air. so that there is no corrosion. Corrosion is prevented. That is taken care of. But it is has to be replaced. It is designed to be replaceable in within 60 to 100 years, so that the others others will be there in place. Then deck slab and rails, they have taken as with fiber reinforced concrete. So spray waterproofing is provided on top. And they are also designed for a minimum target life of 150 years. Then the eye girder plates, which are on the supports on the sides, approach spans, they are designed for 200-year lifestyle. This is what in the morning they were explaining, Domex steel they are using, which is 500 grade. They are specially made for this one. And then the bearings, pot PTFE spherical bearings are there. So again, their design life is around 40 years. It is designed to be cartridge type. You can, just like in a printer, you can put the cartridge in and pull it out. That is the mechanism they have made here, so that in case wherever it is needed, they can just pull it out and replace it easily. And smart sensors have been provided. So this is the view of the Krunuvari bridge when it will be completed, and you can see the trams provided. They are provided only for the trams, bicycle, and for pedestrians to walk around. This is the incremental launching method for the approach spans, which is currently going on. This is the main pylon. You can see the climbing formwork is being used. So this is the pylon almost nearing completion. These are again some of the construction photographs. So the thing is, everything they modeled in BIM, and then that was exported to a digital twin. So this is the complete, each and every bar has been modeled. So even they have modeled the rock. Okay, so this is the foundation is in open rock, excavated rock for the main pylon. For others, they have used pile, but the main pylon, they have found hard rock, and they have anchored it into hard rock. Next one, this is from South Korea. It's the Godeok Bridge. It's already opened. So the difference here, it is two pylon. The other one, what we saw, was a single pylon. This is also a two pylon. Okay. So what happened here is, this is totally of concrete. Okay, concrete and composite box girders they have made. Means the bottom is steel, top is concrete. Okay, composite box girders and concrete box girder they have prepared. It is designed for a 6-lane. The contract was awarded in 2016, and it's already completed and open in 2024. So this surpasses the earlier bridge which they had, was the longest bridge in South Korea at that time. Here they had used 80 MPa HPC. So these are the key panels for the concrete box girder. See the pre-stressing strand they used. Normally we use 1860. They developed special strand just for this one. That is 2400 MPa. And even the stay cables. Here also they have developed new technology, higher strength. That is 2200 MPa stay cables they have done. So this is a photograph of their construction. This is the bridge cross section. And here, this one they have provided. This is the PSMA deck overlay which they are providing. So with this will basically a waterproofing membrane. It will prevent the salt and water ingress into that. Okay, next. Design and construction. This is designed again with a 200-year seismic spectrum and 200-year wind speed. Okay, this value may be wrong because this is the value given in net. Even I was surprised by this such a low value. Okay, wind tunnel tests were done, and free cantilever method was undertaken for erection, and stage-wise tensioning was done. And even here, if you look, the main reinforcement is having a cover of over 100 mm, so that it will not cover. By the time the carbonation reaches that level, it will take so many years. And they have already provided sensors in it for real-time monitoring. These are few of the construction. Here you can see for the main pylon, they have given a 3-level coffer dam. Okay, this is the BIM model. You can see the series of transit mixtures, and here they are pumping so high. Here the construction cross-section can be seen. Next, this is a Randselva bridge in Norway. This is also, I would like to stress, this is the first bridge which was constructed without physical drawings. Yesterday Pratik was saying, we should come out of it. We don't need 2D drawings. This is precisely that one. In Norway, it has been done. They have constructed this bridge without any drawings. Everybody was given a tablet at the site. So any changes, immediately it reflected in there. Okay. So this is the bridge length is 634 meters. The specified life was 150 years, but the contractors targeted 200 years to win bonus. And in 2022, it was completed. And now it's in use. So this is, you can see everything was in a BIM model, which was sent to the site, 3D model. So the persons at site, they could visualize how the bridge would come up. The blisters, they were done, they were modeled at site and seen whether they are exactly tallying with that. All the reinforcement detailing, cable detailing, everything was in 3D, no physical drawings. Okay, these are a few of the photographs during construction, and this is the constructed bridge. Just for information, the height of the box girder at this location, the person is standing here. So you can imagine the height of the box girder here. Okay, so these are some of the key features, whatever quantities they had. And this was done by MSS, that is movable scaffolding system. Okay, that itself requires very, at least 15-20 minutes presentation, which we can do sometime later. One more, I'm going very fast. This is a Queen's Ferry crossing done in Scotland. This is already opened in 2016. So here what happened is the design life as per the tender was again 120 years. But the design philosophy was based on 200-year philosophy, that though the design life is 120, the design philosophy will be that it should last for 200 years, and that is the kind of material protection and all they have used. And incidentally, this is the world's longest 3-pylon cable-stayed bridge. And one more thing you will notice here is that the cables are overlapping in the midspan. All the others which you have seen, there is a gap between the two planes of the cable. They are not overlapping. So these are a few of the construction and launching photographs. So just for a comparison for all the three bridges, what did they do? So concrete around C75, basically in India we are used to cube strength. So cube strength if you go, it is 75. Here it is M80. And Randsleva it was 67, Queen's Ferry 60. So nothing much difference, but only thing is, as everybody else mentioned, they are using GGBS and fly ash. Once you use that, you are reducing the cement content, because reinforced concrete has two enemies, cement and steel, right? Because steel corrodes and cement, it leads to deterioration. So this was the reinforcement. In Krunuvari, they used the SS reinforcement, and in Godiak, they used the high strength pre-stressing strength, which I already told. And in Randsleva and Queen's Ferry, in the splash zones, they used the SS stainless steel rebars. And the steel protection was zinc primer and polyaspartic top coat, which is what they call C5, as they had explained in today morning. And again, dehumidified cavity. So that is there for all the cable-stayed bridges. They have been dehumidified, they are using. And the special feature is that everywhere they have used SHM modeling, and digital twin is there. So all these things have been incorporated during the construction stage itself. So what are the emerging materials? The main thing is chloride diffusion coefficient should be less than 3 into 10 raised to minus 15. And you can use GFRP or BFRP, which is basalt fiber reinforced bars, which are non-corrosive. Thermally sprayed aluminum on steel can be used, and self-healing concrete. So this is just some of the comparison of GFRP and BFRP. The lessons learned is that early material science, whatever you want to do, it depends on material science input. Mock-up you have to do and check what is this one. And lifestyle cost analysis, it justifies whatever the premium you are paying on this. And in conclusion, the thing is that 200 years are achievable. They have been done. It just requires proper detailing, QA, QC, and proactive maintenance. That is all. So thank you so much.
Thank you. You have just exceeded 3 minutes. Thank you. Yeah. Next is Engineer B.V. Nagesh, MD Nagesh Consultants. Sir, you have 10 minutes.
Thank you, sir. I was thinking you may give only 5 minutes. Yes, sir. Yes, sir. Good evening, everybody. And today we are talking about the extremely durable bridges. Next slide, please. Oh, sorry. Okay. So when we are talking about a design life is the period for which a bridge structure is designed to perform its intended function without major repair. When I say service life, the actual period structure remains in use and performs its intended function. In essence, design life is target and service life is actual outcome. According to IRC guidelines, the design life of a bridge, excluding ancillary items, is generally 100 years. And even in Eurocode also, it is 100 years. The design life of bridge, according to ASTO LRFD guidelines, is generally 75 years. So this is what the codes have been talking about. But today we are talking about the bridges whose life is little more than over 200 years. The general steps that we have to follow in design of target life bridge. Establish service life requirement, establish general layout, dimensions and material section, assess environmental exposure, and design to resist approach. All these are known to us. Avoidance approach. Then we have to have a construction specification, maintenance plan, inspection, monitoring plan, construction, execution structure, inspection of construction structure, and during operation also, condition assessment through inspection and monitoring during operation and maintenance. So this is the flow chart that we have to go through to look in for design of bridges of life over 200 years. And we also have to understand some of the factors we have to keep in mind. See, what are the factors that affect the service life? That is also very important. We call it as a fault tree. We have to write the fault tree so that we understand and we don't miss the points and include the points which are required to make the bridge life over 200 years. One is the reduced life service of bridge. It may be due to obsolescence or it may be caused by deficiency. As far as the deficiency is concerned, it may be load-induced, natural or man-made hazard, or production operation defects. When I call about obsolescence, there is significant increase in corridor traffic that we have been seeing. We have been seeing that we have designed many bridges, and within 10 years, 12 years, it is not serving the purpose of what is known as required level of service. Safety issues, inadequate shoulder widths, sharp curves, inadequate sides, these are all the things that we need to avoid. And changes in design load over life of a bridge, that happens many a time. In the extremely long life bridges, risk of future obsolescence should be considered and appropriate choices should be made. And caused by deficiency and load-induced maybe overload and fatigue, and natural or man-made hazards like thermal climate, coastal climate, chemical climate, collision, hydraulication, and production, design detailing, wrong design detailing, fabrication, construction, inspection, all these things have to be looked into very meticulously while planning and designing such bridges. So, and also very importantly, when we are talking about a 200-year life bridge, the recurrence level of the event, when you are talking about 75 years or 50 to 100 years or 100 to 200 years, we have to take into account the recurrence level of hydraulic, wind, seismic, temperature, sea level, etc. should be considered. It is all based on the probability, that is statistical data. The statistical data should be extended for up to 200 years, and such factors shall be considered while designing such bridges. And what are the options for enhancing service life? Identify appropriate design methodologies, select durable material, consider additional protective measures such as cathodic production, electrochemical chloride extraction, specify best practices for construction, develop an effective maintenance plan. So this is the basic things that we need to have in our mind while designing the bridges of life over 200 years. Now, just one case study, that is Akashi Kyoto Bridge, which is in Japan. Of course, the keynote speaker did touch upon this bridge, but I'll go little in detail, and I'll try to take my 5-7 minutes to complete this. So this is Akashi Kyoto Bridge connecting the two islands of Kobe and Awaji in Japan. This is the longest suspension bridge. Okay, if you go to the history of this, the thinking of the bridge started in 1959, and it went up to 1998. See how much of thinking that it has gone into while investing that kind of money for this kind of a project. And to get you the feel of the geometry of this bridge, this is overall, this is across the Akashi Strait, which is around 4 kilometers wide, and it is a very busy strait. 1,400 ships movement is there. You can imagine that. Considering this huge ship movement, the central span is made 1,991 meters, approximately 2 kilometers, which is the longest suspension bridge as on today. And two sides, the spans are 960 and 960. And here, the road level is around 52.8, whereas the summit level, that is 96. See, you can see the profile, you can feel the profile of the bridge. It is not straight. Okay, the profile of the road is going like this in a curve manner. And to get a feel of the sizes, the tower height is 280 plus meters. Okay, and the foundation of the pier, that is P1 and P2, P3 call it as, they call it as A1. This is 2P, that is 3P, and that is 4A. It is 80 meter diameter and 70 meter depth. That is the kind of foundation that has been provided there. So is here also it is 85 meter diameter and 81 meter depth. And there, if you go that side from the the soil profile, you can see as you go towards that side, they are finding what is known as a granite, and they have appropriately designed with a lesser dimension for the foundation. I mean, you can, this is the anchorage. What I meant to say is the anchor, the end one. Okay, this is the foundation, side wall excavation, and this is the construction of the bottom slab concrete, roller compacted concrete. Look, they have used a special concrete which is highly workable and which is highly durable. And this is how the slurry infiltrated concrete is poured to protect that anchorage zone. You can see the picture here. This is the anchorage frame. Okay, to tell you, I'll go little into the cables later. And the total weight of the cable, okay, which is running around 4 kilometers, is 55,000 tons. Only I'm talking about the self weight. 55,000 metric ton is the self weight of this one. And it is being pulled. Okay, I'll give the, and that kind of a thrust is there. So you can feel the size of the foundation, the frame, which is required to resist that kind of a thing. So you can see approximately 232,600 cubic meter concrete used for foundation. Okay, and foundation is 80 meter diameter and 63.5 meter depth. And the next one is, this is the tower caisson. As I told you, the tower is around 280 plus meter. And this is also 80 meter diameter. And this is actually prefabricated the shore, and it is moved and sinking of the caisson. And you should also see here, they're also dropping the riprap cover protection. Okay, the steel caisson is with a high quality, high tensile strength steel, and they are also provided with anti-corrosive treatments like, okay. And you can feel when coming to this tower, the total height is 282.8 meters. Okay, this is the one, this one, and the total width is 35.5 meters. Okay, this is one, sorry. Okay, you can just compare the height here like this. See, this is, sorry. That is the Eiffel Tower, this is the Tokyo Tower, then our is Akashi Kaiko Tower. It is almost on par with the Eiffel Tower. In fact, I also showed you about the dropping of the rubbles, why it is required. They have carried out an extensive hydrological study, and they have found that this is the stream that is flowing like this. Okay, there is an eddy current around this foundation, which is susceptible to thus covering. So, to avoid this covering, they have dumped that kind of rubber, rubble material around the foundation to avoid this one. And this is the tower shaft. In plan, it is made up of 7 segments. It is not easy to say, transport entire this one. They have transported 7 segments. They have attached together, and that is in plan. In this one, elevation, they have done in a module of 3 meters. This is the schematic representation of the tower. This is the tower here. Okay. This is the tower foundation. Okay. This is the tower. And this is the superstructure here. This is the caisson, underwater current. This is what I told you, cover protection rubber. Okay. And I'll come to that later. The towers are transmitting 110,000 weight of the bridge. Not 1 or 2, 1 lakh ton. You can see the magnitude. And the towers are in cruciform cross section. See, when you saw the bridge, a suspension bridge shown by our friend Arvind, the shape was something really artistic. Here, they have gone for the stability. Here, to tell you, this bridge is in such an environment, corrosive environment, very heavy winds, and heavy seismic activity zone. To ensure the stability, they have done a lot of study. They selected this cruciform, this one, towers. This is what. And as I told you, to each tower, they have fixed 20 tuning dampers, and each tuning damper is weighing 10 tons. That is again to ensure the stability of such a massive tower and such a long suspension bridge against all these lateral forces. You can feel the size of the damping tuning dampers. See here, they have provided in 2 locations, one at one height, another at one height. It is all well conceived and well designed. This is the tower under erection. You can see the erection there. Okay, erection of diagonal. And coming to this, our superstructure. See, superstructure, you can see the height is 14 meters, and the width is 35.5 meters. Superstructure is actually this one only, our truss type only. They have done an extensive study. Okay, they have done all the wind analysis, everything, and they compared this with our regular box, and they found this is aerodynamically far superior, far stable. It is only after doing a detailed R&D, they have selected this superstructure with truss. And of course, Jacob Alji was telling, they have got 14 meters depth. They could have used even for a movement of load, some trains or something like that. Of course, there were some constraints on the project's cost, I was told. And this is how, they are all made in segments, these trusses. Okay, they are transported. Okay, these are all the hangers which are from the cable. And this is a wind tunnel test. And here actually there is one balancer is also there. This is the grating system is also there. The grating system, the balancer that is provided to the superstructure is adding to the stability of this superstructure. I'll take only another 3 minutes, sir. Please give me 3 minutes, sir.
Reduce it to 2.
Yes, sir. So, when it comes to the cable, I told you, I told 50,000, it is 50,500 metric ton. Here you have to understand, our strands are 7 ply. They are circular. And there will be a gap between the wires. That's what the professor, two professors were talking about that add to the corrosion. Here they have selected each cable with 290 strands. Each strand 127 wire made of high tensile galvanized steel. Total length of the wire is 3 lakh kilometer. Friends, please bear that is. Okay, the magnitude of this one. That is enough to go around the earth 7.5 times. Okay, and they have also corrosion resistant system developed for cables in which humidified air is run through the wires in cable, thus drawing out humidity. And as I told you, they're all hexagonal. It is not our 7 strands, this one. This is all hexagonal. Absolutely, there is no gap between the strands. Absolutely no gap. That is how they have taught to that highest level. And of course, this is how, because there is a straight here, and you have got movement of the ship, you can't this one. They have used the helicopter to take the this one, cables. I'll run through it fast. Erection of cable. Okay, this is what the cable is about. And this is installation. The installation of suspender. This is what we were talking about. This is to prevent the strand, because the cable is the most important system, the part of this bridge, because it is a cable suspension. You have to protect it. So what they have used, they have gone for anti-corrosion system for main cables using dry air injection. You can also see here that they have got a window for inspection. This is another view of that. Okay, they have an expansion joint, which is very important. If you don't provide that, there will be a distresses. It is a 4.8 meter long. And you see, this foldable type is there. It is with the finger type. Okay, it can move for a distance of 1.2 meter. It allows a movement of 1.2 meter. See, you please appreciate the detailing that has been done even for the expand joint. They have gone with the cast iron because it is very moldable and it is very durable. See, these are all the points. Of course, it has been studied for earthquake also. In fact, just after when it was about to complete the construction, a 7.2 meter scale of earthquake was hit. But even then, the movement of the tower is only 0.1 meter, and here it is only 0.8 meter. And all these movements are well within what was conceived during the design stage itself. And this is the beautiful view of this Akashi-Kaiko bridge. They have taken great care even to illuminate it. And coming to the coating, the painting, I'll tell you, they have done a lot of research. Okay, they have selected such paint so that they can repaint it only once in 40 years. Health monitoring, they have installed all these things have been told by our, this one, keynote speaker. Okay, prediction of optimal, all these. This is the magnetic wheeled, this one, inspection for robot for painting checking. And so this is the conclusion I would say. Akashi-Kaiko bridge with consideration of all critical forces design stage with recurrence of 200 years. Okay, selection and excellent health monitoring, and with preventive maintenance. This we have to understand. With preventive maintenance approach is extremely durable bridge with service life of over 200 years. Thank you.
Thank you, sir. It was an excellent presentation. We enjoyed a lot. Specifically, Nagesh sir's presentation was as if we were there at the site itself. It was quite enjoyable, sir. Thank you very much.
I think, Shrikant sir, Mr. Jayagopal wants to. Jay Prasad sir. Yes. Sir, he wants to.
Bani, Jayagopal. ಪುರಾಣ ಆಮೇಲೆ ಕೂತಿರ್ಲಿ ಜನ ಕೇಳಿಸ್ಕೊಳ್ಳಿ ಅಲ್ಲ ಸರ್ ನಾನು ಗೌಡ ಪಾಲಿಶ್ ಗೊತ್ತಿಲ್ಲ ನೇರವಾಗಿ ರಫ್ ಸ್ಟೋನ್ನಲ್ಲೇ ಟ್ರೀಟ್ ಮಾಡೋದು ಭಾಳ ಕಷ್ಟದಲ್ಲಿ ನಾವು ಈ ಕಾನ್ಫರೆನ್ಸ್ ನಡೆಸಿದ್ದೀವಿ. ಐ ರಿಡ್ ಔಟ್ ಥ್ಯಾಂಕ್ ಯು ಫಾರ್ ಯುವರ್ ಆಕ್ಟಿವ್ ಪಾರ್ಟಿಸಿಪೇಷನ್. ನಿಮಗೆ ಯಾರಿಗೂ ಅಂದೋರ್ಗೆ ಬರದೇ ಇರೋರಿಗೆ ಈಗಿರೋರಿಗೆ ಇದರ ಸಿಗ್ನಿಫಿಕೆನ್ಸ್ ಗೊತ್ತಿಲ್ಲ. ಇಲ್ಲಿ ಯು ಹ್ಯಾವ್ ಸ್ಪೀಕರ್ಸ್ ಫ್ರಮ್ US, Japan, Germany, and more so the chairman herself from Copenhagen, and then the president Subbarao. We are nearing the conclusion, and director decided to review the outcomes. ನಾನು ಹೇಳೋದು ಆಗಲೇ ಒಬ್ಬರು ಅಮೆರಿಕನ್ನವ್ರು ಹೇಳಿದರು, $1 ಯಾರ ಹತ್ರ ಈಸ್ಕೊಂಡು ಖರ್ಚು ಮಾಡಿದ್ರೆ ಅದಕ್ಕೆ ಲೆಕ್ಕ ಇರಬೇಕು. ಏನಿಲ್ಲ ನಮಗೆ. ಈಗ ಉದಾಹರಣೆಗೆ ಹೇಳ್ತೇವೆ, what we have collected for conducting this seminar. For every one of the delegates, we send 15,000 rupees to Delhi. You kindly consider. And virtually all the sponsors are renowned contractors who have actively participated in contribution. ನೀವ್ಯಾರು ಇನ್ಕಮ್ ಟ್ಯಾಕ್ಸ್ನವರಲ್ಲ, ಅದರಿಂದ ಐ ಆಮ್ ಟೆಲಿಂಗ್ ಯು ಡೈರೆಕ್ಟ್ಲಿ, ಸ್ಟ್ರೈಟ್ ಅವೇ, we have collected 35 lakhs for conducting this seminar. But unfortunately, what is the outcome? What is the outcome? When I see the bloody mobile, every alternative day there is seminar, virtual, that, this and all that. What have we learned from that? Whatever we have discussed so far, it is really, really encouraging. But also deplorable that the preachers throughout the world are coming down. I don't know what's wrong with that. Then the subjects, you know, that what we have done, what we have selected, I appreciate Jayagopal and his team because I was not always available. I appreciate them. And as far as you have been treated just like your home with tea twice, so on and so forth. The approach for the right bridge is the right design, and the chemical approach, which we have not heard 50 years back. 60 years back, when I joined service, bridges were already built across Netravati and being built across Sharavati was built and Kali was being built. ನಮಗೆ ಉಪ್ಪಿಂದ ಎಫೆಕ್ಟ್ ಆಗುತ್ತೆ, ಸಲ್ಫೇಟಿಂದ ಎಫೆಕ್ಟ್ ಆಗುತ್ತೆ, ಏನಿರಲಿಲ್ಲ. Even now, after 65, 70 years, they are standing. When I ask somebody, you know, during my time, we never quoted waterproof compound for the bloody sump tank because it was not leaking. Or overhead tank, now plastic bandide bidi. Then when I asked a chemical supplier for waterproofing, he said, sir, in those days, materials were good. I don't know, because none of us know the quality of cement. And straight away, we used to bring bag and pour it, and the structures are still standing. Whereas, even if you have to conduct us before using, then steel, we have brought down other type of steel. I was surprised. Stands for spacers. These spacers, generally, we were placing stones, aggregate. Then we moved to concrete. And then now they say they have a plastic spacer. Now one gentleman said, the spacers are also responsible for corrosion steel and the quality of steel. Just now the stainless steel has come to market, they have already grades of. I tell you, the whole market is cheating everybody. Why do you say best quality, top quality? Why top best quality? Are not your products, all the products top quality? You have second grade, first grade. When you go to a ready-made shirt, they have second. When you go to Bata company, they have second. Like that, has engineering come to that level? I don't understand. Then I tell you one thing. Nano agle that Mr. Paul repeated. Build a bridge and forget it. That should not happen. What I'm suggesting is, in one district or division or at least one town or say Bangalore or say Mysore or Dharwad, Hubli, Belgaum, you have one engineer from the department for money, the periodical checking. One more thing, nobody has seen the bottom of the deck. I have suggested my engineers, particularly in KRDs here and elsewhere, provide steps from the approach, just a stone step, to at least go and see the bottom. I tell you, I will request you, if any of you are from working in the field, please let me know how many have seen the bottom of the deck. So that I have suggested, even regarding the condition of the bridge, Honorable Supreme Court has passed a judgment and has listed out from the others which they have done. I am also thinking, not that I am partnering any consultant, why not make consultant to inspect the condition of the bridges periodically? We make a terms of reference, let us say. One thing, perhaps Professor just asked me, why these roads are getting spoiled? Sir, we have to have continuous job. If the road stays for 5 years unrepaired, where do I get work? If you build a 200 years lasting bridge, then there is no need of engineering colleges. Everybody will have to close. You have not thought of the other side of the coin. You are thinking, I make 200. What happens to the engineer? You will have to close the college. And you yourself will have no employment. You are stabbing yourself in the back.
200 years for selected bridges. 200 years for selected bridges, not for all the bridges.
Sir, do you know, today you said selected, tomorrow you say 100. Now another will say, you lay it down. All measured, every bridge above 60 meters length will stay for 200. We are not the bosses. And regarding consultants, what we saw in all these 2 days, we have the best of the cream of consultants in the country. I asked one of them, why you are shy of Karnataka? I don't know. There must be some reasoning, or there are plenty of work in their states. We want them to come down here. I was thinking, you have seen, heard of ISRO and all that, specialized in space research like that. All these cream of consultants, let them make a sort of organization wherein they are ready to help, wherein they will extend, not free, be paid. You have so many, why don't you look eye to eye and come out? Then the second thing is, why don't you make a type design like this? So you have, for 6 meters, these are the parameters that are to be satisfied. These are the qualities that are to be satisfied of material. Like that for major bridges also you can. If you standardize just checklist, why, I will tell you one thing. Everybody wants to be employed. Nobody wants to give a permanent solution. Why God has given some bloody life to us? Why not 200 years? God will run away. The last thing which my friends totally disagree, instead of going for RCC superstructure, PSC why not composite construction? I tell you, everybody is allergic. At least, even for rehabilitation, you showed so many cracks in the deck. Can you show so many cracks in the beams, girders? Still, you don't have so many. You just throw that girder and replace. I don't know why. I'm telling you, I'm a novice in pictures. Blindly, I follow. And then guidelines. My dear sir, what are the guidelines in IR? Guideline is a guide. You need not stick to it. ನಿಮ್ಮ ತಂದೆ ಹೇಳ್ತಾರೆ 9 ಗಂಟೆ ಒಳಗೆ ಮನೆಗೆ ಬಾ ಅಂತ 9 ಗಂಟೆಗೆ ಹೋಗದೆ ಇದ್ರೆ ತಪ್ಪಾಗತ್ತಾ ಕಾರಣ ಇರ್ತದೆ ನನಗೂ ಅದೇ ಗೊತ್ತಿದೆ I tell you, all these repairs I compare with malignancy. I am sure that you know the word. I mean the meaning of malignancy. Once it occurs, it takes your life. You cannot restore, you cannot repair. It is an eyewash. Luckily, many have been repaired. We ourselves, myself, BRS and Mr. Jayagopal have joined and repaired a 160-year-old bridge and got a medal also for that. Right? Then we are cheating ourselves. That's I'm sure. Cheating in design, cheating in quality, including contractors, everybody are cheating the government. It is cheating the government, it's like cheating our parents. That's what we are doing. Then I will tell you, Karwar port in the very Karwar Sea, Kalibri Sea, it is still there. Nagenza no city was with me when we did port. It is nearly 70 years. Nothing has happened. When you can win, that means it is equivalent to your 140 years. Right? So, what I cannot understand your love for Japan. All the three of you, Japan. You also. He also.
Finland, sir.
Huh?
Finland.
Are yaar chodo. Why this Kesha love? Anyway, I thank you, but kindly understand the labor behind any work. We have begged for fund to arrange, but what have we got? At least attendance, at least 70% attendance. I need to go and beg, please come, please come. It is not my daughter's marriage. So finally, we decided to have half-day sort of workshop or what you call blow your mind or blast your mind on individual subject by the consultants. I'm sure that the consultants will cooperate with us, especially K-Ride, BMRCL is almost in the last stages. K-Ride is badly we need, and PWD. I cannot understand one thing, sir. Every 30 meters you gone putting pier. After having worked for 100 years, 50 years as consultant, still 30 meters span. क्या पाल जी हैं? क्या मुसीबत है? Very unfortunate. Thank you for your patient hearing and your cooperation in making this a success. Thank you.
Thank you, sir, for those words of, I would rather say, stemming from huge decades of experience, wisdom, and more importantly, ethical and responsible approach to anything that we do as civil engineers. Thank you so very much, sir. Please, let's give him a good, big hand. And I think perhaps the takeaway is that we need to really mean business with respect to delivering on ground in the most honest and professional way possible. Thank you.
Yes, please, sir. Sir, Jai Prasad, sir. One question, sir. Arvind Salecha explained about 3D, no drawings, straight away execution. Can we take up some pilot projects? You are into so many departments, at least 2 departments, at least pilot, so that no drawings, straight away you can take it up, and whatever help required, certainly, the software company people are there, we can call them and get it depends on how you agree for that. Yeah, no physical drawings. Yeah, BIM modeling. And no 2D also. No, it is 3D. Yeah, complete 3D. No, why not we try once or twice, whatever difficulties we come across. So automatically you are in the next level. So just it is a suggestion. And in case, you can just think over about it, sir. Aye, sir. Aye, sir. Okay, sir. Aye, sir. Okay.
₹1 ಖರ್ಚು ಮಾಡಿದ್ರೆ ಅದರಿಂದ ಏನು ಲಾಭ? ₹1 ಮೇಲ್ಬೇಡ, ₹1ಗೆ ಏನಾದರೂ ಒಂದು ರಿಟರ್ನು. ನನಗೆ ಗೊತ್ತಿದೆ, ಇದು ಎರಡನೇದು ಇದೇ ಥರ ಮಾಡ್ತಾ ಇರೋದು.
ಅದು ನಾನು ಕನ್ಕ್ಲೂಡ್ ಮಾಡಿ ಹಿಂಗೆ ಅವ್ರು ಕೂತಿದ್ದಾಗ ಕನ್ಕ್ಲೂಡ್ ಮಾಡಿ ನೀವು ಮಾಡ್ಬಿಡಿ ಸರ್, ನೀವು ಹೇಳ್ಬಿಡಿ ಕನ್ಕ್ಲೂಡ್ ಮಾಡ್ತೀವಿ ಅಂತ ಹೇಳ್ಬಿಡಿ.
Yes. That was the next son. Now, may I request that the esteemed chair, co-chair, and our speakers come onto the center stage, and may I request our Jayagopal sir to do the honoring. Burji sir, please join, so that we can honor our erudite speakers, the chair and the co-chair, please. Thank you. So, Bani sir, please.
ಅರವಿಂದ್ ಕೊಡಲಿಲ್ಲ ಅಲ್ಲ.
friend, we are very thankful to our engineer Girish. We have been coordinating last 2 days and we have been monitoring and excellent way. Thank you, Girish.
Jai Prasad,
On
sir.
behalf of all of us, we thank you very much. And we keep seeing you like this for our future programs also.
ನಾನು ವಾಯ್ ಜ್ವರ ಇದೆ.
Sir.
ಹಾಂ ಮುಗಿತಾ ಇದೆ ಇವಾಗ ಎಲ್ಲ ಇದೆ ನೀವು ಹೊಡ್ಬೋದು ಮೇಡಮ್ ಇನ್ನೂ ಅದೇ ಹಾಂ ಸರ್ವಿಸ್ ಹೇಳಬೇಕು ಬನ್ನಿ ನನಗೆ
ಸರ್
ಹೇಳ್ಬಿಡಿ ನೀವು ಹೋಗ್ಬಿಟ್ಟು
We have we have prepared a resolution after going through the proceedings across these 2 days of international conference. ING-IABSE has made it, so we will go through it once again and we'll pass the resolution shortly so that it reaches those to whom it has to reach. Thank you. Now may I request Engineer Jay Gopal sir to please address the gathering and propose the vote of thanks. Thank you.
Thank you, Mr. Girish.
ಹೆಸರುಗಳು ಹೇಳ್ಕೊಂಡು ಹೋಗ್ಬಿಡಿ ಹೇಳಿ
My thanks to KRDCL entire team, including the Chief Engineer, SC, Managing Director, who was present here also for providing this fantastic venue. And we could carry out with the 2 days program very nicely, very neatly. Thanks for the entire KRDCL team. All speakers were all selected. They were all cream and the best in this part of the world. And now all of them have majority of them left, and we have Mr. Narayan Pal, NC Pal is here. They're all actually, when we see at the Indian Roads Congress or some seminars, you can see their caliber, extremely high caliber, and very well dedicated to the country. Majority of them, whomsoever I've seen on the dais for all the 2 days, unmatched they are. Thanks for all the speakers, including the international speakers from US, Japan, Morocco, and US, Copenhagen, our president. No, we are very much grateful to her because she came online, she appreciated. In fact, I had called her when I was in Tokyo that we might call you in physical, you may have to come down to India. Then she said, okay, definitely I will come down, just call me and I will attend your seminar. That's what she told. But since, because of the time, we are forced to go for the VC. It went on very well. In fact, even the present president, actually the present president-elect, when I told Jayaprakash sir about his selection being the son of TN Subbrao, he was so happy. He said that, no, we'll fix up some program here, call the gentleman. He's an Indian and the first Indian to get selected in such a huge, technically that is a very, very strong organization, IABSE, like FIB and IABSE, they're all equal from the Switzerland. Then when he told we should get him somehow, so last time in Tokyo, I just discussed with him, we may call you anytime. Then he said, okay, call me anytime, I am there with you people. And she was also there, our present IABSE president. She also agreed totally. And somehow I am surprised because these people will be international, they will always be very busy and they will not be able to give their time whenever we ask. They may not give. But suddenly it exactly matched so that they made their time, especially when this gentleman, our president-elect, he was there for almost a full day and giving so much of information when he was in the principal keynote speaker. Now, our thanks to all the speakers outside, inside India, and the keynote, everybody. And we could learn huge thing yesterday and today. One day after day, it was more concentrated and more appreciated, and we could learn a lot. Our engineers learned a lot. We never say that we are the ultimate, we know fully well. To be frank, we do not know a fraction of one also. So we learned a lot, our engineers learned a lot, whomsoever present here, not present here, they have lost a lot. Then engineers of KRDCL, Public Works Department, civil consultants, delegates, thank you all. K-Ride, you all attended this, including railways, some were there, railways. Thank you very much. If you have learned something, all the 2 days, we are thankful for the entire organization. Then we have sponsors. Thank you all sponsors. Without you, this program was not possible. I would like to read out, and these contractors, agencies, kindly come down here and collect
ಯಾರಿದ್ದಾರೆ ಬಂದಿದ್ದಾರೆ? ರಾಮಕೃಷ್ಣ ಎಲ್ಲೋದ ಕರ್ಜನ್ನೊಳಗೆ ಏನು ಮಾಡ್ತಾನೆ?
Yeah, sponsors, we have KMV Constructions. If they are there, please come down and collect representatives. Dasari Taranath, then BSR Construction, if somebody is there, or we'll keep it outside. Then,
NCC,
sir, Star Infra. Then BSR, ಅಲ್ಲಿ ಇಟ್ಬಿಡೋಣ, we'll take. Then thank you for the Star Infra. Then AICPL, please kindly come down and collect your memento and other things from here. And we also have some engineers who contributed from the Karnataka Housing Board. We have, even though Mr. Prem Reddy is not present, sir, day for yesterday, Mr. Prem Reddy called me. He is in some urgent meeting in Hyderabad. He said that he himself is a member actually in the Karnataka Center of ING-IABSE. He said that whatever help required, whatever, we are there with you totally, and you ask anything, we will give you. Then there is one more, sir, there is one more Vasant contractor from Rajiv Gandhi Housing. Now we should thank him also.
Rajiv Gandhi as well as Health Department.
Health Department. So we thank all. Varun, yes sir. And we thank each and everybody who was responsible in contributions. Then we have stalls, some people are here. We have JSC stainless steel, JSL stainless steel. Kindly come down.
And then glass fiber.
And we have ASR steel, concrete additives. Then Star idara kodi. And sir, ನೀವು ಕೊಡಿ. ಅಲ್ಲ, one by one.
Stainless steel man, they have included in the SR. I hope it will not let us down. You are the businessman. Star Infra. Star.
Star Infra.
Next year.
ARS Steels. Then we have the CAC concrete additive chemicals. Concrete additives. And we are thankful to the audiovisual team who were responsible for the audiovisuals. Narayan and team. Audio visuals.
ಸಂಗೀತ ಡ್ಯಾನ್ಸ್
ಅವರು ಇದ್ದಾರೆ ನಾಟ್ಯ ತರಂಗ ಡ್ಯಾನ್ಸ್ ಗ್ರೂಪ್ ಅವ್ರಿಗೆ ನೆನ್ನೆ ಕೊಟ್ಟಿದ್ವಿ ಬಟ್ ಹೇಳ್ತೀವಿ ಫಾರ್ಮಲ್
ಕೇಟ್ರಿಂಗ್ ನೋಡ್ಕೊಡಿಯಪ್ಪ
Then many thanks to the dance troupe yesterday, Natya Taranga by Veena Gangadhar, entire choreographed everything by our member, Mr. Mohan. It was fantastic, and many of you, whomsoever not attended, they missed it.
Different world.
Yes, all together. Then we are also thanking the catering agency here who took. Who looked after our tea, coffee, the working lunch and all. We are thankful for him. Then the support staff of KRDCL auditorium, and the security staff of the KRDCL, of course, we'll thank them there when we go out there. And then we are very much thankful for the support given by the staff of Chetana Consultants of Arvind Salecha and our Nagesh Consultants and Structure Tech Research Laboratories Private Limited. And last and the least, Mr. Girish, he helped us so much. Girish. He helped us so much in the MC here, and many times MC will become a bridge between the audience and the speakers here. So, and of course, we are also talking about the bridges now. See, Girish holds a good example for that. Sir, kindly,
you left out one thing.
Yes, sir.
Your own. Actually, from all of you, from all of us, we thank Mr. Jai Gopal for the very initiation. He was the man who brought the Karnataka Center, and we all nurtured it. If Jai Gopal had not initiated today's and yesterday's seminar, I would not have bothered. I would have been happy and slept peacefully. I thank Mr. Jai Gopal and his trusted staff, all these ladies and
Part of the team, sir.
Participated in all levels, whether catering or receiving or reception, you name it, they took.
Sir, may I request the Chief Engineer of KRDCL also to please grace the stage, please. Kindly do come, sir.
The best thing was it's live streaming.
Wait.
Thank you to this whole team because all the bags and souvenirs and books we got at midnight. Okay. Tuesday midnight we got it and Wednesday morning we started this. So all the bags we had to fill in with all the mementos, souvenirs and all. Thank you so much.
जय हो जय हो जय हो जय हो भारत माता की जय माता की जय
Can we have the national anthem, please? I request all of you, please raise from your seat for our national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे